Hi guys, my name is Bappy Ahmed and you are welcome to my YouTube channel. So guys, as you know, I have started a complete Agentic AI playlist on my YouTube channel, and so far we have completed so many important topic in this playlist. So if I show you my playlist guys, as you can see, I started from introduction. I have already discussed about the evaluation from LLM to Agentic AI, how Agentic AI came. We already understood about the entire Agentic AI concept, how agentic system works. Then I told you about asynchronous programming, Pydantic. Okay, we also saw how we can implement AI agents with the help of LangChain. Okay, then we started our first orchestration framework for AI agents implementation, which is LangGraph. Even we also understood this LangGraph, each and every component in detail with the code implementation as well. Now what I am planning for guys, I'm planning for the practical development of project. So what I'm going to do, I'm going to start implementing a agentic chatbot from this video onward. So first of all, let's try to understand each and every component in detail. We'll try to explain the things in detail, because if you want to create a agentic chatbot, so for this you need lots of component, like you need tools, you need memory, you need persistence, you need streaming, you need user interface. Okay, there are so many things you have to implement independently, then you will be combining them all together, then one agentic chatbot would be ready. Okay, and if you found my content useful guys, please try to subscribe to my channel and hit the like, and please try to share it with your friends and family. So first of all, let's try to understand in this agentic chatbot whatever component we're gonna implement. So guys, first of all, let's discuss our plan, like how we'll be implementing this entire agentic chatbot. So the entire agentic chatbot I'll be implementing with the help of LangGraph. Okay, we'll be using LangGraph orchestration framework to implement the entire agentic chatbot, because this project is the part of our LangGraph orchestration framework in our playlist. So in this video, first of all, I'm going to create a simple chatbot workflow. Okay, we'll try to create a simple chatbot workflow. Then we'll try to make this agentic chatbot like more advanced. We'll try to add some more advanced component in this particular agentic chatbot, and with the help of that we'll be learning all of the LangGraph code component. Okay, so whenever let's say you want to implement this kinds of project, whatever component you need from the LangGraph, you will be understanding each and every component. Okay, so that's why I made this particular implementation like a series. Okay, series of video. So next, in the next video, I'm going to show you the persistence concept, like what is persistent. Okay, persistence, and why it is required, why persistence we have to add inside our agentic chatbot. We'll try to understand. So persistence in LangGraph. Okay, then we'll try to understand um, how to add streaming feature. Okay, streaming feature to our chatbot. Then we'll try to understand the concept of um, resume chat. Okay, how we can resume any kinds of chat inside our chatbot. Then we'll try to see the database integration. Okay, integration in our chatbot. Then we'll try to see how we can implement user interface. Okay, let's say chatbot UI. Okay, we'll try to also implement this. Then after that, I will also show you how to add the tools. Okay, tools in LangGraph. Then we'll try to understand um, the observability. Okay, observability. So in observability, we'll try to see how we can integrate LangSmith, okay, LangSmith to our agent. So I think you have already heard of about LangSmith. LangSmith is a observability tool. With the help of that, we can monitor the entire application. Okay, what is the flow of the application, when it is executing, what component, each and everything we can track. Okay, in this particular LangSmith, we'll also try to see how we can use the LangSmith here. Then after that, we'll see the um, RG concept. Okay, how we can integrate the RAG features inside our agentic chatbot, because if you have already used this kinds of agentic system, you know that it will also work with your documents. That's you can upload your documents and you can do the chat operation on top of your entire documents. Okay, this is called RAG concept. So the RAG means Retrieval-Augmented Generation. So we'll also try to understand this thing. Then we'll understand this HITL, that means human in loop concept. Then we'll also understand the short term, okay, short term and long term memory concept as well. Okay, memory. So yes, this is the entire plan, guys. So in this video, first of all, let's try to implement the simple chat bot workflow with the help of LangGraph. Then from the next video onward, I'm going to discuss these are the concept as well. So guys, let's try to implement our chatbot workflow. So if you want to implement any kinds of agentic chatbot, first of all, you have to implement the chatbot workflow. And how chatbot workflow works, I think you already know that. So let's say if I want to implement with help of LangGraph, so how many node I have to take? I have to take only one node, which would be chat node. So here user will pass a message, okay, any kinds of message, and it will go to the chat node, and chat node will try to return something. Okay, so this is a simple chat operations we'll be doing here. And to run this particular graph, actually we need a state. And for this particular chatbot, what would be the important state? Important state would be the message. Okay, let's say the message user is passing, let's say, hi, my name is Bappy. So this message should be saved, right? And let's say your bot has replied, welcome Bappy, okay, and how I can help you today. So these kinds of messages would be also saved inside this particular state, right? So for this, what I have done, guys, I have taken this this particular state, and here we are using the reducer concept. Okay, here we'll be using the reducer concept. Otherwise, what will happen? Every time this state would be replaced with the new message. So I don't want that. I want to save all of the conversation story inside this particular state. Okay, and now you can ask me why we haven't taken string type data here, because message is a string type data. Because I already told you here, this is a conversational story, and in LangGraph, actually this is recommended whenever you are creating this kinds of chatbot, you have to take this function. This is a like LangGraph function we have to import from the LangGraph called add messages. In basically this add messages will try to handle this kinds of scenario. It will take all of the conversation story, the user message as well as the replied message, and it will store in this particular state. Okay, and this state will go to the chat node. I hope you clear. Okay, so once we have built this workflow, the simple chatbot workflow, then we'll try to make it more advanced. We'll try to make this particular workflow as agentic chatbot workflow. Okay, so for this, what we'll try to add, guys, we'll try to add, see, as of now in this particular workflow, you can perform the simple chat operation. In this workflow, you can perform simple chat operation. Okay, after that, we'll try to add the RAG functionality. That means even you can also upload any kinds of documents, and you can perform the chat operation on top of that. Okay, you can add extra knowledge base on this particular chatbot, right? Then we'll add the tools. Okay, real-time tools we'll try to add, so that if you are asking any kinds of question, and if it needs any kinds of tool, it will try to use that. Okay, and that time actually it will become agentic chatbot. That means it doesn't only have the the existing knowledge base, it has also connection with lots of tools. Okay, so that whenever you are asking something, it will real time fetch those informations and it will give it to you. Then I will also add the user interface, because user needs a user interface to use this particular chatbot. So definitely we'll try to create the UI. And for UI implementation, as of now, I'll be using Streamlit package. It's a Python package. And here you don't need to write any kinds of HTML and CSS code. But later on, also going to show you how we can use HTML and CSS code, how we can use the fast API. Okay. With the help of that, we'll try to create the entire agentic chatbot. But as of now, we are learning. Okay. This is our first project. So that's why I'll be using Streamlit so that everyone can implement with me. Okay. Then we'll also try to add the observability tool, which is LangSmith. Okay, LangSmith will try to add. So with the help of that, we'll try to monitor the entire chatbot. Okay, like how it is performing, which particular component is triggering, each and everything we'll try to log in the LangSmith dashboard. Then we'll also learn some advanced topic as well. Okay, inside advanced topic, we'll be learning memory concept. Okay, short term and long term memory concept we'll try to learn. Um, okay, I missed out one thing, which is persistence. Okay, here we'll also try to learn this persistence. Okay, we'll also try to add the persistence in the chatbot. Then we'll be learning the memory, the advanced topic. Then we'll also try to learn this HITL, human in the loop. Okay, then here also we'll try to learn the retry functionality, like how we can perform the retry functionality and all. So these are the things we'll try to cover. That means by this particular project itself, we'll try to master, okay, all of these LangGraph concept in detail. Okay, that's why I made this particular implementation as a series, so that each of the video will cover each of this concept in a detailed way. Okay, so yes guys, this is the plan. I think you got it now. We already have the graph. Okay, we already have the workflow architecture. Now based on this architecture, now let's try to implement our chatbot. Okay, first of all, we'll try to create this simple chatbot workflow in this particular video. Then from the next video onward, I'm going to discuss one by one all of these advanced component. So first of all, let's try to create a Jupyter notebook file because initially I want to show you this workflow in the Jupyter notebook. Then I'm going to just write everything in the .py file, okay, Python scripting file, because Jupyter notebook file we won't be using whenever we'll be creating the project, okay. But for experiment purpose, we'll be using this Jupyter notebook. So here, let's try to create a file .ipynb. Yeah, so previously I had my environment, which is this LangGraph test. I'll try to select this one, and here we'll try to import all the necessary library we need. And this import would be common, guys. I think you know that. What is this import? Let's import everything. So these are the import we need. We are importing this state graph, start, end. Then from typing, we are importing type dict, annotated. Then we are also importing this base message and human message. And we will be using OpenAI large language model. That's why from LangChain, we are importing chat OpenAI. You can also use any other large language model provider like Grok. You can also use OpenRouter, Gemini, okay? Anything you can use. Only you just need to check the LangChain documentation, how to import that, okay? Even you can also copy this code, and if you give to the chat GPT, this will replace with another model. But I have my OpenAI API key. That's why I'll be using OpenAI model here. So let's import all of the package. Okay, it's done. Now the next thing, guys, what you have to do, you have to get this OpenAI API key. So quickly, I'm going to move my .env file from my previous code. So guys, as you can see, this is my .env file. Inside that, I'm going to simply copy my OpenAI environment, OpenAI API key. So this is my OpenAI API key. I already collected. Now let's try to write the further code. Yeah. So now what I'm going to do, guys, first of all, here um, I'm going to initialize the LLM. So here I'm initializing the LLM. Okay. So we'll be taking the default large language model. Okay. Here I'm getting an error because I have to load this environment variable, right? So let's load it. So from .env. Okay. .env import load env. Then after that, we'll try to load this environment variable. Then now this code will work. Yeah, now we are able to load our LLM. Now, first of all, you have to define the state. So let's try to define the state. This is the state, guys. And I already told you, if you are storing conversational story, that time you can use this function add messages from LangGraph graph message. Okay. So here we are using the reducer concept. I think you know what is the reducer function, like operation.add previously we used. But right now, this is a conversational story. So we'll be using this add message, and by default, actually it will perform this adding operation instead of replacing. Okay. And here I given the base message. Base message means, see, inside base message, what happens? We are telling this is a chat history. Chat history means there will be user message as well, and there would be AI reply as well. Okay, so if you combine all of them together, this will become a base message. Okay, so this is why we are using the base message here. So this is going to be my state. Now let's try to define the state. So after that, we'll try to create the graph. Now let's create the graph. So this is our graph, guys, state graph, and we have given the state to the graph. Now after that, we'll try to add the nodes. So let's comment here, add nodes. So if you see, we only have one nodes, which is chat nodes. Okay, let's try to add that. So graph.add chat node, and this function we have to write separately. So let's try to write this function. I'm going to create a function def chat node, and this will take this state, but I'm not going to return all of this state altogether. Instead of that, simply I'm going to only return the update message. Okay, so first of all, here we'll be taking the user query from the state. Okay, take the user query from the state. Yeah, so user will give the message, right? User will give the message. So this message I'll be basically this will store as a message. Okay, so this message I'm extracting. Then after that, we'll try to send it to the LLM. Okay, send it to the LLM. You can see LLM.invoke. We are giving the message and we are getting the response. Okay, now this response I'm going to store in the message again. Okay, response stored in the state. That means in the message keyword, because this is a list type. Okay, and every time it will store your user message as well as the response. Okay, altogether it will store, and we are returning the state. So this is going to be my chat node. As you can see, this is going to be my chat node. So once this chat node is prepared, now let's try to add the edges. Okay, now if you see the edge connection, first of all, start will be connected to the chat node. So let's try to add the edges. Add edges. So start would be connected to the chat node, and chat node would be connected to the end. Chat node would be connected to the end. Okay, so this is the simple like edge connection. After that, we'll try to compile the graph. Let's compile the graph. We have here will be compiling a graph. Okay, now let's compile. Yeah, done. Now if you want to see the workflow, so this is the chatbot workflow. Okay, this is the simple chatbot workflow we have created like that. Okay, now here you can perform the simple chat operation. So this simple chat operation you can perform as of now. Now let me show you how we can perform the chat operation. Now let's give the initial state. So this is our initial state, guys. As you can see, we are using human message because this is a human prompt, and for this we have already imported this human message. It's good to use this function whenever you are implementing this kinds of chatbot. So as you can see, message this should be a dictionary. We are giving the message, and you can see it takes as a list. Okay, as you can see, it takes as a list. Okay, input. So that's why we are giving as a list. Now we are giving the human message, and this is the content. What is the object oriented programming? So this thing I will try to pass to my chatbot. Okay, so chatbot.invoke, we are giving the initial state and this will return you. Let me show you if I don't give this line. Yeah, so this will give you this kinds of response. So maybe I can store inside a variable response is equal to chatbot.invoke. Now if I show you the response, so this is the response. Inside the response you have two things. Here one you have the message, okay, the human message, and another one is the AI message. Okay, now I have to extract this AI message. For this this is a dictionary. First of all I have to extract the message. Okay, message keyword, this message key I have to extract. Once we got the extract, now this is a list and here we have two items. Okay, one is the human message and one is the AI message, and that's how this add message stores your data right inside this list. Now I need the last one, so for this I give -1. Okay, the last index AI message. Now I only need the content, so here simply I'll just give dot content. Okay, if you do it, now you will be able to get this content, guys. Very simple. Okay, so that's how, guys, you can perform any kinds of chat operation right now with this particular workflow. Now let's say I will ask another question. What is let's say object-oriented programming in Python? Now see, object-oriented programming in Python, blah, blah, blah. Okay, it's working perfectly. Okay, so guys, now what I'm going to do, I'm going to just make a loop so that user can continuously give the input and this chatbot will be working. Okay, it will provide the output. Because right now, every time I have to change the message here and I have to re-execute the cell, but I don't want that. I want a loop. Okay, so for this, what I can do, guys, I can just make a while loop. So this is our while loop. Okay, so here we are taking an input from the user. I'm just telling type here some message. Then we are printing this user message. Then I'm checking if user message, let's say if it is if they write like say exit, quit, and buy, so that time I'm going to break the loop. Okay, otherwise I'm going to simply invoke my LLM. So let's do that. So we'll be invoking our LLM here. That means the workflow. So as you can see, we are doing the same thing. We are just hitting this chatbot invoke. We are giving the message, human message. Right now the content should be is equal to the user message. Okay, because previously I hard coded this message, but right now I'm taking as a variable, input variable. Once it is done, I'm going to print this response in the terminal. Okay, we'll be printing this message in the terminal. That's it. Now let's execute. Okay, now let's execute this while loop. Now here I can give the message hi. Now see, user given hi and it's telling hello, how I can assist you today. I'll tell my name is Bappy. Okay, hello Bappy, nice to meet you, how I can assist you. I'll tell what is Python. See, it's working fine. Okay, but one issue I want to show you in this particular chatbot. Let's say now if I ask what is my name, now it will tell you, I'm sorry, I'm not able to access the personal information about the user. But although if you see, every time we are saving this information to this state and we are passing this state to the to this node. Okay, if I open my diagram, I think you see that. So every time what is happening, whatever message user is giving, I'm storing in this state, and whatever response also I'm getting, I'm also storing in this particular state, and we are passing the state to the chat node. So chat node should have the informations, okay, about the older conversation, because we are storing the conversation story. But still, why it is not able to give you the answer? Okay, still why it is not able to give you the answer? This is a question to you. Just try to think about and please reply in the comment. If you can pause the video and you can reply in the comment. Okay, why it is happening like that? See, if I tell you, see what is happening. If you're using the state concept, right? If you're using the state concept, so what will happen? First of all, let's say it will start this node, then the input will go to the chat nodes. Okay. Then chat node will return some kinds of response, then it will go to the end. Okay. So once it is reaching to the end, right? Once it is reaching to the end, that time this execution is ending. Okay, this execution is ending. That means whatever you have in the chat state, okay, that means in the state, this particular data would be erased. Okay, this particular data would be erased. So that time, whenever you are running this loop, right, you are running this loop, so every time what you are doing, you are invoking the chatbot, you are invoking the workflow, and whenever you are invoking the workflow, that means what is happening, you are re-executing from here. Okay, you are re-executing from here. That means again it will go to the chat node to the end, again this data would be erased. Okay, so every time this particular list will be erased. Okay, it is not able to, like, let's say, store the older conversation. It will only store in this particular session only one session. Let's say right now this loop is running, right? In this particular session this information is available, but whenever we are again executing, this loop is again executing from here, that time this information is getting erased. This is the problem. Okay, now how we can handle this kinds of scenario? We can handle this kinds of scenario with the help of persistence. Okay, I think I already told you about persistence, right? Now we'll be using persistence concept, and we can actually handle this kinds of scenario. That means whatever conversation story we are, let's say, having, okay, so we can store somewhere this conversation story, because right now this is only storing inside the variable, and once it is getting initialized again, this variable is getting cleared. Okay, this is the main problem. So that's why LangGraph supports actually persistence concept. So inside persistence, either you can save this informations in the memory saver, that means inside your RAM, either you can save this particular informations in the database, and you can load anytime. Okay, these kinds of things you can perform. Now let's try to see how we can do these kinds of persistence operation. So for this, I'm going to open up my code again. Okay, so here simply I can exit my bot. So for this, you have to give this exit message. Sorry, this exit message only. Done. Now see, it has exited. Now see, persistence concept I'm going to explain in detail in the next video. So only I'm just going to add this persistence, let's say, implementation here, how we can add the persistence. So inside persistence, basically we just try to add a memory here. Okay, we just try to add a checkpoint memory. So what happens, let's say the entire state we are having, right? This entire state we are having. So this entire state we can save inside a memory. Either you can save inside your RAM. Okay, this memory you can say, this state you can save inside your RAM. Either you can save inside the database. Okay, but right now this particular state is not getting saved anywhere. This is only storing the data in the variable. And you know, whenever code will re-execute, this variable would be clear that time, right? We already know that. If you understand the Python concept, you already know that. So somehow we have to store this state inside a storage actually, let's say, service. Either you can use your RAM, because you know that RAM would be the temporary storage. It's completely fine. But if you want a permanent storage, that time you can use any kinds of database. This database part I will also show you in future. But I told you I'll be going step by step so that I can explain each and every concept in detail. So initially we'll try to see how we can save this information in the RAM. So whenever we'll save inside the RAM, so what will happen? This particular data would be saved unless and until I don't restart my kernel. Okay, if I restart my kernel, that time this information would be cleaned up. Otherwise, this information will remain same inside my RAM. Okay, so this kinds of concept we'll try to add right now. So here, for this, I'm going to import a function from LangGraph. So inside LangGraph, there is a function called memory saver. Let me import that. So this is the function langgraph.checkpoint.memory import memory saver. Okay, so this memory saver stores your state inside the memory, inside the RAM. you can also use any kinds of database. That part I will also show you later on. Okay, first of all, let's try to see the memory saver one. Now let me import. Okay, so once it is done, now simply here, whenever you are defining the graph, so before the graph initialization, you have to define a checkpoint. This checkpoint should be the memory saver. Okay, so this is going to be this is going to become your memory saver object. Okay, checkpoint. Now whenever you are compiling your entire graph, that time you have to mention I have a checkpointer. Okay, I have a checkpointer. So this checkpointer will basically store your state in the RAM. Okay, you can see checkpointer is equal to checkpoint, and here we are using memory saver. Memory saver means the RAM. That means whatever state it is getting, right? The chat state, that means the entire state it is getting, and every time it is updating, right, with the user message and the reply of the AI message, right? Every time it is getting update. So this information will save in the RAM right now. Okay, because we are using the checkpointer right now. Okay, now let's try to compile the graph. So one compilation is done. Now let me show you. Now let's say I don't need to execute this code. I will directly execute my while loop. Okay, yeah, but before executing the while loop, here I will pass one thing. Here you can specify the thread. Okay, thread means it should be like kinds of unique ID for each of the user. Let's say this chatbot can use many people, right? This chatbot can use by me, then this chatbot can be used by any other person. So all of the people can chat together here, right? And if they're chatting together, it's not like that. Let's say I will let the people to chat with my chat history, right? So instead of that, what it should have a different thread ID. Okay, different thread ID. Different thread ID means, let's say if this thread ID is equal to 1, I have said, let's say thread ID is equal to 1. That means this is my thread ID. So whatever chat I will perform, it will store all of the information in this particular thread, right? In this particular, let's say whenever it will store inside the memory, right? Because I use the memory saver. So in the memory, it will create a separate section for one. Okay, and all of the information, all of the chat history, it will save inside this particular thread. Okay, now if I change it to 2, right? That time another user will come and he will perform the chat operation. That means what is happening in the memory, there are different block is getting created. Let's say this is thread 1, this is thread 2. Okay, whatever chat I'm performing in the thread 1, thread 2 person won't be able to see that. Okay, he won't be able to access this information. And whatever, let's say chat thread 2 is doing, thread 1 won't be able to see or get this particular information. Okay, like the chat GPT, like chat GPT is having different thread, right? Whenever, let's say you just create a new chat, right? In the chat GPT, whenever you create a new chat, let me show you. So here, so this is my chat GPT. So let's say here you can create a new chat, right? You can create a new chat and you can perform some chat operation here, right? So this becomes a thread, right? Then whenever you text another new chat, that means the complete new thread will be getting here and you can perform the another chat operation here. Okay, so that means you won't be able to get the previous let's say thread information in this particular thread, but you can switch to the thread. Okay, let's say you can switch to the threads anytime. You can go to the previous thread, you can go to the current thread. Okay, that's how we can switch. So these kinds of things also we can perform with the help of this persistence. Okay, we can make different threads here. Now let's try to do that. Let me show you. I think after seeing the practical implementation, you will be able to understand. Now let's say I'll make it as thread ID. Initially, I'll give it as 1. And whenever you are using this persistence concept, that time you have to define a configuration. So this is the configuration. Before response, maybe I can create it. So this is the configuration. Config is equal to configurable. And here you have to pass this thread ID is equal to thread ID. So your thread ID. Okay, then this should be a dictionary. Okay, dictionary object. And this config you have to pass whenever you are invoking the workflow. So here at the last, you have to give this config. You have to give this config. Config is equal to config. Okay. Now what will happen every time this this persistence, what it will do, it will try to load the information, load the state from the memory, and it will try to pass to the um, um, invoke function. Invoke function means you are giving the user message as well as the older history. Okay, user message as well as the older history. That means whatever older history you are having, whatever chat state you are having, you are entirely passing the chat history as well as the new message user is giving. Okay, now, right now it won't be replacing because we are storing in the memory, and every time we are loading it and passing it to the invoke function. Now see, if I execute the code, now let's say here I'll tell my name is Bappy. Okay, now let's say I'll give another message, what is Python. Done. Now if I ask, let's say, what is my name? Now see, your name is Bappy. It is able to remember right now. Okay, it has some kinds of memory right now, and this information is saving inside my RAM because we are using memory saver here, and this is called persistence. Okay, this is called persistence. Now if I, let's say, give another thread. Okay, let's see if I give another thread. Let's see if I do exit right now. One thing I want to show you, if I run it inside my while loop, so if I exit my while loop, so that time your entire session will be restarted. So instead of that, maybe I can use this code. I'll copy this thread ID here. Thread ID, and I will also copy this config, and we'll pass this config to this. Whenever we're doing the invoke operation here, I'll try to pass the config. Okay, now let's execute. So let's say I'll type what is, or I'll pass my name is Bappy. Now see, nice to meet you, Bappy. Now if I ask, what is my name? What is my name? It's giving your name is Bappy. Okay. Now let's see if I give another thread here. Okay, let's say thread 2. Now if I ask what is my name? Now see, it is telling, I'm sorry, I do not know what is your name. Is an as I am a AI assistant and I do not have access to the personal informations. Okay, because this is a completely new thread right now. Okay, now let's say in this particular thread, I will give, let's say my name is Alex. Now it is telling, nice to meet you, Alex. Okay, now if I ask, what is my name? Now it will tell your name is Alex. Okay, now if I switch to my thread 1, okay, now if I again ask what is my name, you will see that it will tell you your name is Bappy. See, your name is Bappy. Okay, now if I go to my thread 2, that time your name is Alex. Okay, I hope you got it, this concept. Okay, this trading concept, that means we can separate out the chat session. Okay, chat session for each and every user. This is possible, right? And here you can also see the state. So for this you can use this code. So chatbot dot get state, and you have to pass the config, and you will be able to see like how many threads you are having. Okay, all of the history you will be able to see. The entire state, that means the entire state you will be able to see. The state is saved in the memory. So this is the snapshot object. As you can see, whatever question you have asked, like what is my name, some other metadata, the AI response. Okay, so each and everything is visible here. And the input token, output token, and you will be able to see the trade ID as well. So what is the trade ID? Yeah, so this is the trade ID too. and thread ID 1 is also there somewhere. Okay, so that means the entire state snapshot you will be able to see here. So this entire step snapshot you will be able to see here if you're using this persistence concept. And there is a function called get state. Inside that you have to only pass the configuration you are preparing. You will be able to see the entire state. Okay, it is saved in the memory. So yes, this is the concept of this persistence. Okay, we have learned this persistence concept. So here I already told you persistence we can add inside LangGraph. This is also possible. And don't worry, I'm also going to I'm also going to record another video on top of this persistent in detail. We'll try to understand each and every concept, okay, of this particular persistence. Now this thing is working fine. Now what I can do, I can quickly convert it to the .py file. So let's create a file here. I'm going to name it as Agentic Chatbot .py, and whatever code I have written here, I'll just try to copy here. Or let's name it as Agentic Chatbot backend. Okay. Now I'm going to copy here. So first of all, let's import all the necessary library. Select my environment. Then I'll load the environment variable. Then initialize the model. Define the state. So this is my state. Now I'll copy my node. After node, I will copy my entire graph. Okay. So this is going to be my final. Yeah. So this is going to be my final workflow object. Okay. Chatbot object. Now we can use this chatbot object anywhere to run this particular workflow. Now what I'm going to do, guys, I'm going to show you whether it is working or not. So maybe I can create another file here called, let's say, app.py. Inside app.py, let me first of all import this chatbot object. So from Agentic Chatbot backend, import chatbot. Okay, chatbot. Now I'll just write response is equal to chatbot.invoke, and here we have to pass the human message. Okay, and for human message we have to import this library, this one. Hmm. So here I'll give, let's say, what is Python, and whatever response I'll get, I'll just try to print the response. Okay, now let's see whether it's working or not. So I'll open up my terminal. Then I will activate my environment. So conda activate LangGraph test. After that, we'll try to execute the app.py. So Python app.py. Okay, here. Okay. Sorry, actually, I have to give this. I have to give this trade ID, right? Trade ID I haven't given because here initially we passed the trade, right? We are giving the check pointer, so here I have to give the pass this trade. So here I will copy this trade. And also copy this configuration. Then we'll pass this config. Now I think this will work. See, it's working. Python is a high level widely used programming language, blah blah blah. Okay, but here I can't left this kinds of application to the user, because user don't know how to code, right, and how to execute this app.py from the terminal. So definitely I have to add the user interface. Okay, now let's try to add a user interface with the help of Streamlit here. So guys, now we'll try to add the user interface for this chatbot with the help of Streamlit. So Streamlit is a Python package, and here you can create any kinds of user interface without using any HTML and CSS code, right? So for this, we have to install this Streamlit. So what I'm going to do, in the same requirement file, I think you know this requirement file I am using so far, okay, inside my LangGraph tutorial. So here I'm going to add another package. I'm going to name it as Streamlit. Okay, Streamlit. You can specify any kinds of version if you want to install. So let's say I want to install this specific version. Then I will open up my terminal and I'll just write pip install -r requirement.txt. Oh, sorry, install spelling is not correct. Okay, as you can see, installation is complete. Now I will come back to my app.py. I'll close these are the file. Now let's start implementing the UI. See, your backend code will remain same. You don't need to change anything. You only need this chatbot, let's say, object here, so which we have already imported. Okay, from Agentic Chatbot backend, we have already imported the chatbot. Now I'll just remove these are the code as of now. Okay, so see, first of all, here I need a Streamlit server, right? In that particular server, I'm going to just add my UI functionality, and this server should be run on my local host, right? And if you're using Streamlit, it's super easy to launch the server. Only you just need to import the Streamlit. So from our import Streamlit as st. Okay, if you only import that, and let's say here I will give a title only, st.title. Let's say I'll give Agentic Chatbot with LangGraph. I've given this title. Now you have to execute this file only. Okay, now if you want to execute this file, if you just let's say write python app.py, it won't be running that time. For this, you have to use Streamlit command. Streamlit run app.py. So basically, you are launching this Streamlit server. Okay, now if I execute, and now see, Streamlit server will be running. See, this is the Streamlit server, guys, and this is running on localhost port number 85. Okay, port number 8501. So by default, Streamlit runs on port number 8501 on the local host. See, one thing you have observed here, without writing any kinds of HTML and CSS, we got this kinds of user interface. Okay, so this is the work of Streamlit, and here you can also change the settings. You can go to the settings. You can also um, change the appearances. If I, let's say, active this wide mode, this title will be moving to the left side. And let's say if I change the color, let's say I want a light color, I want the dark color. Okay, everything is possible here. But here we'll try to customize in the code whatever things we need. We'll only just try to add it. Okay, you can make it more beautiful. For this, you can go to the Streamlit documentation and you can check it out. There are so many functionality you can use. But this front end is not like our concern. Okay, there would be other front end developer. Okay, they will take care about the front end and everything. But as a agentic AI engineer, we have to know the actual concept, actual backend engineering. I think this is more than enough. Okay, so for this particular project, whatever let's say UI interface we need, we'll only just try to focus on that part. See, we already launched this Streamlit server and we set the title. Now here I need a user input box. Okay, that means the chat box. So here user will be able to pass any kinds of messages. Okay, for this we can take this chat input. So if you want to get the chat input, you can write this code st.chat input. Okay, and you can give any kinds of messages, because if you go to the chat GPT, right, so here you will see by default ask anything. So if you want to give this kinds of message, display message, you can write it here, and whatever message it will provide, it will store in the user input variable. Okay, so once we got the user input variable, if I show you, so if I let's say refresh, now see here I got a chat input box. Okay, now whatever input you will give here, you will try to send it here, it would be stored here. Okay, now I can also print and show you our st.print st dot text, or let's say write. I think there is a function called write. Now let me show you, refresh. User written none. So if I let's say give hi, now see here hi will come. Okay, that's how you can take any kinds of user input. So after taking the user input, guys, what I will check, I'll check first of all user has given any input or not. If user has given the input, that means if user input is equal to true, okay, that time I'll just try to um, give a display actually icon, okay, of the user, and from this icon I'm going to take the user message. User input, whatever user input will pass, we'll try to pass it here. Now see what will happen if I refresh. Now say if I pass any text here, now see this icon is coming because of this particular line, chat message, and this is user. Okay, this is the user icon, and user has passed hi. So if you see any kinds of chatbot, guys, you will be able to see people are using this kinds of icon to identify the human message as well as the AI message. Okay, that's why we have given this line, and by default in Streamlit it is available. So once I got the user input, now what I have to do, guys, I have to invoke the message to my chatbot. Okay, the chatbot object we have created, but before that we have to configure the thread, right? So maybe what I can do here, only I can prepare my thread. So config is equal to configurable thread ID. So here I have given, let's say, thread 1. Okay, thread 1. You can also give 1, 2, 3, 4. It's completely up to you. Okay, even you can also write like that. Okay, you can also write like that. It's completely fine. But in just one line, I have added like that. Now let's try to invoke the message. Yeah, so here we'll try to invoke the message. Yeah, chatbot.invoke, and message is equal to, we are giving the human message, content is equal to right now the user input, and we are giving the config. Now whatever response I'm getting, guys, I will also show this response. So first of all, I will extract the content from this response. So AI message is equal to response message -1 content. Okay, that means we are doing this operation. We are only extracting the AI message, and this AI message I will try to show in the console. For this, I'm going to create another icon, assistant icon, and this message would be shown in the assistant icon. Okay, now let me show you. If I refresh, done. Now let's say if I give hi, send. Now see, assistant is giving hello, how I can assist you today. Now this is the assistant icon, this is the user icon. Okay, that's why we have given this chat message is inside that I have mentioned assistant. Whenever you will give assistant, automatically it will take the assistant icon, and whenever you will give user, that time automatically it will take user icon. Okay, so that's how Streamlit works, guys. By default, internally they are handling each and every scenario, and they have given some high level functionality. We can use that and we can create our chatbot. Okay, it's working fine. But one issue in this particular chatbot would be, let's say if I give another message, I am Bappy. Now see, previous message is getting replaced. Okay, previous message is getting replaced. Now it is giving you the new one, but I can't see my previous conversation. But in ChatGPT, So let's say if I give I am Bappy, so I will be able to see my previous message as well. Okay, so this kinds of thing, if you want to do it, that time you have to use something called session. Okay, session state inside Streamlit. So Streamlit also works in that way. By default, if you're not using session state, what is happening? So every time it is re-executing code from here, and whenever it is re-executing code from the beginning, that time this message is getting erased. Okay, it is getting cleaned, and new message is getting replaced here. But if you're using session state will store these informations in memory, and every time whenever it will execute from the beginning, it will not erase. Okay, still this information will be available inside memory, and from memory it will able to load that. Okay, the same concept like trading. Okay, we have learned before, right? Yeah. Now let's try to add this session state. First of all, we'll create a session state here. First of all, we'll try to create a session state. I'll check if message history is not in session state. Then I'll try to create this message history. Okay. It will create like a dictionary kinds of thing by default inside this Streamlit. And this dictionary, it's a different type of dictionary. Basically, this dictionary will store the informations in the memory. It will not erase. Okay. If you execute the code from the beginning, still this dictionary data would be remaining same. Okay. Then after that, we'll load the conversation from the dictionary. So this is the code I have written, loading the conversation story. So for message in session state, message story, and if it founds this message, so it will basically load the role and the content. So role means whether it is the message for the user or AI. Okay, this particular role and the content. Now here you have to write some line of code. Let's say whenever user is giving any kinds of input, this input should be stored in the message story. So this additional line you have to write here. This is the additional line. First add the message to the message story. So st.session state message story, we are appending it. Okay, role, user, content, the user input. Okay, we are storing in this particular list. Once it is done, now I will also do the same thing whenever I got the AI response. So after getting the AI response, we'll also save this in the message story. So you can see st.session state message story append role. Now this role should be assistant. Okay, because this is the response from the assistant. Content is equal to AI message. Okay, done. Now if I come back here, refresh. Now if I give the message, let's say hi. Hello, hi, can I assist you? My name is Bappy. Nice to meet you. How I can assist you today? Okay, but this agentic chatbot with LangGraph is coming here. Let me see why. Okay, because you have to assign it at the beginning. Okay, because after load conversation story we have assigned it, that's why it's coming here. So maybe at the top I will try to assign this one. Okay, now I think this will work fine. Refresh. Now I'll give hi. Fine. My name is Bappy. Now see, nice to meet you, Bappy. What is Python? Now see, okay, it's working perfectly, and I am able to see my older message story as well. Okay, so yes guys, so we are able to create our first chatbot workflow, okay, with the user interface. Even we have also added the this persistence concept, that means the trading concept. And don't worry, I'm going to explain this trading concept, persistence concept in more detail in the next video. But this is the first video, guys. I wanted to show you how we can create the skeleton of the agentic chatbot. Now the chatbot skeleton is ready. Okay, now we have to add, these are the functionality one by one. Okay, we have to add, these are the functionality one by one. Now next I'm going to show you maybe the persistence concept in detail. Okay, after next I will discuss about the RAG concept, how we can add the RAG functionality, how we can add the tool functionality. Okay, UI I have already shown you. Okay, UI I'm not going to show you again. Maybe I'm going to continuously update the UI as per my need. Then I'm also going to show you how we can add the observability tool like LangSmith, memory, okay, HITL, okay, each and everything we'll be discussing one by one, guys. Okay, so yeah, this is the part one for this implementation, guys, of this agentic chatbot, and we are able to build our first interface of the chatbot. But right now it doesn't have any kinds of tool, it doesn't have any kinds of rack capacity. We'll try to add one by one, okay, through the entire series of the video. And I'm going to share all of this code in my video description. From there you can get and you can execute inside your system, guys. Okay, now I can test one more thing, which is the persistence. That means whether it is able to remember my name or not. So I'll ask, what is my name? Your name is Bappy, as you mentioned earlier. Okay, perfect. It is able to remember. So guys, here one more update we have to do inside this chatbot, which is, let's say, if I ask anything, let's say if I tell generate a blog about let's say Python. Now see, if I give this prompt to my chatbot, it will take some time, right? It is taking some time to generate this particular blog, and user has to wait till the execution, right? But if you go to the chat GPT, if you give the same prompt, right? If you give the same prompt and if you send this message, so instantly you will be able to see it will start generating one by one. So this is called streaming response. See, it is still generating streaming response. But the chatbot we have created, it is generating in one shot. Okay, we have to wait for the execution. Once execution is complete, once my generation is complete from the chatbot, then you will be able to see the content. Okay, so let's say if you are generating a big blog or any kinds of big content from the chatbot, that time you have to wait, and this is not a good user experience, right? But in ChatGPT, this is a good experience. If you give any kinds of prompt, whether it is a big content, it doesn't matter, it will generate this content, okay, token by token, and user will read it. Okay, instantly user will be able to read it. So this is called streaming response. So if you want to implement this kinds of streaming response inside your chatbot as well, you can also do it, because I already told you I will also show you this streaming response as well. Okay, streaming, yeah, how to add this streaming inside LangGraph. In LangGraph also you can add this streaming concept. Now let's try to add it. I will open up my code. So in this app.py only, you have to add this line. So there is like a very minor change you have to do. See, whenever you are getting this assistant message, right? We are invoking the response, and after invoking the response, we are getting the AI message. So basically here what is happening, first of all, you are invoking the message and you are waiting for the response. Once you got the response, then you are showing this response to the Streamlit user interface. So we have to replace this code with this code. So this is the code, guys, you have to use. See here, instead of invoking at the very first time, first of all, what we are doing, see, we are preparing this assistant icon. After that, there is a function inside Streamlit called write stream. Okay, we are using this write stream function. Inside that, we are using the chatbot object. Okay, now instead of invoking, we'll be using stream. Inside that, you have to pass the message user input, and you have to give the configuration. Okay, we already have the configuration. I need to pass the config only. So config is equal to config. Yeah, and stream mode is equal to message. You have to provide this particular configuration, and you have to run a for loop for a message chunk and metadata. So whatever message chunk you will be getting, you will only take the content, and this message chunk continuously it will be showing in the Streamlit user interface, because we are using write stream. That means every time whenever using ChatGPT and you are generating something, okay, let's say you are generating something, I'll tell more about it. it is giving you the response token by token. As you can see, token by token. Okay, so these kinds of token by token output you will be getting, and you will be writing in the Streamlit user interface. So this will feel like this is a streaming response that time. Okay, then once everything is done, then we'll try to store this AI message to the history, message history we are appending, like a same previously we did. Okay, as the assistant, we are appending in the session state. Now let me show you. So if I get back, if I refresh, fine. Now let's say I'll give hi. Streamlit has no attribute write stream. Why this error is coming? Let me check. Maybe the version we are using, it doesn't have this write stream. So what I can do, I can install the latest one. Now if I give the message again, okay, still the same issue. Let me check, guys. Okay, I have given this arrow to the ChatGPT, and ChatGPT is telling still you need to upgrade this Streamlit. So let me execute this command. Pip install upgrade Streamlit. So basically this will download the upgraded version. Done. Now we can try again. Now I'll give message hi. Now see, we are getting the response. Now if I ask, let's say, generate a blog about Python. Now see, it is streaming response like ChatGPT right now. Okay, and this is more interesting and more good experience to the user. Okay, so that this kinds of scenario you also need to take care whenever you are creating this kinds of agentic system. Okay, or any kinds of simple chatbot, whatever you are creating, this kinds of thing you have to take care. And lang graph is having this kinds of concept integrated. Okay, you can easily implement this thing in the lang graph. Okay, so we have also seen how we can add the streaming response inside our application. Okay, now this application looks more cool. Now in the next video, guys, I'm going to discuss about this persistence concept in more detail. We'll try to see what is this persistence is all about. We have already understood in this video as a high level, but in detail I'll try to discuss in the next video. So yeah, guys, this is all about from this first part of this implementation. So guys, as you can see, this is the definition of persistence, and in my previous video, that means in the part 1, maybe I already given you the high level overview on top of this persistence, like what is persistence and how we can integrate with our chatbot. I already told you about, but let's try to understand the detailed definition of persistence. As you can see, persistence in LangGraph is a built-in layer that automatically saves and restores the state of your agent or graph workflow over time. Okay, it works by using a checkpointer to automatically capture snapshot of the graph's state at every step, organizing them into unique and retrievable traits. Okay, so I think by the definition itself you can understand what I'm trying to say here, because if you have already completed the part 1 of this chatbot implementation, I think you know that. See, persistence, why it is required. First of all, let's try to understand from the beginning. Um, I think you know inside agentic application, first of all, we'll have a goal, right? So let's say, yeah, let me write down. Yeah. So see, in any kinds of agentic application, first of all, definitely we'll have a goal. Let's say you have a problem statement, right? You want to, let's say here we are creating an agentic chatbot. So definitely this is our goal. Now this goal should be divided into multiple tasks. So first of all, what we'll do, guys, we'll try to divide this goal to the multiple tasks. Let's say this is task 1. Okay, this is task 2, and so on. That's how we'll be breaking down different tasks. And whenever we'll be using LangGraph, right? Whenever we'll be using LangGraph, because so far we are learning about LangGraph. So in LangGraph, to define this particular task, we use something called nodes, right? Each of the task will become a nodes. Let's say this is our first nodes, this is our second nodes, okay, and so on. So that means, first of all, we'll be having a goal and we'll define a task from this particular goal, like a step-by-step task. And this particular task would be our nodes, okay, inside the graph, because this is the entire graph. As you can see, this is the entire graph in LangGraph, right? This is the entire graph in LangGraph, and these are the nodes, okay? And you can see this is the edge connection. This is the edge connection, and this start node is nothing but this is the input. So here we pass our initial state, initial input, right? And this input will go through these edges. This edge is nothing but it's a connection. This edge defines basically after which node, what node should be executed, okay? Because of this particular arrow symbol. As you can see, this arrow symbol defines, okay, after start nodes, node 1 would be executed. After node 1, node 2 would be executed, like that, right? So this is called edges. This is called edges, and this is called nodes. We already know about this is called nodes, right? Okay, and then this particular task will go through all of the nodes. Then at the last we use a end nodes. What this end nodes will do, it will first basically stop the graph execution. Okay, let's say whenever we'll give any kinds of input, and whenever it will reach to this particular end, it will stop the graph execution, and you will be able to see the final, okay, final result here. Final result here. And we have already seen this particular things in the practical implementation as well. I think this is pretty much clear to you, right? Now, see, the main things we have to understand whenever we are defining any kinds of graph, right? Whenever we are defining any kinds of graph, and if I want to execute this graph in LangGraph, we have to provide something called state, right? We have to provide something called state. I think you know that. Without state, we can't execute any kinds of graph. And what is state? State is nothing but it's kinds of variable we are passing, right? It's kinds of some of the data we are passing to the graph. Okay, let's say in this particular chatbot, what should be the state? State should be the message. Let's say the message user is giving, okay, and our AI bot is replying. So this is the message, this is the information. So every time what will happen, this state will go to the every nodes, okay, every nodes, and these nodes, whatever output will return, it will basically update in this particular variable. Okay, this is called state. But what happens if we are giving this particular state to the graph? So let's say we are passing this state to the start node, right? Then the start node will pass to the node 1, then node 2, then end. So whenever it will go to the end, that means this graph execution is getting over, and whatever state data you are having here, it will be basically erased that time. Okay, it will be basically erased that time. Then whenever you will be running second time, you won't be able to get the previous information, whatever you got in the first execution, right, inside the state. So this is the main problem. Then what we introduce something called persistence, right? We introduce something called persistence. So in persistence, what we usually do here, we basically save the entire state, okay, inside a storage service. Either you can use your RAM, okay, we call it as a memory saver. Either you can use any kinds of database. That means two kinds of storage service you can use. Either you can use your RAM, that means memory, okay, your computer memory. Either you can use any kinds of database here. Okay, database is the permanent one, okay, permanent one, and this is the temporary one. Okay, temporary means if you restart your application, that time this data would be erased. But in database, if you restart your application, okay, it doesn't matter you if you restart, if your let's say system crashes, it doesn't matter, your data will be permanent. Okay, you can load anytime these kinds of data. That okay, that means inside persistent, whatever state snapshot we are having, okay, we try to store inside a storage service. That's why in the definition itself, you can see persistence in LangGraph is a built-in layer that automatically save, okay, and restore. That means you can restore this particular state anytime, okay, from the storage service. The state of your agents, okay, the state of your agents or graph workflow over time. Okay, over time means because it is every time it is capturing your snapshot. It is let's say this persistence, every time it will save the informations in the storage service. Let's say after start, whatever state update you got, right, this particular information would be saved. After node one execution, whatever state would be saved, it will be basically saved in the database or your local storage. Okay, that's how every step, okay, every step it will be saving the information of your state. That's why we call it as a overtime here. And it works by using a check pointer to automatically capture the snapshot of the graph state at the every step. Okay, I already told you. And in my previous implementation, I used something called check pointer. I think you know that. Again, I will give you the idea, okay, how check pointer works, and each and everything I will give you. Then another thing we learned, this organizing them into unique and retrievable threads. Okay, we'll be also learning about the threads. Thread means you can create multiple threads. Let's say thread 1, you can do some kinds of conversation. Thread 2, you can do another kinds of conversation. Okay, so both conversation would be different, and you can't use thread 1 information in thread 2 and thread 2 information in thread 1. Okay, we can also make this particular difference. Okay, I hope you got it, guys. Now that's how your persistence comes into picture, and this is very much important whenever you are creating this kinds of agentic AI application. Otherwise, what will happen, your application may not get the state data, okay, over time. Whenever you are creating this kinds of agentic chatbot or any other, let's say, advanced application which is required your older data as well. Okay, just try to think about whenever we're creating this agentic chatbot, definitely I need my previous response. Let's say I have given the input, my name is Bappy, right? And second time, if I'm asking what is my name, so definitely it should remember that particular informations, right? Whatever it is updated in the state. Okay, but if it is getting end, right, and if the final result is getting erased, okay, of this state, that time definitely your agent won't be able to give you the response. But if you're using the persistence concept, and if you're capturing this state, okay, inside a memory, okay, if you're saving this inside a memory, so anytime we can load this and we can pass again to the graph, and graph will be able to recall the previous information, and that will be able to give me the result. Let's say your name is Bappy. So this is the main funda here. Okay, I hope you clear, guys. So guys, now let's try to understand the speciality of persistence. See, persistence is having some kinds of speciality. See, I told you whenever we define any kinds of state, right, and whenever we execute a graph, so this state will go to the every nodes, right? Every nodes it will go, and all the nodes will be updating something in the state, okay, and we'll be getting a final result from here. So it doesn't mean this persistence will only capture the final updated state information. Instead of that, it will be able to store your intermediate, let's say, data. Intermediate data means, see what happens whenever we define any kinds of state, right? Let's try to take example. Let's say state. So let's say here I have taken a state. The state name is, let's say I will take name. I want to only save the name information here. Okay, name. Let's say I have only taken one variable. So what will happen? This state will go to the every node. First of all, it will go to the start node. Okay. After going to start node, your graph would be initialized. Your graph would be executed. So through these edges, it will reach to the node 1. Okay. Let's see in node 1, we are doing some kinds of update. That means node 1 is updating this name. Let's say initially it was, let's say initially I have given A. Let me take this color. Initially, let's say the name was A. Okay. Now what we'll do, this node 1 will try to update this particular name. Let's say it will be updating B. Okay. It will update B. But whenever we pass this state, okay, initially it was name A. Okay. But whenever we pass through this node 1, this was changed to the B, right? So the execution you can see here, node start to node 1. That means through this execution, okay, this is called super step. Okay, this is called super step. So what is super step? Basically to execute the entire nodes, okay, to execute the entire graph, whatever super step we perform. Okay, let's say if I want to execute the entire graph, definitely I have to execute node 1, node 2. Okay, then it will go to this end, then your entire graph would be executed. then you can see multiple edge connection is there, and each of the edge connection is a super step here. Okay, that means in every super step there would be some kinds of update in the state, and your persistence would be able to capture these informations in the stories. Okay, that means let's say after node 1 it will go to the node 2. Let's say node 2 will try to replace this B to this C. Okay, and whenever it will reach to the end, and here you will get the final name C, right? But it's not like that. It is replacing all of the previous information. Still the previous information is available. Okay, still the previous information is available. Okay, so this information we call it as a intermediate intermediate state. Okay, we call it as intermediate state, and this is called final state. Okay, final state. That means the specialty of persistence is it will capture your intermediate state as well and the final state as well. Okay, it's not like that every time you will get the final state. Definitely intermediate state would be available after each and every super step execution. Okay, let's say in future your application will crash here. Let's say node 1 it will crash, or let's say node 2 it will crash. Okay, that time it's not necessary whenever you will restart your application it will execute from the beginning. Okay, it's not like that because it has the intermediate state and it has already has the information. Okay, so what it will do, it will able to resume. Okay, it will able to resume your application from node 1 or node 2 because it has captured the intermediate state. Okay, so this is called actually fault tolerance. I already told you about this, right? Fault tolerance in my introductory session. I already told you about fault tolerance, right? That means whenever your application get crashes, it's not necessary to re-execute your application from the beginning. Okay, you can execute your application wherever your application got crashes. Let's say this is crash point. Okay, or let's say this is crash point. Wherever your crash point happens, it will resume the application from here itself. Okay, I hope you get it. So this is the specialty of this persistence. If you see these kinds of question in the interview, what is the specialty of persistence, that time you can tell it can also save the information of the intermediate state along with the final state. Okay, I hope you get it. And if you go to the real time, let's say application, let's say if I go to the ChatGPT. Okay, ChatGPT also using this kinds of persistence concept. So in ChatGPT, what you can do, you can either create a new conversation, okay, new chat, either you can continue with your old chat, right? Either you can continue with your old chat. Let's say if I want to continue some kinds of old chat, I can continue here. Let's say this is my old chat, as you can see, right? I can continue here. So let's say what is the final code. See, it will basically reusing my older state. See, and it is continuing the conversation. Okay, and even I can also start a new conversation here. Okay, if I start a new conversation, that means my new state would be created, and one by one this super step will be executed, and each and every step, this snapshot would be captured and it will be updated in this state. Okay, so without this state you can't create this kinds of application. Definitely for these kinds of advanced agentic chatbot you need this state, and this state is already you need this kinds of persistence concept, and this persistence is already integrated inside LangGraph. Okay, and with the help of that you can handle these kinds of fault tolerance in a very easiest manner. Okay, I hope you got it, guys. I have given you the example with the real world example as well, like ChatGPT. So ChatGPTs are also using these kinds of persistence in the backend. So in ChatGPT, what is happening? Whatever conversation you are doing, this kinds of information is getting saved, in the state, and they're using persistence concept here definitely, and they're storing these kinds of informations to in a database. Okay, they are not using any kinds of local storage service. Instead of that, they're using some kinds of database, and from the database itself this information is getting fetched. Okay, whenever you are opening any kinds of old conversation, you will be able to see whatever message you have done here. So this information is coming from the database. Okay, I hope you clear, guys. Now guys, this definition would be pretty much clear, what is happening inside persistence. Now let's try to understand another concept here. As you can see, it works by using a check pointer to automatically capture the snapshot of the graph states, okay, at every step. Now let's try to understand what is this check pointer exactly. So here I have taken another example, guys. As you can see, check pointer is inside a persistence. See, check pointer is nothing but uh, you can consider this check pointer is kinds of tracking functionality. Tracking functionality means each and every super step whenever it is executing and whatever update we are making inside the state, that time check pointer will be able to capture those informations in the state, right? In the state means it will be able to capture those information and it will save inside the persistence memory. Okay, so let's try to understand this concept in detail. So what I'm going to do, I'm going to open up my Blackboard and here let me make you understand. See what I told you, whenever we give any kinds of state to a graph, okay, so what will happen, it will execute the nodes one by one. As you can see, we are having lots of nodes here, and you can see the edge connection. This is the edge connection, and whenever you are doing this kinds of edge connection and edge execution, that means after start to from start to node 1, here we are doing a execution, and this execution we call it as a super step, right? I already told you about super step, right? So whenever you are having these kinds of super step, okay, whenever you are having these kinds of super step, uh, after that you will basically set a checkpoint. Okay, set a checkpoint. That means whenever we are passing an initial state to the start, that time one checkpoint would be available here. Checkpoint, checkpoint 1. Okay, let's say this is our checkpoint 1. Then uh, after doing this super step execution, there would be again an update. So there would be another checkpoint. Let's say this is checkpoint 2. And here you are having multiple nodes, okay, as parallel. So this is one execution, this is another execution, this is another execution. We combine all of the execution and we will be calling as another super step, another super step, super step, right? And after this super step, there would be another checkpoint, checkpoint 3. Okay, and at the last, because here we are doing another super step execution and we're getting the final response. Okay, here also another checkpoint would be available, checkpoint, let's say 4. Okay, and every checkpoint will capture the updated state. Let's say after this start to node 1, whatever update will be happening in this state, this checkpointer will capture that information. It will save in the persistence memory. Okay, persistence memory, it will save. Either you are using local storage, that means your RAM, either you are using any kinds of database. Okay, database, it will store there. Okay, whenever it is storing, that means it is not replacing the value. Instead of that, it is merging. That means it is adding the information, and we call it as a reducer concept. I think you know that reducer. That means whenever we are using this kinds of persistence concept, definitely we have to use the reducer. Okay, reducer concept will be continuously adding the informations instead of replacing the old one. Okay, I hope you get it, guys. Okay, then this kinds of checkpoint we have in every super step, and whenever any kinds of update would be happen in the state, it will capture the information and you will be getting a final snapshot, final, let's say, state at the last checkpoint, and this will like store at the last. Okay, but you will be able to see the previous update as well in the state. Okay, this is how this particular checkpointer is working. I hope you got it right. To get the updated data in the state, we use this kinds of checkpointer, and the checkpointer work is to capture this information in the storage service. This is the work of a checkpointer. That's why in the definition itself, I think you see the definition. In the definition itself, it is telling it works by using a checkpointer to automatically capture snapshot of a graph state at every step. Okay, because we are using every step execution here. I hope you get it, guys. Okay, now let's try to understand this checkpointer concept through an example. Let's say I'll take the same graph execution here. So let's say here I will define a state. Let's say I'll define a state here. The state variable I'll take number. Okay, number. So this number will be a list of integer, list of integer. Okay, and here we are using add operation. Why we are using add operation? Because we are using reducer concept. I think you know that. Okay, and this number would be a list of numbers, and all of the number would be an integer. Okay, so let's say initially whenever I will pass this number to the graph, initially let's say the value is 1. Okay, the value is 1. So I told you each and every uh, super step will be having a check pointer. Let's say I can define all of the check pointer. Definitely at the first node there would be a check pointer, let's say cp1. Then here also we'll be having a check pointer cp2. Here also we'll be having a check pointer cp3, and here we are having, let's say, cp4. We are having all the check pointer. So what will happen? Yeah, so whenever it will execute, it will go to the node 1. Okay, let's say node 1 update update this value, let's say this number, it will update let's say 2. Okay, 2, it will return 2. So it will happen, now the number will become like that. So in this list, so initially the number was, I'll denote with n. N means number. Initially it was 1, right? 1, and now it has updated 2. So instead of replacing the previous one, it will add the number at the last. Okay, this is the concept of the reducer. Okay, and this is called your intermediate state. Now we got the intermediate state. Now it will go to the next node execution, and here also you are having a check pointer. Now let's say this generates a single number. Let's say it will generate 3, this will generate 4, and this will generate 5. So what will happen? Again the number should be like that, 1, 2, then this 3 will come, 4 will come, and 5 will come. So 3, 4, and 5. Okay, then it will save this information to the memory. Okay, every time it will save this information to the memory, because check pointer is saving the information to the memory. Either you are using local memory or any kinds of database. Okay, it will try to save that particular state. Then it will go to the last one, that means check pointer 4. Let's say this returns the final result, and here you haven't done any kinds of update. So what would be the final? Okay, final number should be 1, 2, 3, 4, and 5. Then this final state would be also saved, okay, in the database. Okay, that's how we are not only getting the updated state, and instead of that we are also getting the intermediate state. How? Because of the check pointer. Okay, now I think this part is clear to all of you guys. So guys, we have understood about this persistence. We have understood the persistence. Then we have also understood what is check pointer and how it works. Okay. Now let's try to understand another important concept. As you can see, organizing them into unique and retrievable threads. Okay. Now let's try to understand what is this threads. Okay. Threads is also a concept of persistence. So in my previous part, guys, that means in the part 1, I already told you about the threads, right? We added the threads. With the help of threads, actually, we can separate out each and every, let's say, chat. Let's say if you are doing chat in thread 1, that means in thread 2 you won't be able to see that particular chat, or in thread whatever chat you are doing in thread 1 you won't be able to see inside thread 2. So this kinds of thing I think I already showed you. If you haven't checked that, please try to check my previous part, guys. So here let's try to understand this trading concept. As you can see, trades in persistence, we have already taken an example here, so I'm going to open it up. So see here what is happening. Let's say here we have taken 2 trades. Let's say this is trade 1, and this is trade, sorry, this would be trade 1, and this is trade 2. Okay, now in trade 1, as you can see, I have updated some kinds of state. Okay, so here would be 1, actually I missed out. Yeah, so you can see Let's say here we got 1, then after node 2 execution we got 1 2, okay, and so on, like I already showed you this example before, right? Yeah. Now I have taken the same example, but I updated, let's say, another state number. Let's say here I started from 6, then node after node 1 execution I got 6 7, then 6 7 8 9 10, okay, then 6 7 8 9 10. This is the final number. So see what is happening here. Although I am executing this graph two times, but in a different threads. So for the first time I have given a separate number, and for the second time I have given another number. So it is not replacing the previous information. As you can see, previous information is remaining same because it is running in a different thread. And here thread ID is different. It is also running the same graph, but it is running in the another thread. Okay, I hope you got this concept. So if I give you one real-time demo, guys, if I go to the ChatGPT, so in ChatGPT also, I think you understand, let's say whenever we do chat operation, right, it will basically create some threads. Let's say this is a threads, this is another threads. Okay, that's why we are having different threads. Okay, let's say if I show you, let's say this is the different thread. Let's say this is another threads. Okay, this is another threads. That means this information you won't be able to see in this particular threads, right? And whatever information you are having, you won't be able to see in this particular threads, right? These two threads are completely different. And whenever you are creating these kinds of real-time agentic chatbot or agentic AI application, definitely you have to take care of this particular threads. Otherwise, what will happen? It will be getting the previous context as well. Okay, and I will be able to separate out my chat whenever, let's say, this application is using by multiple person, or let's say by me only, I won't be able to separate out my chat informations. Okay, everything will be combining in one particular threads, and this is not good, right? So that's why we create this particular threads. And now we can also create another threads by clicking on new chat. Now if you do any kinds of conversation, see, it will create another threads automatically here. See, new chat has created, and this is another threads. Okay, so we'll also able to see how we can add these kinds of trading, how we can add these kinds of, let's say, real-time trading inside our chatbot also. Although I have shown you the trades, but I hard coded the trade 1 and trade 2, right, in my previous demo. But I will show you, okay, whenever you are creating this kinds of chatbot in a user interface also, how we can add like ChatGPT. Okay, these kinds of trading I will also able to show you. So now I think you understood about the trades, guys. What is trades exactly? Trades is basically it stores the informations with a trade ID. Let's say whenever you are using any kinds of database or your local storage, it doesn't matter. Let's say whenever you are using local storage, that means your RAM. That time what is happening in the RAM only, it is creating a separate ID, trade ID. Okay, that means it is taking a separate space inside a RAM. And for trade 2, it is taking another separate space in the RAM. Although it is executing the same graph, but it is executing in a two different place. But in database, what is happening? I know, you know that in database, we create a table, right? Inside a table, we can create another column called trade ID. Okay, trade ID. Let's see if trade ID 1, all of the information would be saved about the trade ID in this particular row itself. Let's see if trade ID equal to 2, all of this information would be saved related trade 2 here. So whenever I need trade 1, I will try to fetch the trade 1. Whenever I need trade 2, I will fetch the trade 2. Okay, that's how the things work actually. Basically, it saves the same information but in a different threads to separate out my each of the, let's say, state or each of the chats. Okay, I hope you get it, guys. So guys, we have understood the theoretical concept of persistence in LangGraph. Now let's try to see the code example. Okay, for this I will create a simple sequential workflow here. So this is the graph I have taken. As you can see, this is our workflow. So here basically we'll try to see an example. In this example, first of all, we'll try to generate a joke of a topic. Let's say here we'll pass a topic. Let's say we'll pass any kinds of topic. Let's say I passed football. So first of all, what will happen? Here we'll create a node, and this node will try to generate a joke on top of that topic. Let's say it will generate a joke on football. Then after that, we'll pass this joke to another nodes called gen exp. Basically, this will generate the explanation of that particular joke. Let's say the joke we have generated, we want to generate the explanation of that particular joke, then this workflow will be end. And to make this graph, guys, we need a state. So I already prepared the state. As you can see, we named it as joke state. We are inheriting with the type dict, and we have taken the state. First of all, we need a topic, then whatever joke it will generate, joke would be there, then explanation. Okay, that means the three variable we have taken. I think this is pretty much clear. So I have already written the code. As you can see, this is the code. So first of all, let's import all of the necessary library. We are importing state graph, start, end, type dict, chat, OpenAI, load env. Only the new things I have imported, this in memory saver from LangGraph checkpoint dot memory in memory saver. Okay, so this is what your persistence like a persistence memory, that means the check pointer, like where you want to save this state. So here we are using in memory. In memory means it will save the information inside your RAM. You can also use any kinds of database. We'll also see database in future, but as of now, just to show you the demo, we'll be using our RAM. So let's import all of the necessary library. Okay, then we'll try to load the environment variable, because there I have my OpenAI API key. I already set my OpenAI API key here. Then after that, we'll try to define a large language model. Then we'll define the state, the same state I showed you here. We are defining the state. Then we'll be writing the nodes. Okay. So first of all, we have created the graph, as you can see. Then we are adding the nodes. First node is generate joke. Second node is generate explanation. So generate jokes and generate explanation. So these two functions I have tried separately, because this is going to be my node. So this is the generate joke nodes. As you can see, it will take this state and it will generate the joke and it will update that joke state. And this particular nodes will try to generate the explanation. Here we have given the prompt. So it will take the joke from the state and it will generate the explanation and it will update the explanation. Okay, so let's try to define all of them. So after that, we are defining the graph. So as you can see, we are adding the nodes. After that, we have to do the edge connection. As you can see, edge connection is start to gen joke, start to generate joke, then generate joke to generate explanation, generate joke to generate explanation, then generate explanation to end, generate explanation to end. This is the edge connection. Now, if you are using this persistence concept, you have to define a check pointer. So here we are defining the check pointer and we are defining the in memory saver. And if you're using any kinds of database, you have to define the database class here. This will become my check pointer. Now we'll whenever we'll try to compile the graph, we'll pass this particular check pointer, okay, in this particular parameter. Now basically by this code, you are telling your LangGraph graph to use this persistence concept. That means whatever state you are having, okay, whatever state update it will do, whether it's intermediate or final, it will try to save all of the information in this particular memory. Okay, I hope you get it. Now let's try to compile the graph. Done. Now let me show you how we can execute this workflow. See, to execute this workflow, you need to define a configuration. Okay, you need to define a configuration, and in the configuration you have to define the threads. I already told you, okay, threads is important. Whenever you are using persistent concept, definitely you have to pass the thread, and each and every thread will store your informations in a separate space in the memory. Okay, if you're using a memory, it will use a separate space. If you're using a database, it will use this particular thread ID to store those information. Basically, in thread 1, whatever conversation you are doing, you won't be able to see in thread 2, or in thread 2, whatever conversation you are doing, you won't be able to see in thread 1. Okay, that's how you can create as much as thread you can, like the ChatGPT. We saw the example, right? So we are preparing the configuration. There is a parameter called configurable. You have to define as a dictionary, then you have to define the thread ID. So let's say we have given 1. Then we are invoking the workflow. We are passing, let's say topic is equal to football. Let's say here the topic should be the football, and it will generate a joke on top of the football. Okay, then we are passing the configuration here. Now let's execute. Okay guys, so here I'm getting an error, rate limit error. I think my OpenAI credits is over. So what I can do, maybe I can use other model. So let's use another model. Maybe I can use Gemini. Maybe I can use this model freely, okay, for some request. So what I'm going to do, guys, quickly, you can simply go to the chat GPT. I have already done. Let me show you. See, So I go to the chat GPT, then I given my code. Let's say this is the code I'm using, and can you change the model to Gemini? Uh, Model to Gemini, OpenAI credits is over. Now it has suggested, okay, that's how you have to use the Gemini model. First of all, you have to install this library, LangChain, Google Gen AI. So let's try to add inside our requirement. So I've already added inside my requirement. Now let me install that. So pip install -r requirement.txt. Yeah, that's how you can use any model. Okay, model doesn't matter. Either you can use OpenAI model, Gemini model, open router provider, anything you can use. Once it is done, then I'll try to simply see the next step. I have to collect my Google API key. So, and we have to add inside the environment variable. So let's try to do that. So this is my environment variable. So here I'll try to add my Google API key. And where you will get the API key? You have to go to the Google AI Studio. Google AI Studio. So left hand side, you will be able to see the API key option. Now let's try to generate the API key. I already have some API key here. Maybe I can delete. Okay. If you want to create a new one, click on create API key, Gemini API key. You can select your project. If you have any project, let's say I'll select my project and create the API key. Once done, let's copy this API key and I will try to paste it here. Done. Okay. Now let's try to, yeah. Now let me check. So if you want to do that, first of all, you have to import this line. Instead of OpenAI, you will import this LangChain Google Gen AI, import chat Google Generative AI. Let's import, load the environment variable. Then you have to replace this. Okay, replace this model definition with here I'm using Gemini 1.5 Flash. I think this is the free model, free to use model, and this is the temperature parameter. Now let's define. Okay, now I think it's fine. Now everything is good. Now I'll come here. Let's try to execute all the cell again. Otherwise, I think I might get some issue. I'll define the graph. Now let's invoke this workflow. Okay, here I'm getting a client error. Okay, this model not found. Flash is during the task with name joke ID. Okay, let me check this model not found. I can try with this pro model. Okay, this is also not found. Maybe I can try with this 2.5 Flash. I think this should work. Yeah, 1.5, I think it is deprecated from the API. You have to use 2.5. Now see, we are getting the output. That means 2.5 is working. Okay, you have to use this 2.5 Flash. Okay, now see, here is the topic we have given, and this is the joke I got, and this is the explanation. Okay, we are getting from this particular joke. It's working fine. Okay, now if you want to see this state, right? If you want to see your state, because this state got saved in the memory, you have to call this function get state, and you have to pass the configuration. That means our trade ID configuration, trade one configuration. Now if execute, now see, this is the snapshot. This is your state. You can see the topic, you can see the joke, you can see the explanation, and some other metadata informations are available here. Okay, Now if you want to see the entire intermediate state as well as the final state, you have to execute this function get state history, and again you have to pass the configuration, that means thread 1. Now if I execute this, now see guys, you are getting all of the intermediate state as well as the final state. Okay, now the last one, you can see this is the like that means the final state, and the first one, this is the first intermediate state. Now if I show you this graph guys, so how many checkpoint you have here? See, you have one checkpoint, 2, 3 and 4. So that means 4 output we are getting. So this is the first checkpoint output. So initially whenever we pass the topic, we didn't have any kinds of joke, then explanation. Okay, we didn't have anything. You can see initially this was only running the start node and there is nothing. Okay, then we executed the second node, that means the second checkpoint. In second checkpoint we only pass the topic. Okay, and that time we didn't have any kinds of joke. You can see we didn't have any kinds of joke or this explanation. Okay, you can see this was nothing. Then at the third you can see checkpoint, it has generated the joke. Okay, that time explanation was not available. Okay, you can see topic was there, joke was also there. Okay, joke was also there, but explanation was not there, because you can see explanation is completely empty. It was not there, right? Then whenever we executed the last node, that means we got the checkpoint 4, that time explanation was available. You can see topics is available, joke is available, explanation is also available. Okay, that's how you will be able to see the final snapshot as well as the intermediate snapshot of this state. Okay, this is amazing, right? And that's how your persistence is working. And this is super important guys, just trust me, this is super important concept whenever you are implementing any kinds of agentic AI application. That's why in my first part, the application I started guys, Agentic Chatbot, so there I use this particular concept, this persistence concept. So there also we created this checkpoint. I think you remember we created a checkpoint, but here I use this memory saver. I was saving everything in my RAM, but later on I will also show you how we can add the database as well. Okay, because I told you we'll be going step by step so that I can teach you each and everything. Okay, I hope you clear. So now I'll get back to my code. Yeah, now let me show you one thing, this trading concept. Let's say if I right now give this trade ID is equal to 2, right? That means completely another trade would be created, another block would be created in the memory, and in that particular memory it will save all the informations. Now see, we are invoking with another topic called cricket. Now it will generate the joke on top of the cricket, but in a different trade. Let me show you. Okay, if you're using free model, it might take some time. Now you can see this is the topic and this is the joke and this is the explanation we are getting on top of cricket. Now, if you want to see the state, final snapshot, this is the final snapshot. And if you want to see the all the intermediate state as well as the final state, you have to execute this line. Now you can see this is for football. Okay, now the best part is that if I change this configuration anytime, let's say I want to get my football, sorry, not football. Okay, this is configuration 1 I pass, sorry, I have to give configuration 2. Now if I give configuration 2, now see this is for cricket. Here also I have to pass the configuration 2 because this is my trade 2, right? Now if I give configuration 1, so this is my trade 1, that means cricket, sorry, football. Now if I give you trade 2, now this is cricket. Okay, see all of the state is different right now because it is saving inside different trade. Okay, I hope you get it guys. So from this persistence guys, we got some benefit definitely. So let's try to define the benefit of persistence. So the first benefit, we got the short-term memory. I think you already saw the short-term memory, right? We have implemented because it is saving the information in this state, okay, in a database. And in my previous code example also, the chatbot I created, this was also able to remember my informations. Okay, this is called short-term memory we can implement, okay, with the help of this persistence. Now the second one benefit you will be getting called this fault tolerance. Fault tolerance. Okay, I already told you about this fault tolerance. Fault tolerance means, I think here I showed you somewhere. Yeah, so let's say if your application got crashes from any particular nodes, instead of executing your application from the beginning, you can resume the application from the same crash point itself. Okay, let's say node 1 your application got crashes, from node 1 itself you can execute your application. Okay, for this I will show you a practical demo. I think after that you will be able to understand. Then this persistent helps us to implement this HITL, that means human in the loop concept. Then there is another one called time travel. Okay, time travel. We'll also see the example itself. Now we have also already seen the short term memory example. Even going forward also I'll use this concept in my application. Okay, you already understood this concept. Now let's try to understand this fault tolerance, like how we can resume the application whenever it got crashes. Okay, so let's see the fault tolerance example. Like I will show you a code example how it works. For this here I have taken this particular workflow. It's a like very basic dummy workflow I have taken. I generated from this workflow from ChatGPT. So here what I have done, guys, I have taken actually three steps: step 1, step 2, step 3. So what is fault tolerance? I told you fault tolerance means let's say at step 2, let's say you got crash. Okay, crash your application. So instead of running from the beginning, whenever you are resuming your application, instead of starting from beginning, so what you can do, you can start from step 2 itself. Okay, because I have all of the intermediate state data, okay, till step 1. So I don't need to execute from step stay from the first step again. I will execute from step 2. Okay, so this is called fault tolerance. So this example we'll try to see in a code example. So here what I have done, guys, here manually just I have taken up like time. I am using time module in Python, and here I will wait for 30 seconds. Okay, and in 30 seconds what I'm going to do, I'm going to just do a manual keyboard interruption, and I will just crash my application here. Okay, and I'll show you how we can resume your application from step 2 itself. Okay, that means wherever your application will get crashed, from here itself it will try to restart the application. Okay, this part I will show you. For this, what I've done, guys, I have written a code in Google Colab. So why I'm writing in Google Colab? Because in my VS Code I was not able to interrupt this cell. Okay, it was taking lots of time. That's why I have copied this code on my Google Colab. So I already connected the notebook, and I will share this notebook with you guys. So here what I'm going to do, guys, I'm going to import all of the necessary library. Then here for this particular graph, I have defined all of the state I need. Like I need input step 1, step 2. Okay, and I inherited with the type dict. Then here I have defined all of the step 1, step 2, step 3. You can see all of the step I have defined: step 1, step 2, step 3. Only in step 2, guys, here I am just taking this time.sleep. I will wait for 30 seconds. Okay, and here I'm only just doing the print statement. I'm just doing like step 1 executed and return the step. Okay, and update the state. And step 2 only I'm just doing this waiting operation. 30-second will wait, and in between I'll just try to crash my cell. And step 3 also I'm just only doing the print statement. Okay, this is a dummy code I generated from ChatGPT. Now let's execute this cell also. Now here we're building the graph. As you can see, we're taking the graph and we are adding all of the node one by one. Then we're doing the edge connection. Okay, then we are taking the check pointer in memory saver. Then we are just compiling the graph and we're giving the check pointer. Done. Now here, guys, in the try set block, I am invoking my you can see graph, and I am just doing some print statement. Okay, so you can see I'm giving input is equal to start, because here I told you we are only doing by very basic workflow execution. That's why I've just given some dummy value here. And here we are giving the trade also. That means the configuration. I think you know in persistence you have to give that. Then in exception we are also printing kernel manually interrupt crash simulated. Okay, now let's execute. Now see, it will wait for 30 seconds. In between, I'll just try to stop the kernel. Okay, now see, kernel stop, that means my application got crashed. Now if I show you my state, as you can see, uh, step 1 done. Okay, step 1 executed perfectly, it's done. Now whenever it was running step 2, right, there is nothing. You can see step 2 didn't complete it because here it got crashed. Now I will rerun this particular workflow again, and you will see that instead of running from the beginning step 1, it will run from step 2. So again, what I'm doing, guys, I'm invoking the graph, and as of now the input I'm only giving this none. Okay, why I'm giving the none? Because if you're doing the fault tolerance, instead of, see, previously I was giving my input, but right now I don't want to start from the beginning. I want to start where it got crashed. That's why I have to pass the none. Okay, then we are giving the thread again, and we are giving the same thread. Now let's execute. Now you'll see that it is running from the step 2. As you can see, it is not running from the step 1, it is running from the step 2. And after waiting for 30 seconds, you will be able to see the final output. Let me show you. 30 seconds you have to wait. Now see, execution is done. Now we're getting the final step. You can see step 2 is also done. Now if you want to see the state, as you can see, step 1 is done, step 2 is also done. Okay, so that's how, guys, fault tolerance works with the help of this persistence. I hope you get it, guys. That's how you can resume. Okay, you can resume your any kinds of workflow whenever it got crashes in production. Okay, I hope you clear, guys. Now let's try to understand this HITL, that means human in the loop, like how persistent helps us to implement this human in the loop. See, for this, let's take a simple example and try to understand this one, because I'm not going to show you as a code example for this human in the loop. I'm going to create a dedicated video. See, let's say I want to generate a LinkedIn post, okay, or let's say Facebook post. First of all, I have to take a topic, okay, topic name from the user. Then it will go to the next nodes. It will basically generate, let's say, this uh, Facebook post. Okay, once it generated the Facebook posts, then I want actually it will wait for the human verification. Let's say it will wait for the human verification. Let's say if I verify my post is completely fine, that time I'll give the permission. Just try to post this particular post to the Facebook platform. For this, maybe we can use a API provider, Facebook API provider, and we can basically post this. Sorry, here I will. Yeah, basically here we can post this particular post on the Facebook. So maybe I can draw it perfectly. So topic, then Facebook post, then here it will wait HITL, human in the loop, then it will post this uh, let's say post to the Facebook platform. Okay, now you can see here, whenever we'll try to build this workflow, right? Whenever we'll try to build this workflow, so that time user will give a topic name. It's completely fine. From the topic itself, your Facebook post would be generated. Then here itself, it will wait for the human verification. Okay, here it will wait for the human verification. So that time, uh, human can give this particular verification in 1 minute, 30 seconds, 1 day, 2 day. Okay, it doesn't matter, or after 1 month also. Okay, based on the user, let's say, choice, user preferences. Okay, so it's not like that your entire workflow should be running. Let's say user want to give this permission after 2 days. It's not like that. You have to run your entire workflow 2 days. Okay, and you have to wait for the user verification. Otherwise, what will happen if you are continuously running? You are ending up with like your hosting cost, right? I don't want that. Computation cost, I don't want that. So what will happen? This this persistence, that means you have learned about this fault tolerance, right? So here basically fault tolerance concept would be applied. That time automatically this particular execution would be interrupt. Okay, interrupt it. This execution would be interrupt. Interrupt would be, it would be stopped. Okay, then human will come and give the, let's say, feedback. Let's say he has accepted this particular post. That time this workflow will again re-execute, and instead of running from the beginning, okay, instead of running from the beginning, what it will do, it will start from here only. That means the post is accepted. Now it will run the next workflow, which is post. Okay, the next node, which is post, instead of running from the beginning. Okay, and how it is remembering? Because it has the persistence concept, because all the intermediate data it has also saved. Okay, so whenever it will get the new data, that time from here only it will start. The example I showed you right now, fault tolerance, it will work in the same way. Okay, I hope you got it, guys. That's why this percentage is also required whenever you are using, whenever you are implementing this HITL concept, that is human in the loop concept. Okay, I hope you're clear. Now guys, let's try to understand the last benefit, which is time travel. Okay, the concept looks interesting. Even this is also interesting inside this LangGraph, inside the persistence. Let's try to understand what is time travel exactly. Okay, so see here, I have already taken the code example. I will just show you, okay, how things are working. So I think, remember, we just created this joke generator actually workflow, right? We created this joke generator workflow. So in time travel, actually what you can do, you can actually go to the each and every nodes, and you can see their execution. Okay, so here, see, let's say this is our workflow we created previously, right? Now here I showed you all of the execution, all of the snapshot, all of the like state update, right? All of the intermediate and final. Now let's say I want to go to a particular, let's say, checkpoint. Let's say I want to go in this particular checkpoint. Okay, where I only pass the let's say topic is equal to cricket. So what I will do, I'll just do workflow.get state, and here you have to pass the configuration. So here this was my thread 2, right? That means configuration 2. I'm passing my configuration 2. That's why you're giving the thread 2 here, because in configuration 2 I was giving the thread 2. Then here you have something called checkpoint ID. So here you have to give the checkpoint ID. Now you can see every snapshot is having a checkpoint ID. So here, if you just go right side, here you can see the checkpoint ID. You just need to copy this checkpoint ID and you have to provide it here. Okay, once you do that, now if you execute this, okay, you will be able to see that it will only return you that particular snapshot, let's say output, that particular state only. Okay, now you can ask me why it is required and how it is helpful. See, whenever you are creating any kinds of complex workflow and you want to do the debugging operation, that time this concept is required. Okay, this thing you won't be using frequently. Whenever you want to perform some kinds of debugging, you want to see each and every node execution, that time this time travel you can use. Okay, now you can see the exact same thing you are getting here. Now let's say I want to see the after that, let's say this snapshot. Okay, so I'll give this particular ID. So if I go to the right side, you will have the checkpoint ID. You just need to copy that, and here I have already passed that. Okay, now I already executed. You can see here I'm getting topic is equal to cricket, and this is the joke, and here I got the explanation. Okay, now if I show you the entire get state story, now see, initially it was 4, now 2 more snapshot is created because I did the time travel. Okay, so this is the first one, there I only got the topic, and here is the second one. Okay, now let's try to see another concept, which is update state. Okay, like let's say here I'm having this particular node, right? And each and every node is updating some kinds of state, right? Now if you want, you can also manually update your state. Let's say your workflow has generated some state, okay, but you want to update. Let's say initially I have given cricket, topic is equal to cricket, but right now I want to, let's say, debug with tennis. Okay, so what I will do, I'll just write workflow.update state, and here also you need to pass the configuration, that means your thread ID, and you have to give the checkpoint ID. Now let's say at the very first checkpoint, this was the checkpoint, right? There I give it the cricket, topic is equal to cricket. So I'll copy this checkpoint ID. Okay, I'll copy the checkpoint ID, and you have to provide the checkpoint ID here. Okay, after that, here you have to pass the topic is equal to tennis, I have given. Okay, this is a dictionary. Now if you execute, you will see that this particular state would be updated. Now if you again execute the workflow, now you'll see that another state would be created. Now here topic is equal to tennis. Okay, so that's how you can do the debugging operation. If you want, you can update your state, even you can do the time travel through your entire state. Okay, this is also possible. And here I already updated your fault tolerance code in the same notebook itself. Okay, so that you can copy paste in the Google Colab, guys. So yes, guys, this is the concept we have understood inside persistence, and by this video itself, you have now enough informations like how much persistence importance is like whenever we are creating these kinds of agentic AI application, and how persistence is helping us. Without persistence, actually what will happen? Okay, we have understood each and everything. Now I think you don't have any kinds of question. Okay, that's why in my first part, guys, I added this persistence concept, I added this checkpointer concept. Okay, now I think this part is pretty much clear, guys. Okay, so that's how, guys, we'll be implementing the chatbot in detail. I will try to make this particular chatbot more advanced. Okay, agentic chatbot more advanced. I'll try to add all of the concept one by one by explaining these kinds of concept separately. Okay, so we have created our basic skeleton, basic agentic chatbot workflow. So here you can perform any kinds of chat operation right now. So let's see if I give a message, generate a blog about, let's say, Python. So if I send this prompt, now see, it is able to generate the blog. Okay, so we have already created this kinds of skeleton, this kinds of workflow like chat workflow, and everything is working fine. Now in this video, guys, I'm going to just deep dive into this streaming, like what this streaming is and why it is required. And we'll also try to understand, if we don't use these kinds of streaming features inside our agentic chatbot or any other agentic application you are creating, so what should be the issue? Okay, so guys, we'll try to continue with our discussion of the streaming features inside agentic chatbot. And if you are using LangGraph, guys, by default inside LangGraph, this streaming features is available. Okay, with the help of that, you can easily create the streaming features. So for this, you can go to the documentation of this LangGraph. So there they have given some code example. Okay, but let me first of all show you my code example. Okay, then after that you can go through the entire documentation. Okay, and you can understand about the streaming. Okay, yeah. So guys, see, if I'm not using the streaming features, so how my chatbot will look like? First of all, let me show you. So guys, as you can see, this is the code we have already written for this agentic chatbot, and this is our first initial workflow we have created. Okay, this is the chatbot workflow we have created. And here, if you just go to the last part, so here I already discussed about the streaming. Okay, how to add the streaming features. But yeah, I think in the first part you might have some kinds of confusion, like how we have added this particular stream features here. So in this particular video, I'm going to clarify each and everything. Then I think this would be more clear. Okay, so here what I'm going to do, guys, let me show you the non-streaming like features first of all. So I think this code is also common. Initially I also created this code, and you remember there I'm not using any kinds of streaming features. Okay, so what I'm doing, I'm just generating the response. After that I was waiting for the entire response. Once I got the response, I was just showing on the Streamlit user interface. So if I execute this particular file, let me show you. So I'll stop my app.py and I will execute this non-stream.py. So I'll just write Streamlit. Okay, Streamlit run non-stream.py. Now if I hit enter, so this will load my application. Now here, let's see if I give the same prompt, generate a blog about, okay, about, let's say, I'll give machine learning. Now see, if I give this prompt, now see, here we have to wait, right? We have to wait till the execution. Now see, so here I think you have observed we had to wait unless and until this output got generated here. So let's say if you're generating some more, let's say, content here, some more big content, that time it will take some time. Maybe it can take, let's say, 30 seconds, 60 seconds. Okay, it depends upon your output or the prompt you are giving. Let's say you are running an agent, and that agent is taking time, it is using some kinds of tool. Okay, so in between actually it will do lots of work and you have to wait for the execution. So this is not good, right? This is not good user experience. So if I open chat gpt, okay, if I open chat gpt, in chat gpt, if you give any kinds of prompt, let's say I will give the same prompt in the chat gpt. Okay, you'll see that ChatGPT also will give you some kinds of streaming response. See, this is giving you a streaming response one by one, right? And this is more interactive, right? This is more interactive because we don't need to wait for the entire execution to be completed. Okay, whether it is using any kinds of tool, whether it is doing the reasoning operation, it doesn't matter, but I'm able to see my output token by token. Okay, so this is good user experience here. But inside this particular application, this is not good experience. So if I give this kinds of prompt, so what is happening? It is taking some time, right? That's why I'll give right now deep learning. See, it's taking lots of time. So this is not a good experience. Okay, so that's why streaming features is required. Okay, streaming features is required. Now let's try to understand what is streaming exactly and why it is important inside our application development. So guys, first of all, let's try to understand what is streaming. So here I have already written a definition. In LLM, streaming means the model starts sending tokens, that means word, as soon as they are generated, instead of waiting for the entire response to be ready before returning it. Okay, see what happens whenever we are using any kinds of large language model. It generates the output as token by token or word by word. Okay, so whenever, let's say, we invoke any kinds of large language model, let's say this is our LLM, and we are giving some kinds of prompt here, and we get a response here. Okay, so what you can do, either you can get this response in one shot, that means you have to wait for the entire output to be generated. Okay, for this we use something called invoke function. Okay, invoke function, I think you already know that we are using. Okay, so far, so invoke, what it does, it will wait for the entire output to be generated, but LLM will try to generate the output as token by token. Let's say it is generating something. So first of all, one token will come, then another token will come, another token will come. Okay, that's how it will complete the entire execution. Okay, that's how it will complete the entire execution. Then you will be able to see the response. But in streaming, actually what we do, we use something called stream function. Instead of invoke, we use dot stream function. This is already a default inside LangGraph whenever we are defining any kinds of graph object, right? And you remember we are doing the invoking operations. Instead of invoking operation, we have to perform dot stream operation. So if you do dot stream operation, so what will happen, that time you will be getting this particular output as a token by token or word by word as soon as they are generated. Okay, instead of waiting for the entire response to be ready before returning it. Okay, so this is what actually your streaming is. I think you already saw inside ChatGPT. Okay, ChatGPT, it was generating token by token. Let me show you again. So maybe I can give another prompt. So I'll give, let's say, generate a blog about deep learning. Now see, it will generate the output token by token. You can see token by token it is generating. Okay, now I think this definition is pretty much clear. Now let's try to understand why this streaming is required. Okay, you can see the first point, faster response time and low drop off rates. Okay, I think by this point itself you can understand what I'm trying to say. Faster response time is, let's say, whenever I'm using any kinds of chatbot, let's say I'm using ChatGPT. Okay, I'm using ChatGPT or any other thing. So there I definitely need a faster response. So if it is not giving faster response, that time, like I won't be getting interest, right, to use this particular application, because nowadays time is expensive, right? Time is expensive, and nowadays people don't have that much of time so that they will wait for the entire execution. Okay, that is taking 1 minute to run, so they don't have that much of time. They will wait and they will get the let's say entire output. Okay, so they need a faster response. So definitely faster response is required whenever you are creating any kinds of application, whether you are creating chatbot, whether you are creating AI agents. Okay, anything you are creating, faster response is required. Otherwise what will happen, there would be a drop off rates. Okay, drop off rate means people will leave your application. Okay, let's say if it is taking 1 minute to run, so definitely I'll leave your application. Okay, I'll leave your application. I will look for some other application which can give me faster response. So that's why if it is faster response time, that means low drop off rates. Okay, low drop off rate means people will not leave your application. They will be continuously using. Like ChatGPT, people are using daily, right? Because it is having the faster response because of the streaming features. Okay, we know that LLM takes some time to generate the entire output, but we have to handle it smartly instead of waiting for the entire, let's say, output to be generated. Whatever token it is generating, okay, one by one, we'll show to the user so that they will see something in the screen. Okay, this is what we have understood in the first point. Now, the second point you can understand, guys, mimics the human-like conversation, build trust, feel alive, and keep the user engaged. Okay, see, whenever you are doing any kinds of conversation with any kinds of agent or chatbot or whatever you are doing the conversation, so definitely there some kinds of engagement should be there. Let's say if this application is taking 1 minute to run, right, and you have to wait for the execution, so definitely I can't tell this is like a human like conversation. Let's say you are talking with someone, let's say this is you, okay, this is you and this is someone, you are talking with someone, right, and if you're asking something and let's say this person is taking 1 minute to give you the response, so definitely you will not feel like interest, you will not feel engaged. Okay, you will not be able to build a trust with that particular person. Okay, I can give you another example. Let's say, I think nowadays people are using lots of hardware assistant, right? Hardware assistant means like Amazon Alexa, then Google Home Mini. Okay, Google Home, many people are using that, right? So this is kinds of personal assistant system. And what we do, we use this particular assistant system so that we can speak with them, right? Speak with them and we can do lots of tasks. Now let's see, if you're talking with your personal assistant, you are talking with your, let's say, Google Home Mini. Okay, you are talking with your Google Home Mini, and let's say it is giving you the response after 1 minute. So definitely you will not feel engaged, you will not feel alive, you will not feel you are not going to build a trust, okay, with that particular device. So that's why mimic human like conversation it is required. So whenever I will talk with my, let's say, bot or let's say agents, so I'll feel like, okay, I'm talking with the human. Okay, instantly I'm getting the response and the response is engaging as well. Okay, like chat gpt, if you're using chat gpt, I think you know that this engagement, then alive, trust is super important, right? And we found inside that particular chatbot, right? That's why we are using continuously. So that's why this is super important. Then important for multi-model UIs. Okay, so whenever you are using multi-model and you are creating a user interface, so this is also required there. Okay, sometimes you will be generating some kinds of image, and whenever you are generating the image, that time you can show like, we are generating the image, we are taking this particular, let's say, color, or there should be an image window continuously, it will tell, okay, we are generating something. So that's why you have to show something. Streaming means you have to show something on the screen, okay, instead of just keep waiting the user here. Then better UX for long output such as code. So whenever you are generating any kinds of code, let's say you created an agent that generates the code, so instead of waiting for the entire code generation, you can show the streaming. Okay, like it is importing, it is defining the model, it is creating the architecture, so one by one you can show it here. Okay, so this is another user experience we get. Then you can see you can cancel midway savings tokens. That means whenever, let's say, you are chatting with your agents or chatbot, and you are generating a long form content, right? And let's say you found some kinds of content useful and you don't need the remaining content. So what you can do, you can stop, you can cancel the midway execution to save the token. Because what happens, whenever LLM generates the output, it generates as a token, right? And whenever you're using any kinds of provider, let's say OpenAI or Gemini, it charges based on the tokens, like how much token you are giving as an input and how much token your model is returning as an output. Okay, based on the token count, it will charge you. So let's say I don't need some unnecessary information, so definitely I can stop the execution and I can save my tokens. Okay, this is only possible whenever you are adding these kinds of streaming features. So if you are adding like one shot output, that time this is not possible. Okay, then you can interleave UI updates, example, show thinking, show tool result, okay, etc. So whenever we'll be creating any kinds of agents, so definitely it will be using tools, right? And whenever it is using tools, that means that execution will take some time. First of all, tool will be executed and this will fetch the informations, then it will pass to the LLM. So it's taking some time, right? That time, instead of waiting, I can show something in the user interface. Let's say it is right now using this particular tool, and this tool is facing this kinds of information. Okay, I can just show these kinds of output to the user so that user feels like, okay, now my application are using some kinds of tools, so that it will generate the final outputs. User will wait. But if it is if you are not showing that, so what will happen, user will think like, okay, my application got hang, so definitely they will leave your application. Okay, so that's why this streaming is super important, and we need this streaming whenever we are creating these kinds of agentic system, guys. Now we have already understood this streaming. Now let's try to understand through the code. Although I have showed you the code implementation before, so let me show you. So this is the code implementation I showed you. But in this video, let me show you how things are working. Okay, how we are adding these kinds of streaming features. So for this, I think you know we have already written this agentic chatbot backend. So in the backend, I already created the entire workflow. So this is our workflow we created, and this is our chatbot object we created. Okay, this is the graph. So what I can do, maybe I can show you. I will create another file. Let's say I'm going to name it as test.py. So inside that, I'm going to first of all import my chatbot from agentic backend. So from agentic chatbot backend, we are importing chatbot. Now see, if I'm not using this, if I'm not using streaming, that time I was using Invoke. I think you remember I was using Invoke, and we also need to import this library as well. Yeah, human message and base message we have to also import. So let me check again. Then I need to also pass the configuration as well. So let me copy the configuration. Config should be also passed here. So I'll also import the define the configuration, because we're using persistence here. Okay, we have to pass the thread and everything. I think you know that. Now we'll try to replace with that. Yeah. Now this is the code, guys. So basically we are using invoke here. And if you're using invoke, so that means you have to wait for the entire execution to be completed. Let me show you. Now let's say if I stop the execution, Python test.py. Now see, we have to wait for the execution. Maybe I can show you with another question. Generate a blog about Python programming. Now we'll be able to observe. Now see, okay, you have to wait for the entire execution. So this is not good. Okay, now we have to add the streaming features here. So here, instead of using invoke, we'll be using dot stream. So you can write like that, chatbot dot stream. Okay, stream. Now stream takes some argument. First of all, you have to provide the masses. Okay, I'll try to provide the masses. Yeah, we'll try to provide the masses. Now let's say I'll give the same message, generate blog about LangGraph, or let's say machine learning. Okay, this is the message. Now the second parameter, you have to provide the configuration. Okay, and the third parameter, you have to provide the stream mode. Okay, now there are multiple stream mode are available. If I go to the documentation, as you can see, we have update values, message, okay, custom. So here I want to print the message only, so that's why I'll be using stream mode is equal to message. Okay, because I want to show my message streaming. Okay, whatever output I'm getting from my LLM, I want to show this. Okay, that's why we're using this. Now once it is done, now if I, let's say, show you the result. See, this stream will return two things. One is the message chunk. Okay, message chunk. That means the token. Okay, token output. And it will also give you some kinds of metadata. Okay, metadata, but I don't need the metadata. I only need the message chunk and metadata. Okay, so basically this returns a generator object. Let me show you. So I'll give you example response. Now if I print the response, now if I execute this code, python test.py, so this will give you a generator object, as you can see. Okay, stream generator object. And you already studied it inside Python. If we are getting the generator object, I can use any kinds of iterator to get the output. And what is the iterator? We can use for loop here. Okay, for loop will try to iterate the output one by one here. Okay, instead of getting everything in one shot, it will take one by one. So for this, I will just write a for loop. So now I can write like that. Instead of going through the response, maybe I can write the for loop here only. I think that would be amazing. So for it will return two things I told you. One is the message chunk, and it will return the metadata. Okay, in chatbot.stream. Okay, now I will keep this one. Yeah, now here I'll just write a condition. If let's say message chunk um, dot content. Okay, I will extract the content only. Okay, if there is a content, sorry, content, I'll just try to print this content. So print message chunk dot content. Okay, and here I will give some other parameter like end is equal to this empty string, and I will give this splash is equal to true. Okay, these two things you have to give. If you check the documentation, they have written the same thing. Okay, now let me show you how this output would be generated. Now I'll execute my test.py. Now see, it is giving you token by token as a streaming output. Okay, I think you saw the difference, and that's how we can implement the streaming features inside LangGraph. Okay, I hope you clear. Now the same thing you have to also do in the user interface, because in user interface we created, this should also show as a streaming output. And how we have done, guys, I think I already written the code. Let me show you. See, it is available in the app.py. So here is the code, guys. Okay, we written already. Now we are using something called this one, write stream. Here from Streamlit we are using write stream. So if you go to the Streamlit documentation, as you can see, Streamlit has having a chat element. So it is having multiple chat element like chat input, chat message, start as container, and there is another one called write stream. Okay, if you check the write stream, so they have already written like how to actually write this particular, use this particular write stream. Okay, so we are using this write stream here. Let me show you. We are using this write stream. So inside that we have written the same code. We are instead of doing the invoking operation, we're doing the streaming operation. We're giving the input, config, and stream, and we are running the for loop. It is returning two things: message chunks and metadata. We're only taking the message chunks. Okay, and once we got the message chunks, what we're doing, guys, we are just writing the stream on the Streamlit user interface. And once everything is done, we are updating inside this message story inside Streamlit session state. Okay, this is a simple code we have written. Now I think this code is clear, guys. Okay, how I have written. So I think many people has the confusion how these things are working. Now I think this is clear. Now let me show you the final execution. I will clear. I will run my app.py. So Streamlit run app.py. So this is our app. Now I'll give generate, let's say, code for image classification in Python. Now see, okay, see, streaming output we are getting. So yes, guys, this is all about from this video. I hope you got it. What is the streaming and why it is required. and why we have implemented inside our chatbot. So if you check my agentic chatbot, guys, so far we implemented till here. So here we can perform any kinds of chat operation right now. Okay. And you can see it's working, and it is also giving you some kinds of streaming response like ChatGPT, right? So in ChatGPT, what happens, guys? In ChatGPT, you can resume your conversation with your old traits. Let's say I did some kinds of conversation previously. I can continue anytime. These are the conversations. So let's say this was my previous traits, right? So if I open this particular traits, I'll be able to see all of my conversation story. Okay, and I can resume my chat from here only. Okay, I can resume my chat from here only, right? Now like that I can go to any another threads. Let's say I will go to these these threads. Okay, so from here only I can do my conversation. So this is called trading. Okay, with the help of this trading we can separate out each and every topic, let's say masses. Okay, let's say right now I want to do a conversation related let's say deep learning. Let's say I need another new session for another topic. Let's say I want to do the conversation regarding, let's say, NLP. It's like that. Okay, instead of doing all of the conversation in a single thread in a single session, you can create multiple threads. Okay, and you can do the conversation anytime. You can come here, you can see the older conversation as well with a different threads. But this kinds of feature is not available inside our agentic chatbot. So in this video, what I'm going to do, guys, I'm going to implement this particular features so that you can also get your older threads and you can also see all of the old threads conversation as well, and anytime you can continue your conversation from there only. Okay, so these kinds of features we'll try to add in this particular agentic chatbot in this video. So make sure, guys, you watch this video till the end, don't miss anything. And if you found this content useful, please try to subscribe to my channel and hit the like, and please try to share it with your friends and family. So instead of talking too much, guys, let's start the implementation, and I'm going to show you how we can add these training features inside this agentic chatbot. So guys, before starting the development, first of all, I want to show you the final result, final demo, like what are the features we are going to add in this particular agentic chatbot. So as you can see, we already added these trading features inside our agentic chatbot. Previously, it was a simple chatbot only. Okay, there we didn't have any kinds of trading features. Like I can't see my older trades, right? It was not there, but in the new update, as you can see here, we have added a separate section. So from here only you can go to your previous conversation. So let's say here I am doing a conversation. Let's say I'm asking what is Python, right? Let's say I will ask, my name is Bappy and I'll tell what is Python. Now you can see Python is a high level programming language and blah blah blah. Now if I ask what is my name, now it is telling your name is Bappy. Okay, so this is a conversation we have done in this particular threads. As you can see, we are using unique ID, right, to save this particular conversation story in this particular threads. Now what you can do, like the chat GPT, you can start a new conversation here. So I will click on new chat. Now see, it will give me a completely new threads here. Now here if I ask what is my name, okay, what is my name, you'll see that I'm sorry, I'm a AI assistant, I do not have access to your personal information. Now if I ask my name is Alex, what is ML? Now see, it is giving you the response. Now if I ask what is my name, now it will tell your name is Alex. Okay, now see, this particular conversation is completely separate from your previous conversation. Now I can go to the previous conversation anytime, okay, where I did like my name is Bappy, what is Python. Now here I can continue the conversation. Let's say now I'll tell I want to see hello world program. Now see, it is giving you the hello world program because we did the conversation related Python. Okay. And here we are doing the conversation with the help of Bappy. Okay. So here Bappy is doing the conversation. Now, even I can go to my previous conversation as well. So this is my previous conversation. This one, my previous conversation. Now here you can anytime resume the conversation. Let's say how it helps in AI. See how machine learning helps in AI. It is telling you each and everything. Okay, so that's how you can create different traits, and you can see your older conversation as well, like ChatGPT. So ChatGPT does the same thing. It also using trading concept, and every time whenever you are doing that chatting operation, it is continuously saving your conversation history in a one particular traits, and you can start new conversation anytime, but the older conversation will remain same. Okay, so this kinds of thing guys we have added inside this particular agentic chatbot. Now throughout the entire video I'm going to show you the implementation part. So guys, this was our previous code we have already written. So as you can see, this was our previous app, and it doesn't have any kinds of trading related code. Although I added the trading, as you can see, I added the trading, but it was hard coded. So only I was using trade one for all the conversation. Okay, that's why this application was simple. Now I'm going to use the same code and will be writing the trading features inside this agentic chatbot. So what I can do, instead of giving the name to app.py, maybe I can give another name just for your reference. So let's say uh, um, whenever you want to refer this particular simple code only, that time you will be able to get this code from here. Okay, so I can also replace the code in my app.py, but I think you won't be able to get the previous code that time. So that's why I'm going to create a new file. So first of all, let me rename it. So this is, let's say, simple app. Okay, this is simple app we created. Now I'm going to create another file. I'm going to name it as app underscore trade. Okay, that means this code has the trading code. Okay, trading related code, trading related features. Now what I can do, I can copy the same code as it is here. Okay, yeah, and here this backend code will remain same. The backend code we have written, this code will remain same. Here you don't need to change anything. The change would be applied in the front end part only. Okay, because in the backend we are only returning the chatbot this graph object. Okay, so here what I'm going to do guys, first of all I need some more library. So let me import. So I need so here I need UUID. So with the help of this UUID, I'll try to generate unique ID so that I can separate out my each and every threads. Okay, instead of doing the hard coding. So every time I will generate a unique ID and I'm going to create my threads. Okay, first I'm going to create one function that will generate unique ID. Okay, unique user ID, because every time I need this unique user ID for this particular trading, right? I already showed you that part. So for this, let's create a function. So this is the function guys I have already created. Yeah, so this function, what it does, it generates unique ID, unique user ID every time. Whenever you will execute this function, it will give you unique user ID. So after getting this unique user ID, what I want to do guys, I want to add this unique ID inside my threads. Okay, so for this I can create another function called add threads. So what this add threads will do, basically it will add a new threads ID to the conversation list. Okay, so basically this will get the thread ID, and where you will get the thread ID, will get from this particular function. First of all, it will check this thread ID, it is available in the session state or not. Okay, that means streamlit session state or not. We'll try to save with the help of these chat threads like key. So if it is not there, it will try to set my trade ID. The trade ID it will generate. Okay, so this is a simple function we have created, because whenever you will try to initialize your application for the first time, there it won't be having any kinds of chat threads, right? So that time one new threads would be created, completely new threads would be created, and it will try to append there, and with that particular threads only will do the conversation. Then later on, if user wants, they can create the threads, okay, as per their requirement. Now you can see this chat threads is not available, so we have to also create that. So if you just go below, so I think remember we created message history previously, so here only I'll try to add another one. So after message history, so we'll just try to write this chat threads, okay. As you can see, if chat threads not in session state, it will create a empty chat threads, okay, and this will become a list. And right now we'll be able to append that particular threads, because now this chat threads session is created, okay, here only. I will also try to add the comments in my previous code as well, so that later on whenever you are revising this code, I think it will be helpful for you, okay. By seeing the comments only, you can understand what this code is doing, okay. You can see this code actually creates the message story when the app runs for the first time, okay. I already created previously, I think, remember. So once it is done, now let me add the user interface, because if you go to the chat GPT left hand side, you will be able to see all of your conversation, okay, all of the threads. So we'll try to create the same thing here. So for this, let me just create a sidebar first of all. So here I'll just try to add a sidebar with the help of Streamlit. So I already commented out, this is that sidebar trading features. Display the sidebar title. So st.sidebar.title, I just name it as my conversations. Now if I execute my code, okay, if I execute my code, you will be able to see that. So Streamlit run app underscore trade dot py, okay, this file we are executing now. If I show you my code, so as you can see guys, this is our sidebar we created. So anytime you can open and close it, like the chat GPT also has the same thing, okay. This is the sidebar. Now here only we'll be adding our trading, okay. So for this, let me just show you my updated code, what I have done. I can show you step by step, I think that would be best. So what I can do, I can just quickly show you. Hmm. So I'll just remove these are the code, okay, my old code, and I'm going to show you my updated code. I think that would be amazing. I'll just try to remove all of the code. So first we'll be adding some utility functions. First of all, generate trade ID. I already told you it will generate the trade ID every time. And another function I have written, this will basically add the trade ID where to the session state, okay. But we have to create the session state. So let's create all the session state. I'll just try to add all of the session state. So this is my message story session session state, and this is for my chat session state, okay, chat threads, okay. That means this one. And I'm going to create a sidebar here. Sidebar here, okay. So this is my sidebar. Now if I go to my application again, if I refresh, now see, it looks like that, okay. Don't worry about this chat input feature, I'm going to add it. Just let me update my this code first of all, then I'm going to add, okay. That will remain same like we did the previously, right? Now what I'm going to do guys, I'm going to add a new button here. So I think you remember ChatGPT also has a button. If you click on this new chat button, it will start a new conversation for you, and you will be able to see the old threads as well. So these kinds of features we'll try to add here. So this is the code. I'm going to tell you about this reset chat, what this reset chat will do, but let's try to understand. See, this creates a button for starting a new conversation. So there would be a button st.sidebar.button new chat. And if you click on new chat, see what will happen in chat GPT. Let's say I'm inside a threads. Let's say I'm inside this particular threads. Okay, I'm inside this particular threads. Now once I click on new chat, you'll see that one new window will come and all of the previous chat history will be cleaned up, right? So for this reason, I'm also going to write a function called reset chat. So whenever user will take the new chat, all of the previous conversation would be removed. So for this, let's create another function here. I'm going to name it as reset chat. So after this function, maybe I can add, okay, reset chat. So what it is doing, you can see, first of all, it will basically generate a new thread ID with the help of this function, and it will store in the thread ID. The thread ID we created. Session state, I think session state thread ID is not created. So let me create it quickly. So this is my thread ID. Okay, if thread ID not in session state, it will create a thread ID and it will take a thread ID from this particular function. Okay, unique thread ID. Now it is resetting, and what it is doing, it is setting a new thread ID. Then after that, all of the message story would be empty. You can see we are giving an empty list. Then after that, we are adding this particular thread ID in my session state. Okay, you can see we are using this add thread function, and we are adding this thread ID, the current thread ID, in the session state, because whenever I'm inside this particular thread, okay, I'm inside this particular thread, so all of the conversation should be saved in this particular threads only. That's why this thing we are doing. So every time we have to track this thread ID. All right, now let's say if I go to my application, if I refresh, now you'll be able to see this new chat. Okay, now if I click on this new chat, so it will basically run this code. It will basically run this code, and all of the recent recent conversation would be removed. Okay, and we have to write this st.return if you are doing the reset chat operation. This is recommended. So basically this will return the Streamlit app to update the interface. Okay, so basically what is happening, whenever you are doing this new chat operation, it is resetting. After getting the resetting operation, it is giving you the new window. Okay, so whenever you are getting the new window, st.return. Okay, this is recommended. If you check the documentation, you'll be able to see that. Okay, now let's try to add the chat feature. I'll just try to add the updated chat feature. So I already written the code, guys. Let me show you. So this is the code. And this is the same code, guys. Only just few update I have done. So here we're taking a chat input from the user. Okay. And whenever user is giving their input, first of all, we are appending to the message story. The same thing we did our previous code as well. So message story. After that, we are setting this is a user conversation and content is user input. Okay. And why we are doing this? Because I want to save my conversation story, and this is the format to save the conversation story. First of all, you have to define what is the role of this conversation. This is user, and what is the content of that. Okay. After this, we are showing this conversation in the Streamlit user interface. For this, we are taking a chat message. I think remember there would be a icon, okay, user icon. So we are setting that this is a user icon and this is the user conversation. Okay, and here, guys, we are defining the configuration right now. Okay, this is the persistence configuration. This is the trading configuration. Config is equal to configurable. Now thread ID is equal to st.session state thread ID. Now we are not taking the hard-coded thread ID. Instead of that, see, previously we are taking the hard-coded thread ID. We are only giving thread 1, but right now there would be a multiple thread. User can create the threads, right? So we are taking it from the session state, and already session state we have created here. The session state it is already created. Session state. What is that? Yeah, session state thread ID. Now I think thread ID it is available. Yeah, you can see thread ID it is available. And how we are getting the thread ID? It is generating by the UI ID. Okay, from here only it is getting generated. Okay, I hope you get it. Now, yeah, from here actually we are showing the user assistant message. As you can see, we are taking this st.chat message. We are taking this is assistant reply. After that, we are taking the write stream function. I told you in my previous video how streaming works, right? How we can show the streaming response. So inside that, we are generating the responses from our chatbot object, the chatbot we have imported from the backend. Okay, as you can see, this is the same code, guys. There is no change we are using. After that, whatever message chunk we are getting, we are continuously writing with the help of write stream function. Okay, and here we are passing the configuration, and we are giving stream mode is equal to message. Okay, and here we are getting one suggestion. I have to import this AI message, so let's import it quickly. I'll just try to import this AI message after human message, AI message. Okay, because this streaming response should be AI message here. Okay, that's why I'm telling if is instance message chunk. If it is like a message chunk, that means we are getting AI reply, right? So that's why I'm telling this should be AI message. So this will only show the AI message here. Then we are saving the complete assistant response in this streamlit session state in the message story. So this code is common. I think you already know that. Yeah, this is pretty much clear. So after this part is done, guys, now what I'm going to do, I'm going to simply execute my app, refresh. Now see, guys, you are getting this window. Now if I do the chat operation, let's say hi. See, I'm getting the response. Now I'll tell my name is Bappy. Now see, previous message is getting replaced because I haven't added this code here. I do remember previously also I added this code and this loading the conversation history. Okay, we have to load the conversation history every time. So let's load that before the user input. So every time it will load the conversation history, message story, and it will write in the streamlit user interface as a human role and assistant role. Okay, because we are running a for loop, so every time it will looping through the role. First of all, user role will come, then assistant role, then user role, then assistant role, and their content. Now let me refresh and again try. So hello, my name is Bappy. Okay, now nice to meet you, Bappy. Now see, we are able to see the previous conversation. But right now what I have to do, so let's say if I click on a new chat, okay, new chat is coming. Okay, it's completely fine. But I am not able to see my older chat, that means older threads. So now I will be adding the code related older threads. So you can also see the older threads. So what I can do, guys, I can show you my updated code I already created for this. Here I can write. So this is the code, guys, I have written. Display all the conversation threads in reverse order. And why I have to show in the reverse order? See, every time what is happening, if you create new threads, right? If you get new threads, so your new threads is coming. New thread is coming at the last. Okay, because by default Python will add this new threads at the last. Okay, but if you see, if I click on new threads, every time this new thread should be coming at the recent chat. Okay, at the first let's say order. So that's why we are reversing the order. So if my new chat is getting added at the last, if I do the reverse operation, that means from the last it will come at the first. Okay, I think you understood. That's why we're doing the reverse order operation. So this is a list. We are just doing the reverse order operation because in this session state we have the chat threads. Okay, in this session state we have the chat threads, and this is a list, and it will continuously add at the last. Okay, let's see if you click on the add new. So new chat will add here. New chat will add here, right? And this has your old chat also. But this will show at the last. But I don't want to see at the last because whenever I'm doing the new conversation, I want to see in the recent chat operation. That means it will come at the first. Okay, that's why we have to do the reverse operation. So if you perform the reverse operation, what will happen? This new chat will come here right now. Okay, before the old chat. And with the help of that, I will be able to make it in the recent conversation. So this is why we are doing this one. Just a minute. Let me. So this is why we are adding this particular code. So it is going through the entire chat threads, and here we are giving a button because this should be also a clickable object. If I click on this particular threads, it will be able to show my conversation. Okay, that's why we are making it as a button. So st.sidebar button. So button name should be thread ID only. Even you can also give any message name if you want. Okay, if you want, you can also add any message name, and the key should be thread ID. So once button creation is done, we are again saving this thread ID in our current thread, because this is the current thread user will do the conversation, and we'll load all of the conversation in this particular threads. Because if you click here, see, if I click here, it is loading all of the conversation I did previously, okay, from my memory. So I will write a function for this called load conversation. So basically this will load all the previous conversation here. So after this reset chat, maybe I can write this function. So load conversation, this will take the thread ID. And I think you remember from the LangGraph graph, we get this state. Okay, if you call this get state function, it will give you all of the previous conversation. If you want to understand this, guys, you have to go through this particular session, because here I already explained each and everything. So that's why I'm not going to repeat it again. So this get state function will return you all of the previous conversation. So we are taking all of the conversation and we are only getting the messages. Okay, from the value itself, we are only getting the messages. Okay, so these particular messages will show here. Then we are taking an empty list here. Then we are going through the messages one by one. Then we are trying to separate out the user conversation as well as the assistant conversation. Okay, so we are using is instance function for this. If you pass any message, it will automatically tell you whether it is a human message or let's say AI message. If it is human message, role should be set to the user. Otherwise, role should be set to the assistant. Then after that, we are adding inside my temporary message list all of the conversation as a role and content. Then after that, we are just updating in my session state, and it is showing you in the user interface. Okay, then again, we are doing the return operation. Now let me show you. So if I, let's say, come here, refresh. Now see, if I do any kinds of conversation, if I take a new chat, now see guys, new chat is getting created and I can see my previous conversation as well. Now let's say if I do another conversation, hi, done. Now I can go to my previous conversation. See, I can go to my previous conversation. This is the new conversation. This is previous conversation. Okay. So we have added this particular code, and I'm also able to see my conversation history. Let's say if I've done any kinds of previous conversation, I can see the history because of this code. Okay. This is continuously, where is that? This function load conversation. This load conversation is continuously fetching the informations because we are running a for loop here. Okay. So every time this message is getting fetched. And one more update we have to do. Every time we have to set the current thread to the conversation list. Okay, for this we'll try to add this particular code. Okay, now I think my application is ready. This is a simple code we have written. Only we're just playing with the thread. Okay, thread ID, and for this we're using UI ID. We can also make it as a readable title like ChatGPT. ChatGPT actually generates readable title. So if you are asking any kinds of question, it will generate a title instead of giving a thread ID. We can also do this particular update. It is also possible. Now let me refresh my app. Okay, so this is the app. My name is Bappy. Okay, so basically this conversation is getting saved inside this particular thread. Okay, in this particular thread it is saving. Now I love cricket. Okay, now if I take new conversation, now see it is coming as a new session again, and this particular session is coming at the first, and previous one was a previous one, it is going at the last because we are doing the reverse operation. Now here I'll tell my name is Alex. I love football. Okay. Now I can go to my previous conversation, and here I can resume the conversation. What is my uh, what is my favorite sport? Okay, you can see cricket is the favorite sport. Now I can go to my current trade, and here also I can ask what is my name. Your name is Alex. Okay, so that's how you can create as much as trade as you can. What is transformers? Okay, so this is telling you about the movie, but I can ask what is transformers in AI. Okay, now it is telling you what is transformers in AI. Okay, so that's how, guys, like ChatGPT, we created the threads. Now we can switch to different threads, and I can resume the conversation. So yes, guys, that's how we can add these trading features like ChatGPT. Now if you want, you can also change this name to the actual, let's say, chat title. If you want, you can also add inside this code. So I'll try to give this part as an assignment to you. Maybe you can add this functionality in this code. Okay, simply you can go to the chat GPT and you can ask, I want this particular features, how should I add? You will be getting the suggestion. Okay, so just try to add this update instead of showing you this unique user ID. Maybe you can show chat title like chat gpt, the way chat gpt shows. Okay, you can also add this particular things. So we have already integrated this chat trading. Now we are able to continue the conversation with our previous chat as well. That means right now I can separate out my chat threads. I can create a new conversation. I can continue with my old conversation like chat gpt. So yeah, we have already added these trading features. So what will happen right now, let's say if I continue any kinds of conversation, let's say here I will give, hi, my name is Bappy. Okay, so as you can see, it is giving you response. Nice to meet you, Bappy. How I can assist you today? Now let's say I want to create a new chat like ChatGPT. So what I will do, I'll just click on new chat, and you can see one new thread has created. Okay, new conversation has created. Now here I will tell, hi, my name is Alex. See, hello Alex, how I can assist you today? Now I can go to my previous conversation where I told my name is Bappy. Even I can continue with my the current conversation I did, right? So that's how you can create as much as session you can. Okay, but I think you have observed one thing, which is if I refresh the application, okay, let's say if I refresh the application, so see, my previous conversation is getting erased. Okay, previous conversation is getting removed. So whenever you are refreshing, okay, whenever you are refreshing, that means your RAM is getting cleared. Okay, and all of the conversation is getting erased. And if you close your application as well, let's say if I disconnect from my terminal, so what will happen? From the RAM itself, it will be removed. And again, you will be able to see the new chat here. You won't be able to see the older conversation. This is the problem. So yeah, today in this particular video, guys, we'll try to understand how we can add the database features inside the agentic chatbot, so that whenever you are refreshing, right, your agentic chatbot, you will be able to see the old conversation. Right now this is the problem. So right now if you perform conversation with your chatbot, and if you are creating different, let's say, chat threads, so if you refresh your application or if you close your application, it will be removed from the RAM, right? So these kinds of things we have to fix. So that's how, guys, we'll try to add new features inside this agentic chatbot, and we'll try to make this agentic chatbot more advanced, and we'll be learning this particular project. Okay, so if you found my content useful, guys, please try to subscribe to my channel and please share it with your friends and family, and please support me, guys. If you support me, so definitely I will be bringing this kinds of content more, okay, on my channel. So instead of talking too much, guys, let's start with the implementation. And here in this video guys, I'm going to show you how we can integrate database functionality in the persistence memory. So guys, I have already shared the source code with you. It is already available in the video description. So if you open up my previous code guys, I have already written this code as you remembered. So there I try to integrate these trading features inside our agentic chatbot. And this is the code we have written, right? So this is the entire code. And the change we have done in the front end, because you can see this is the front end file, and we had another file which is the backend. Okay, in the backend itself I had my like let's say agentic chatbot backend. So here I created the chat node, then the uh, graph and edges. Okay, each and everything I initialized it here, and I was returning as a checkpoint sorry chatbot graph object. So here if you see in this particular backend file, here I was using this memory saver, okay, from the checkpointer, LangGraph checkpointer. So I was importing LangGraph dot checkpoint dot memory import in memory saver. So if you're using this memory saver, that means what is happening, you are storing all of the conversation in the RAM, and whenever you are refreshing or closing your terminal, it is getting erased, okay, because RAM is a temporary memory. Now we have to make it as permanent. Okay, for this we have to use some kinds of database. Now if you visit this LangGraph documentation, you will be finding like some database they are suggesting whenever you are creating these kinds of persistence memory. So if you check the LangGraph documentation, there you will be getting some kinds of database like SQLite database they are suggesting. So SQLite database when you can use whenever you are creating the prototype, right? As of now, we are learning, we are trying to implement this agentic chatbot. So we are in the learning phase. Maybe we can utilize the SQLite database because this is completely free to use. And SQLite database actually basically it will create the instance inside your local storage. Okay, but you can also utilize any production grade database like Postgres is there, then some other database are also there. Okay, you can also utilize that. So going forward, whenever we'll try to create production grade actually agentic chatbot, that time I'll try to use these are the database. But right now we are in the learning phase, so we'll try to use some kinds of prototype based database. Okay, I can utilize SQLite database because this would be lightweight for me and I don't need to take any kinds of subscription plan for that, right? So that's why I'll continue with the SQLite database. So if you go to the SQLite documentation, um, so this is the SQLite documentation, guys. So this is basically a database. This is a database actually you can utilize with the help of Python. And if you're using this LangGraph, guys, LangGraph also has the connection with SQLite. Okay, for this you have to install one library. This library, LangGraph checkpoint SQLite. Okay, so you have to install this particular library. If you install this library, you will be able to use this SQLite with your LangGraph. You can also separately install this SQLite if you are only using Python programming. That time separately you can utilize. But here we want to utilize with the help of this LangGraph. Okay, that's why LangGraph connection is also there. LangGraph SDK is also there. Someone I think has created this and published on the PyPy, and we are able to use this package inside our development. Okay. If you check the LangGraph documentation, guys, here in the memory section, as you can see, add short-term memory. That means this is the persistence memory. As you can see, short-term memory, trade level persistence. Okay, so here, as of now, we use this memory saver database. Sorry, memory saver actually storage. Basically, this stores your conversation in the RAM, and you can see they are also suggesting for the production. So for production use, either you can use Postgres. Postgres, it is also production grade database, and you can create a Postgres server. Either you can create a local server, localhost server, either you can create a cloud-based servers. Okay, so yeah, any kinds of cloud you can set up this Postgres. Either you can use like Render, either you can use AWS, GCP, anywhere you can set up this Postgres server and you can connect with your LangGraph. Okay, this is possible. So that's how you can also use MongoDB. You can also connect with MongoDB. You can also connect with Redis. You can also connect with Oracle. Okay, that's how it is having different database connection. But whenever we are creating prototype, I think this SQLite is fine for us because we can set up inside our um, local storage only. Okay, I don't need to take any kinds of separate server for that. Okay, that's why I'm using this SQLite. Database doesn't matter. You can use any kinds of database. Anything will work, but only you just need to know the like connection, okay, integration, how we can integrate the database. Okay, right now I'm integrating the SQLite. Maybe you can also integrate any other database. Only you just need to get this connection string. Okay, let's see if you're setting this database in a server. You just need to get this connection string. Okay, if you get this connection string, you can check the documentation and you can copy this code and you can change it anytime. Okay, it's up to you. So here the main change, guys, I have to do in the backend file, because in the backend file I am using this memory saver, and instead of memory saver I have to use my this one. I have to use my database. Okay, so for this I have to first of all install this library. Where is that? Yeah, the install this library. So I'll copy this command, or I can copy the name, and I will add inside my requirements. Now let's install it here. Pip install -r requirement.txt. So for me, it is already satisfied because I installed it previously, but for you, it may take some time. So once installation is complete, guys, I'll open up my backend file, and in the backend itself, I'll try to change that. So here, what I'm going to do, I'm going to, should I change in the same file or should I create a new file? If I change in the same file, then you will be able to, you won't be able to get the older code. So what I can do, maybe I can create another file. Okay, so I'll create a same file. I'll just rename it Agentic Chatbot backend. Here I'll just try to add DB backend. Okay, DB backend means it has the database integration. Okay, that's how you will be able to see the previous code as well. Okay, yeah, I think this is fine. Now here, instead of this memory saver, we have to import on this SQLite saver. So from LangGraph checkpoint, here you have a class called SQLite. Okay, and instead of memory saver, we have to import SQLite saver. Okay, SQLite saver. So you have to import that. So once it is done, now I'll just go below, and here you can see I created a checkpoint object and I use this memory saver. Instead of memory saver, I will use my SQLite saver. Okay, this class. Now this SQLite saver takes a connection object. Now you have to initialize the connection object, database connection object. Basically, you will be connecting with the SQLite database. So for this, you have to import this SQLite library. Import SQLite 3. Okay, SQLite 3. So this is already available inside Python. Then after that, here I will create a connection object. So to create the connection object, guys, you just need to initialize this SQLite 3. Then there is a function you have to call connect. Okay, connect, and inside that you have to give a first parameter, which is database. You have to initialize the database. Okay, so here basically this SQLite creates the database object inside your local storage only. That means inside your project folder only it will create a database. Okay, it will create a DB file. So you have to give the DB file name. So here I'm going to name this file as chatbot.db. Okay, and here you have to give another parameter, which is check same thread is equal to false. Okay, why we have to give this particular parameter? Because I think you remember we are using the threading concept, right? Chat threading concept. So every time user is creating separate threads and they are doing the conversation, and by default actually SQLite doesn't support actually multi-threading. That means you can't apply the threading. You can't create a different threads in the SQLite. Once you have created one particular session, you have to continue the same execution in that particular session only. Okay, by default this parameter basically it's true, right? But if you make it as false, then SQLite will try to give you the access for the threading concept. That means you can do the multiple threading chat. Okay, that means you can store your checkpoint in a multiple threads. Okay, this will basically allow that particular option. That's why we have given check same threads is equal to false. Okay, I hope you're clear. So this is basically here you will be getting a connection object. So I'm going to store inside a variable. Let's say this is connection object. Now this connection object you have to pass inside this SQLite server. Okay, you have to pass inside this SQLite server. So once you have done that, now you will be getting the checkpoint. Okay, now this checkpoint is not a simple checkpoint. It will not store your conversation. It will not store your checkpoint inside the RAM. Okay, instead of that, it will save the conversation or checkpoint inside a storage service, inside a database storage, which is chatbot.db. Although this storage service will create inside your computer storage only, but this is not storing inside a RAM. Okay, it will store as a file, and we know that unless and until we are not deleting the file, this file will be available inside my computer. If I turn off my computer as well, this file will remain same. Okay, this is the main benefit here. So once we have done that, guys, the same code you have to write here. No need to change anything. Now let me show you whether it's working or not. So here maybe I can test this file. So for this, let's do the invoke operation. So here what I'm going to do, guys, I'm going to just do the invoke operation. So response is equal to, yeah, so I have written like that. So I just created a config, because you know that we're using persistence memory and we have to pass the config whenever we're doing the invoke operation. So here by default I have taken this default thread. I have just done hard coding operation, and we're invoking and we're giving the message, hello, how are you? Or let's say I'll just give my name is Bappy. Okay, and we're passing the configuration, and this will give you the response. We'll try to print that as well. Okay, now see if I execute, what will happen? You will be able to see one chatbot.db file would be created here. So Python agentic chatbot db backend, right? db backend.py. If I execute, see chatbot.db has created, and we are getting the response. As you can see, I given my name is Bappy, and my AI message, that means my agent has replied, hello Bappy, how I can assist you today, and some other, let's say, metadata informations we are getting. Okay, now you can see one chatbot DB has created. You can also visualize that. Okay, it is also possible. For this you have to install one extension called SQLite Viewer. SQLite Viewer. Okay, I have already installed this extension inside my VS Code. If you don't have, just try to install that, and you can see this is the publisher, Florian Clamfer. Make sure you install the same version. Okay, once you have done that, you just need to double click on this chatbot DB, and you will be able to see this checkpoint. It has saved in the memory, as you can see. Sorry, not memory, in the database, as you can see. Okay, now you can see it has stored my checkpoint, and this is the thread ID. Okay, we have given default thread. As you remember, we have given what is that, chatbot backend. Okay, not this one. Yeah, this one. We have given the default thread. Okay, now you can see default thread. Now you can ask me why this three time it is coming, because as per our workflow, guys, the workflow we have created, it has three checkpoint. One checkpoint at the start position, second checkpoint in the chat node position, and another one is the end position. Okay, I think I already told you about this, right? In my this video, persistence video, I already told you about that, right? So please go through the persistence video if you don't understand the checkpointer concept, like how many checkpointer would be available, in which node it would be available, each and everything I have discussed here. So here we are having three layer. Okay, three layer inside this sorry, three node inside our agentic chatbot. That's why three time this checkpoint is getting created, and all of the checkpoint ID as well as the checkpoint some meta information is also available. Okay, and if you want to see the checkpoint, guys, directly you can click here. So if I click here, you will be able to see the data. Now this data it stores basically in a binary format. It's not readable properly, but I think some of the messages you can still able to understand, like my name is Bappy. Okay, I have given. Now let me show you whether it is able to store my checkpoint inside my database or not. So let's say if I re-execute my backend, whether I will be able to see my old conversation or not. Let's say I given my name is Bappy. Okay, So this checkpoint would be available or not. Okay, so for this maybe I can just give a separate name here. Let's say Alex I will give. And what you can do, you can also change the thread ID if you want. Let's say I will give default thread 1. Okay, now if I re-execute my backend, okay, now if I open my database, I have to refresh this. Okay, now see, another thread got created and still my previous thread is available here. Okay, previous thread is available, and in the response also you can see my name is Alex, and this is a separate thread it is coming. Okay, so that's how guys we have seen it is able to store my checkpoint, still it is able to store my conversation inside my database. Okay, amazing. Now this is ready. Now we have to add we have to integrate this thing inside our front end app, because right now we tested inside the backend file only, but I have to add inside my front end. So what I'm going to do guys, I will open up my front end. So this is the front end app thread, or maybe I can create another same file. I'll just try to copy and paste, and I'll just rename it app uh, db. Okay, so with the help of that you can understand, like this is actually database, this is trading, this is simple app. Okay, you can understand. So db means this has the database actually update. Now see here, you don't need to change I mean in all the code, only just change you have to do here in the chat threads. Okay, so whenever I was actually creating this session state in the streamlit, right there I was using a simple list only. Okay, and whenever you are using simple list, that time what is happening, if I am refreshing my application and it is re-executing from the beginning, and this particular list is getting created again, and all of the data we had inside the list, it was getting erased. Okay, this was the problem. So instead of taking this simple list here, so here I have to connect my database. Connect my database means in the backend I am already storing my checkpoint inside my database, inside my SQLite database. So what I'm going to do, instead of actually giving a simple list here, I'll try to load my all of the threads, okay, from my database only, and I will just try to provide a list here. Okay, so for this in my backend code, I'll just try to do a simple modification. I'll remove this code, it's not required. So here I'll just do a simple modification. Let me show you the modification. Yeah, so here I'll just try to write a function here. I'm going to name it as get uh, all threads. Okay, get all threads. So here I'll just try to first of all show you this one. See, first of all I will write a script, then I'll just try to convert to a function, otherwise I think you might get some difficulties. So here first of all I'll write my checkpoint. Checkpoint. Now see, checkpoint object is nothing but it's a database object. Right now we are using SQLite Sabre, so it has a function. The function name is list. Okay, list. So if you give this function, call this function list, and if you execute, so what will happen, basically it will return you how many threads right now you are having inside the database. But inside this list function, you have to provide a parameter. Either you can tell, okay, I need, let's say, information about my default threads 1, so you have to give this name here. Okay, you have to give this name here. What is that? Here you have to give this name here. You can give the thread name here, but I don't want to give the thread name, any specific thread name. I want to get all of the thread, right? For this you have to provide none here. So basically you are telling I don't need any specific thread, I need all of the thread informations. Okay, now see, this will return you the threads. Okay, I'll give a equal sign. Now if I print that, okay, print that. print all of my threads. Now let's execute this file again. Okay, so this is giving you a generator object, and you know that if you're getting a generator object, so what you can do, you can run a for loop on top of that. So for checkpoint in checkpoint, or let's say thread, or let's say I'll just write thread in threads. Okay, once you have done that, or you can directly write like that. Let's say instead of writing two line, I can directly run a for loop for checkpoint in checkpointer. I think this is also checkpoint, right? Yeah, checkpoint in checkpoint dot list. Okay, then after that, what I'm going to do, I'm going to just print my checkpoint. Both name is same. Okay, so what I can do, I can maybe write like that, CKPT. Okay, that means checkpoint. Now if I re-execute, now see guys, here we are getting all of the thread right now. It is available inside my database, as you can see. And here we are getting lots of threads, because if I open my chatbot, we are getting 6 threads right now. And why six threads? Because every time if you execute the graph, it will generate three checkpoint. Why? I told you, because our actually workflow having 3 checkpoints. So in every conversation, every execution, 3 checkpoint would be available. Okay, 3 checkpoint would be available. So this was the first thread and this was the second thread. We executed 2 times, that means six times is available. Okay, so all of these 6 threads you are getting here. Okay, but here whenever I will extract that, so this would be a kinds of duplicates to us. I will only track the unique threads here. Okay, let's say here how many unique threads I'm having. Default thread 1 and default thread, only 2 uniques. Okay, otherwise everything is repetitive one. So I'll also try to handle this part as well. So once we are getting all of these these actually checkpoints, now from the checkpoint only, I only need this config. Now if I re-execute my terminal, now I'm getting the config only. Okay, now from the config, I need this thread ID only. First of all, I need to go to the configurable. So this is this is actually dictionary, right? Dictionary. So I will give the key configurable. Now again we are getting another dictionary, and here we have the thread ID. So I only need to extract the thread ID. Now see, I'm getting all of the thread, but I'm getting repetitive threads. Okay, same actually name again and again, but I only need the unique one. So for this, I think you know set, right? Set inside Python. So what set does? Sets basically will give you the unique actually name. So here I'll take a set. I'll just try to create empty sets, and I'm going to name it as all threads. Okay, and whenever I'm getting my threads, I'll just try to add inside my threads. Sorry, I'm going to add inside my set. So there is a add function we can use for this. Then I'll just try to print my all threads right now. Now if I execute, now see, I'm only getting thread 1 and my threads. Okay, that means the unique one. Now I have to provide as a list. Okay, I have to give as a list here, because here the session state we created, it takes a list, right? But here I'm getting a dictionary. As you can see here, I'm getting a dictionary. I'm returning as a dictionary. So what I can do, I can convert it to the list. So instead of printing this, I will just try to do the type conversion operation. I'll just try to convert to the list. Now if I execute, now see it is a list right now. Okay, now simply I'll just try to write inside a function. So I'm going to name this function as def get all threads. Okay, and all of the code I'm going to write inside that. Okay, instead of printing, I'll just do the return operation. So everything is fine. Now this function basically will return you all the threads, okay, from the database itself. So now here in the app.db, whenever you are importing this chatbot, right? So right now we have to import from the Agentic Chatbot DB backend, okay, instead of the simple Agentic Chatbot backend, because we are using DB backend right now. We have to import chatbot as well as the get all threads. Okay, this function we have to import. Now simply you just need to call this function here whenever you are initializing these chat threads. Instead of giving the simple list, empty list, you will give this function name. Okay, so what this function will do, it will get all of the threads and it will store inside my chat threads. Okay, so this particular code is sorry, this particular data is coming from my backend, from my database. Okay, that's how. So if you restart your application as well, it will not affect on my app, because every time this function is getting executed from my backend and it has the connection with my checkpointer, and checkpointer is connected with my database, right? Chatbot.db. So every time it will open the chatbot.db and it will get how many threads you are having. Only this part will return here. Okay, this part will return here. And after that, we are just passing it here. That means if I'm refreshing my page, if I'm closing the application, it doesn't matter. Every time I'm extracting my threads, I'm getting my threads, I'm fetching my threads from my database only. But previously I was doing inside my memory because I was using simple list, and simple list only creates the instance inside the RAM. Okay, and if you refresh, your RAM would be getting cleared. I hope you got the concept, guys. Okay, now let's try to execute and see whether it's working or not. So here I will open up my terminal, clear. Then I'll just try to run my app. So streamlit run app db.py. Now see, guys, you you can already see I already created some threads right here. Manually I created some threads, and this thread is also getting load here. You can see I did some conversation like Alex, then my name is Bappy, and this is the current thread right now. So what I can do, maybe I can delete my database and do start a new conversation. I'll just try to delete it. Okay, it will not getting deleted because it is running in the app right now. I can try delete some temporary file also came. I'll just try to delete. Okay, now I'll freshly execute my app. Now let's do the conversation. Hi, my name is Bappy. I am a teacher. Okay, great. Now I'll create a new chat. I'll tell, hi, my name is Alex. I am a learner. Okay, done. Now if I click my previous conversation, now you can see this is my previous conversation and this is my current conversation. Now the best part is that if I refresh my app, right, see, still this conversation remains same. Okay, now if you also close your app, let's say I'll close my app from my terminal, see it's closed. Okay, and I closed my application. Okay, I closed my application. Now if I restart my application, see, if I restart my application, now still it will be able to load my previous conversation, and anytime I can continue the conversation. Let's say here I'll just try to continue the conversation. Who am I? See, it is giving you are Alex, a learner who is seeking knowledge and growth, blah blah blah. Okay, now I can also do the conversation here only. Who am I? See, you are Bappy, you are a teacher, you enjoy helping students learn and grow in their knowledge and skills. Okay. So yes, guys, that's how actually we can add the permanent persistence memory right now inside our agentic chatbot. And now this is like more powerful. Actually, it will not erase your conversation. It will not erase your checkpoint if you restart your application like ChatGPT. Like if I open my ChatGPT right anytime, and anytime I can see my previous trades as well. Okay. If I close the app also, if I turn off my computer also, if I disconnect my internet connection also, still these are the things would be common. These are the things would be available because they are using a permanent persistence memory. Okay, they're using some kinds of database, whether they're using Postgres, whether they're using MongoDB, doesn't matter, but they're using some kinds of database. Because of that, this thing is permanent like our application. Okay, I hope you're getting it, guys. Okay, so yes, guys, that's how we can slowly make this particular chatbot more advanced. And in my next video, I'm going to show you some more advanced features, guys. We will be adding inside this agentic chatbot, and we'll try to make it more powerful. Okay. And for this, guys, please try to complete all of this video if you want to implement these kinds of project, because going forward, I have lots of plan. I will be bringing lots of project here. Okay. So for this, definitely you have to understand all of this concept. Okay. So yes, guys, this is all about from this video. I hope you liked it and you have understood the entire implementation. If you found my content useful, please try to subscribe to my channel, hit the like, and please share it with your friends and family. And all of the code I will share in my description. From there you can download. So guys, in this video, we'll be learning one very important and interesting concept called observability. So I think you have already heard of these kinds of word like observability, monitoring, tracing, okay, of agentic application or any kinds of GenAI powered application. See, we use this observability, monitoring, tracing not only in agentic application, but also we use this kinds of concept in any kinds of LLM powered application. So whenever you are implementing any kinds of LLM powered application with the help of LangChain or LangGraph or any kinds of framework, this observability, monitoring, tracing is super important there. Okay. Without that, you can't actually debug, monitor, and evaluate your application. This is not possible. So for this observability, guys, we can use one very interesting and powerful tool called LangSmith. Okay. So what is this LangSmith? LangSmith is a observability monitoring tool. It is created by LangChain. And with the help of that, actually, we can monitor any kinds of LLM powered application, whether it's agentic AI, whether it's any kinds of RAG system. Okay. Any kinds of application we can monitor here. Real time we can monitor here. Okay. So first of all, let me give you the idea what is this LangSmith is and why it is required. Then we'll try to see the practical demo, how we can observe, how we can monitor our entire agentic chatbot with the help of this LangSmith. Okay, each and every integration I'm going to show you guys. And trust me, guys, if you learn this concept, I think it would be very helpful for you whenever you are creating production grade agentic AI application, because in productions, whenever you are creating these kinds of system, there would be lots of bugs, there would be lots of issues, and you can trace everything in a single platform with the help of this LangSmith. This is super important, guys. So as you can see, guys, LangSmith is a debugging, monitoring, and evaluation platform for application built with LLM and AI agents. It is made by LangChain team, but it can also work with applications that do not use LangChain. Okay, so I already told you this LangSmith is, let's say it is developed by LangChain. But if you are not using any LangChain, let's say framework inside your application development, still you can use this LangSmith with other framework integration as well. Okay, it has all kinds of integration. So let's try to understand why this is useful. So whenever you are creating any kinds of chatbot or any kinds of, let's say, agentic powered application or any kinds of LLM powered application, there you perform some kinds of steps, some kinds of operation, right? Let's say user can send the questions, then in between you can construct the prompt, then you can perform the LLM call. If you're implementing any kinds of agents that will use any kinds of tool or database, okay, then it can also use memory and checkpointer for the retriever. Then it can give you the final responses. So that means in between there are some hidden operations are happening, but this is not visible to you. Okay, if you're writing only the code, if you're not monitoring the entire, if you're not, let's say, tracing the entire application, this part is invisible to you. Okay, so that's why you can see LangSmith is a debugging, monitoring, and evaluation platform for application built with large language model or AI agents. Okay, because inside all of this application, this hidden operation happens. Okay, this hidden operation happens. So if you're using LangSmith, so what will happen? LangSmith records this complete execution as a trace. That means whatever execution you are doing here, okay, LangSmith records this complete execution as a trace. Okay, it will record all of the execution as a trace, allowing you to inspect every step, including inputs, outputs, error, execution time, token uses, tool calls, and model behavior. Okay, this is super important, guys. I think by the definition itself, you can understand whatever hidden operation you are executing, okay, whatever things are happening in between, everything LangSmith can record as a trace, okay, in that platform itself. Okay, so that anytime you can see the input, output, errors, execution time, token uses, tool call, model behavior, each and everything should be visible to you in a single platform. Okay, now as you can see, for your LangGraph Agentic Chatbot, LangSmith can help you. That means the application we are developing right now. So here this LangSmith can help us for finding why an agent selected the wrong tool. Let's say you are running your agents and it has selected a wrong tool. It is giving you some kinds of other responses, but you don't know why. Okay, why it is giving you this kinds of output, why it is selecting the wrong tool. If you want to see the step-by-step execution, like after user query, prompt construction, LLM call, which tool it has selected, okay, based on the prompt or LLM call. Okay, if you want to understand these things, you have to first of all monitor, trace your entire application. Okay, monitoring is important. Any kinds of application, whether creating MLDL, CB, whatever project you are creating, monitoring is super important. If you cannot monitor your application, that means in production you will be finding difficulties for sure. Okay, that's why application monitoring is super important, and for this LangSmith is a very powerful tools we'll be using. Okay, so that's why find why an agent selected the wrong tool, we can easily understand with the help of LangSmith. Then inspect the exact prompt sent to the model. That means you can see like whether this prompt construction is happening in a good way or not, the prompt you are constructing, whether it is right or not, it is going to the LLM or not. Okay, each and everything you can inspect here. Then debug failed nodes in a LangGraph workflow. That means if any of the nodes let's say failed during the execution, you can easily monitor inside the LangSmith dashboard. Then measures responses latency and token cost. So that means if some of the model is taking much time, you can see like how much time it is taking, why it is taking the time, and how much token actually it is spending, okay, to give you the response. Each and everything you can monitor. Then review conversations and multi-tron threads. That means you can review the construction conversation, review conversation and multi-tron threads. That means you can see the entire conversation. Even you can see the threads conversation. Thread conversation means, I think you know, we have integrated the threads inside our agentic chatbot. Now user can create different threads, user can create different chats, right? So you can see the threads as well, not only the single conversation, you can also see the threads wise. Okay, this is also possible. I will also show you this part. Then compare different prompts or model versions. You can also compare different prompts or model versions. Then you can evaluate chatbot quality before and after the deployment. Okay, that means all of these things you will be getting inside this LangSmith, and it will help you for these kinds of work. Okay, if you are using this inside your application development. So I think apart from this, there is nothing you can monitor inside your application. If you can monitor, these are the thing, I think your application should be production ready and you won't be having any kinds of problem, okay, going forward. So now we'll try to see, guys, this LangSmith in practical. That means the application we have created, this code is already available in my description. From there you can get the code, guys. I think you remember we created a agentic chatbot, okay, and in my last video I showed you how we can integrate database features, okay, so that it can have the permanent persistence memory. Okay, so first of all, let me show you the application, guys, we have developed. So guys, this is our agentic chatbot we have developed so far, and we can perform any kinds of chat operation. Let's say if I give a prompt, give me a roadmap to learn, okay, ML. So see, this is giving you the detailed roadmap, and you can see the previous trades as well. You can also continue the conversation with the previous trades you had here, and this is your current trades. Okay, and if you refresh your application, still this previous conversation will remain same because we have added the permanent memory here with the help of database. Okay, so in this particular video I already explained this concept. If you haven't checked that, guys, please try to go through this recording. So see, guys, here we have performed a conversation. It's completely fine, but this application doesn't have any kinds of observability or monitoring connection. Okay, so I can't monitor this application like in the backend what is happening. Let's say if I deploy this application in production server, so I don't have any kinds of platform there I can continuously monitor my application, what is happening, how much token it is taking. Okay, or let's say any of the nodes is giving you any kinds of error, so I can't see these kinds of, let's say, issues, right? So for this, we can utilize this LangSmith platform. So you have to visit smith.langchain.com. So if you visit this website, guys, this is the LangSmith platform. So first of all, here, what you have to do, you have to create an account. Okay. So here you just need to create an account, guys. You can use your Google, GitHub, Discord, anything you can use, and you can create an account. So I already have an account, guys. I will just try to log in. So once you log in, guys, you will be able to see this kinds of dashboard. So this is your LangSmith dashboard, and previously I already created some of the project here. I already traced some of my project. That's why it's coming here. But if you are using for the first time, you won't be able to see this kinds of like project name here or tracing name here. Okay. So first of all, guys, if you want to use this LangSmith inside your application, you just need to collect a API key. Okay, and this is super easy to use. You don't need to write any kinds of code if you want to use this LangSmith, guys. Only you just need to add some of the environment variables, and automatically this LangSmith will start tracing your application. Okay, I'll show you this part. So if you want to get the API key, so what you have to do, you just need to go to the API section. So I think API is available in the settings, and here is the API key, guys. Okay, now previously I already created some API key. What I will do, I'll just try to remove some of the API key so that I can create a new one. So I'll create a new API key. So you can give the name. So let's say I'll give the name of Agentic Chatbot. So everything, just keep it as it is. Okay, don't need to change anything. Now just create the API key. So once you have created the API key, just try to copy, and you have to add this API key in the environment variable. Okay, so let's say this is our app. So this application we have created, guys, this is the code. I think you remember in my previous video, previous part. So now you just need to open this .env file. After that, here you have to add some of the environment variable. Let me show you. So these things you have to add here. Yeah. So see, these things will common for all the project you will be creating going forward. Only you just need to change the project name. So see, first of all, you have to provide LangSmith tracing. This parameter is equal to true. Okay, that means you are allowing your LangSmith to trace your entire application. Whenever you are executing your application, LangSmith will automatically start tracing your application. It will automatically start monitoring your application. That's why this parameter you have to give as true. Then you are telling what should be the endpoint. That means after tracing it, or the data it will get, okay, the, let's say, information it will get, while it will save those information. Okay, it needs an endpoint. So endpoint is a LangSmith platform. I'm giving, you have to save everything in the LangSmith platform. That means inside this particular platform, this is the dashboard, right? So this is what actually we're doing. Then you have to pass the API key. Now to authenticate with your dashboard, you need an API key. So what I will do, I'll just copy this API key, and here you have to provide the API key, and make sure you don't share this API key with anyone. Otherwise they will be able to use your platform. Okay, then you have to provide the LangSmith project name. Okay, because every time whenever you will execute for the first time, it will create a project, right? Inside the project it will start tracing all of the execution. So project is important. So here I'm giving Agentic Chatbot project. Okay, if you're creating any other project, you can change the name as per your requirement. Once it is done, you just need to save this file, and no need to change anywhere. Okay, no need to change anywhere. I can re-execute my app again. So I'll stop the execution, clear, and let's re-execute my app. Streamlit run my app.py. Okay. So once you have done, now what I will do, here I already saved this API key. So it's done. Now I'll go to the home page. Yeah. Now let's execute my app. See, my application is running right now. Now here again, I will give the prompt. Let's say I will give, hi, my name is Bappy. I need a plan to learn AI. I'll send it. Now see, it is giving you some kinds of response. Okay. Now, once I go to my platform, okay, once I go to my platform, and if I refresh here, so see, this agentic chatbot project is created few seconds ago. See, automatically it has created. I didn't change anything inside my code. Okay. Now, if I go inside that, now inside the project, guys, you will be able to see your trace. Okay. So this is our first trace. That means we have executed only one time. We have given a single prompt. That's why one trace came. And by default, this trace name will be taken as LangGraph because we are using LangGraph. And now if I click on the this trace, our first trace, so whatever message you have given as an input, you will be able to see, and whatever output you got from your AI, even you will be also able to see. Okay. And this is also coming as a chatbot interface. Okay. This is like very interesting. Then there is an option called details. So you have to click on details. Okay. If you click on details, you will be able to see all of the details. That means you have executed your LangGraph, and it has a chat node. I think you remember we are using a chat node. If you can see our entire application workflow. So this is the chat node. Inside chat node, we are using LLM, right? We are using a large language model, OpenAI model, and we are using GPT 3.5 turbo model because I used a default model there. Okay. And by default, GPT 3.5 turbo would be available. Now, everything you can see which model, which node you are executing. Okay. Each and everything is visible. Now you can see the input and output you got here. You can even see the attribute. Okay. All of the attribute, metadata, version, everything is visible here. And if you hover on each and every, let's say, step here, you will be able to see the, let's say, estimated token cost. You can see token cost and how much token actually it used. Okay. How much token it used for input, output, total. Okay. Each and everything you will be able to see that. Okay. That's how you can see the each and every execution of your application. If you're using multiple LLM calls, you'll be able to see the multiple LLM. You can see the prompt. Okay. Each and everything should be available here. Okay. Now let's say if I do for the second time, what I will do, let's say I will give another message. Let's say how much time it will take. Now I got a response. Now if I again go to my dashboard, now see another trace has created. Okay. Because this is my second run. Now if I go to this trace, and you will be able to again see the conversation. Okay. So how much time it will take, based on that you got the entire output. Then you'll be able to also see the token. Okay. Like input token, output token. Okay. Total token, each and everything would be available here. Now even you can also switch to your previous trans as well. So if I go to my previous trans, this is the first trans, this is the second trans. Okay. Everything you can see, even you can see the name. So this is tran 1 and this is tran 2. Okay. So that's how everything would be available. And even if you zoom out here, so you'll be able to see some other information right side, like start time, latency, like how much time it took to execute, then whether you are using any data set or not, then tokens, cost. Okay. First tokens, then metadata, LangSmith endpoint. Okay. Each and everything you will be able to see. So yes, that's how you can utilize this LangSmith platform. Only you just need to add those 3 to 4 things in the environment variable, and tracing would be automatically happening, okay, inside this particular dashboard. But one issue I think you have observed here, which is that, let's say here, let's say if I create a new threads, okay, let's say I create a new threads, and if I do the conversation, let's say I will give, hi, I am Bappy. Let's say this is completely new threads. Okay. But if I go to my dashboard, that means LangSmith dashboard. So as you can see, in the same, trace only, it has created my my current execution. That means the current trace, the execution we have done right now. So see, here I given my name is Bappy and hello, I can assist you today. Okay, so that's how actually it is. As it is not separating my threads, instead of that it is saving everything inside a single trace only. So here if you want to separate your threads guys, it is also possible because LangSmith by default has this threading features here. So if you want to separate out each and every threads, okay, the threads you are maintaining here, so it is possible. For this, inside the code you have to only modify one particular line. Let me show you. So this code only you just need to modify. See here, I was writing the configuration. In the configuration I was only giving the thread ID, okay, and we are passing this configuration whenever we are executing the chatbot, whenever we're invoking the chatbot. Okay, now instead of that you have to write this configuration. Okay, some other information you need to also pass this metadata and the run name. Okay, so run name, see, every time this run name is coming as a LangGraph by default name, but you can change this run name if you want. You can give any kinds of run name. Let's say I'll give chat trace. Okay, you can also give any other name. And if you pass this configuration guys, right now this trading would be applied. That means all of the threads, individual threads would be saved in the threads. Okay, let me show you. So I'll remove this configuration right now. This is not required. I'll use my new one. Okay, new configuration. Yeah, so let me show you the fresh execution. So for this I'll remove my let's say project. So here just go to the tracing and select your project and just try to delete the project. Okay, done. Now I will re-execute my code. So let's say here I'll give a message. Hi, my name is Bappy. Okay, done. So this is the thread guys. I just start the conversation. Now if I come here, see my project has created. If I go inside that, so first trace as created, that the name of the trace is chat trace because we changed the name, and this is the conversation we have done. Okay, now let's say I will give another message. I'll create a new threads here and I'll perform another message. Let's say I am Alex. Now if I come here, now if I go to the threads, now guys you can see threads has created. Okay, now this is the threads. This was my first trace. There I perform hello, my name is Bappy. Okay, how I can assist you today. Now let's say if I give another message, I need a plan to learn Python. Now if I go to my threads, so see inside the same trace, inside the same thread, there is two trans right now. Now if I go to this threads, as you can see, the first I given hi, my name is Bappy, and it has given me hello Bappy, how I can assist you today. Now in the second trace, you can see I given I need a plan to learn Python, and it has given you the plan. Okay, that means in a single thread now it is storing multiple trans, that means multiple conversation. Previously I also did for Alex. See, Alex is also available here. Yeah, you can see the Alex, but it takes some time guys. I think it takes 10 to 20 seconds to update in the threads. Okay, that's why initially whenever I showed you this information was not updated. Now see here also, whenever I did, let's say Alex, right? This is the Alex conversation. This is the Alex conversation. I'm Alex. I need a plan to learn Python. As you can see, I'm Alex, and here I given you I need a plan to learn Python. Okay, so that's how guys, every trades you will be creating, all of the trades would be available inside the trades, or whatever conversation you will be doing, it would be saving as a run. Now let me show you another, let's say execution. Let's say in the Alex only, I'll tell how much time it will take. Now this is my third run. Okay, now if I come here, so you have to wait for some time, then this run would be updated here. Now see, it got updated, turn 3. Now if I click here, now this is the turn 3 guys. And here I asked how much time it will take, and this is the answer I got. Okay, so that's how guys you can separate out the threads by adding this line of code only. You just need to update your configuration and everything will remain same. Okay, so that's how guys, with the help of LangSmith, we can continuously monitor our application, we can continuously trace our application. Lots of things we can perform with the help of this LangSmith. Going forward also I'll be using this tool, okay, in my project development, and I will also show you some other advantage we can utilize from this LangSmith itself. Okay, so all the code I'm going to upload in my GitHub and give the link in the description. From there you can get, and please try to practice in your system, and do let me know if you have any question. So yes guys, this is all about it, and if you found my content useful, please try to subscribe to my channel and hit the like. In this video I'm going to explain one very important concept, one very important features inside our agentic chatbot, which is tools. If you are implementing any kinds of agentic system, this tools is very much important. Without tools, an AI agent cannot perform any kinds of action. With the help of this tools integration, we can make our AI agents more smarter and intelligent and powerful. So far, the application we have created, it doesn't have any kinds of tool. It can only use the large language model and give you some kinds of response. So if I show you my application guys, so this is the application guys so far we have developed. This is our agentic chatbot with LangGraph we have developed so far. And we have added lots of feature in this particular application. We saw how we can create the basic workflow of our agentic chatbot. We saw how we can add the streaming features. We saw how to add the trading features. Okay. We saw how to add the persistence memory, even how to integrate the database with that. Even in my last video, I showed you how we can add the observability tool to monitor the entire application. And we created a dashboard. This is the LangSmith dashboard guys, and here continuously we're tracing our like conversation. So this is the application guys, and the problem with this application is, let's say if you are asking any kinds of question which is latest, which is not available in the large language model, that time this particular chatbot will not able to give you the response. So let's say here we are telling, hello, tell me about Python. So if I give this prompt, it will be able to give you the response. So see guys, it is able to give you the response. And why it is able to give you the response about the Python? Because this Python information is already available in the LLM knowledge base. Okay. So the model we are using, every model has a knowledge cutoff date, and the model we are using, this model got trained till 2022. I think till December, this model got trained, and that time actually Python information was available in the internet. That's why it is able to generate the response. But let's say if you are asking anything which is latest information, this information is not available in the knowledge base, that time your chatbot will fail. Now let's ask about a latest information into my chatbot. So here I will tell, give me all the latest news for today's. Now see, it is telling, I understand you are looking for the very latest news. However, as an AI, I don't have real-time access to the live news feed, and my knowledge cutoff is a specific point in time, typically a few months ago. Okay, this means I cannot provide with you today's minute by minutes news headlines. Okay, to get most current news, I highly recommend checking reputable news sources directly. Okay, and blah blah blah. That means this chatbot is directly telling you, okay, I don't have the access to the latest data. Okay, because this is using a large language model, and this large language model has a knowledge cutoff date. Okay, I think till 2022 or 2024, I don't know, but till the date actually they have trained this model. And actually in that period of time, whatever news were available in the internet, this has the information. Okay, but if you are asking anything which is latest, this model will not able to give you the response. Okay, so this is the problem right now. Even if you want to perform like other things as well, let's say if you want to let's say see the stock market analysis report. Okay, the latest stock market analysis report, this model won't be able to give you the response. So let me give you another demo. So tell me the latest stock of Apple. So as you can see, as an AI, I do not have access to real-time live stock market data. Stock prices fluctuate consistently throughout the trading day. Okay, and my knowledge cutoff means any specific price I could give you would be outdated almost immediately. Okay, that means it is not able to give you the real-time information about this stock. And if you're asking anything, let's say we're asking about the current weather. Okay, let's say I'm asking about tell me the current weather in, let's say, New York. So see, it is telling you again, I don't have real-time access to the live data, weather data. Okay, so this is the problem with our agentic chatbot we have created so far, because it doesn't have any kinds of tool. Okay, so tool means it is kinds of function, it is kinds of API. Okay, it is kinds of let's say uh, different tools that my agent can use to get the latest information or perform any kinds of action. Okay, so let's say if I go to the chat gpt and if I ask the same question, chat gpt will be able to give me the response. Okay, so let's say I will copy the same question. I'll copy this question, and if I ask in the chat gpt, see, chat gpt will be using some kinds of tool in action. See, just try to notice here. Now see, it is searching over the internet. Okay, see, it is searching over the internet and it is finding different latest news. And once it has collected all the latest news, then it will refine that particular news and it will give me all of the, see, news for today's. Okay, and the reference URL as well, like where it got it referred that particular headline, where it referred that news. Okay, each and everything it is giving me. Now let's see if I am asking this question as well, tell me the latest stock of Apple. Again, it will be using some kinds of tool. See, it is using some kinds of tool, and after that it will give you the response. See, it is using this stock market analysis tool and it is giving you the real-time Apple stock data. Okay, then you can also ask about the weather information. Again, it will be able to give you the response because it has the current weather tools as well in the backend. With the help of that particular tool, it is real-time searching the current weather information in New York and it will give you the weather. See, okay, so this is called actually tool in action. Okay, so whenever you are creating the agentic system, it should have lots of tool. Okay, and wherever it needs any kinds of tool, it will automatically decide and it will select that particular tool. Let's say here I was asking about the news, right? That time to get the latest news, what I have to do, I have to perform the internet search operation, I have to perform the Google search operation. So here it is using some kinds of search tool. Okay, with the help of the search tool, it is giving you all kinds of latest information, latest news. Then I asked about the latest stock of Apple. Okay, now it is using the stock market actually tool. With the help of this tool, actually it is getting the real-time actually real-time actually stock of Apple, and it is giving you the response. So it is using some kinds of stock price or stock related tools in the backend. Now again, I asked about the weather. So here it is using a weather tool. Okay, with the help of weather tool, it is hitting some kinds of API of the weather, and it is getting real-time this weather information. Okay, the given location we are giving. Okay, so that's how things are working. So that's how ChatGPT has lots of tool connection. Okay, not only 3 to 4 tools, it has lots of tool connection. So you can ask any kinds of question, whether it's a latest news, whether it's any kinds of outdated news, whether you want to perform any kinds of task. Okay, everything it can perform because it has the tool, and without this tool it can perform the action. Okay, I hope you get it. So these kinds of things we will be also integrating inside our agentic chatbot. So whenever we are asking these kinds of question, my agentic chatbot will be also able to give you the response. It will be also able to use these kinds of tool and perform the action. Okay, so yeah, in this particular video we'll be learning this concept, guys. We'll try to see how we can integrate the tools inside our agentic chatbot, and trust me, this is a very important concept. If you are implementing any kinds of agentic powered application, you have to use the tool. Okay, there are lots of tools are available over the internet, over the market. As per your requirement, you can select the tools and you can integrate inside your chatbot or whatever application you are developing, and you can even create your custom tools. It is also possible. I'll show you both of them. Okay, so guys, before I discuss about the tools concept, the tools integration inside our agentic chatbot, first of all I want to show you the demo, like after adding these tools, how my agentic chatbot will work. So I already integrated the tools inside my agentic chatbot. This is the updated version. First of all, let me show you the demo. So see, this is the updated application. Now if I ask these kinds of question, let's say I will give me the latest news in AI. Okay, now if I send this prompt, you will be able to see it will use some kinds of tool. Okay, so see, it is using Tably search tool. So with the help of Tably search tool, it is searching over the internet about the latest news in AI, and this will give you the response. See, this is giving you the response. See, so all of the latest news it has given me. Okay, from different paper, different publication, it has given me all the latest news in AI. Even you can see the like tools action. As you can see, internally it is using some kinds of URL, some kinds of, let's say, resources, and it is giving you this kinds of information. Even in ChatGPT also you'll be able to see this this backend execution. Okay, this is also possible. So every, like, say, tools execution you will be able to see. If you want, you can also open it and you can see. Okay, so this kinds of thing we have also implemented inside our agentic chatbot, and throughout this entire video, guys, I'm going to show you how we can develop these things. Okay, how we can add this particular tools integration inside our agentic chatbot. Now let me ask another question. Let's say here I will tell calculate. Okay, this number. Okay, so let's say this is my expression. I want to do a mathematical calculation, and inside this agentic chatbot, I am using a tool called calculator tool. So with the help of this calculator tool, you can calculate any kinds of complex, let's say, expression, any kinds of complex, let's say, equation you can calculate here. Now if I send this, now you will see that it will be using calculator tool. Okay, now with the help of this calculator, it is calculating the entire let's say number, and it is giving you the response. So any kinds of complex math problem you can give, it will be able to perform that. Okay, so once it is done, let me show you another demo. Then I have given another prompt, tell me the latest stock price of Apple. Again, you can see it is using some kinds of tool. It is using stock price tool, and it is able to give you the latest stock price of Apple. Okay, even you can also ask the stock related any other companies, let's say stock price of Google. So stock price of Google. Now see, it is using get stock price tool, and it is able to give you the latest stock price of Google is that much. Okay, so yes, guys, that's how our entire agentic system is working right now, and we have already integrated some tools, okay, inside our agentic chatbot. That's why it is performing like ChatGPT. But ChatGPT is having lots of tools, guys. If you want, you can also integrate lots of tools inside your application. This part I will leave it to you. First of all, let me show you the entire development, then you can improve this application a lot. So first of all, I'll be discussing about the tools, guys. What is tools? Why tools is required? Then I'm going to show you the implementation. So guys, first of all, let's try to understand about the tools. What is tools exactly, and why it is required, and how tools works. Okay, so as you can see, in agentic AI, tools are external functions, APIs, database, or any kinds of service that an AI agent can use to perform actions beyond generating the text. Okay, so previously the application we created, guys, this agentic application, the previous version application, that means in my previous video, it was only able to generate the text. Okay, if you give any kinds of, let's say, prompt, based on the prompt, if this information is available in the knowledge base of the model, it is able to generate some kinds of text. Okay, but with the help of these tools, an agent can perform action. Okay, like I showed you right now, right? I did different prompting in my agent. I asked about the stock price. I asked about the latest news. Then I asked to calculate some kinds of mathematical equation, and it was performing some kinds of action with the help of some third-party tools. Okay, so that's why our agent can perform any kinds of actions, okay, using the tool beyond the text generation. So our agent cannot only generate the text, okay, it can also perform some kinds of action with the help of this tool. So this is very much important. So a normal LLM can only respond based on this knowledge and the information in the prompt, okay. An AI agent works with tool, and it can search, calculate, retrieve the data, execute code, update database, or interact with other systems as well. Okay, so by this definition itself, I think you can understand what is tools exactly and why this tools is super important. Okay, so with the help of tools, you can perform any kinds of searching operation, calculate operation, retrieve data operation. You can even execute any kinds of code. Okay, I think in ChatGPT you can execute the code, you can debug your code. Okay, how it is happening? Because it is using some kinds of tool, and that tool actually it is working with the Python interpreter. Okay, so in the Python interpreter or any other, let's say, program you are using, it is using that particular interpreter, it is executing the code, it is reviewing your code, it is finding the bugs inside your code, and it is giving you the final response. Okay, this is the problem inside your code. So everything is happening with the help of this particular tools. Okay, so they are using these kinds of tool, external tools, and they are performing this kinds of operation. Okay, I hope you get it. Now let's try to understand a simple example. Suppose a user asked, what is the current weather in Texas? Okay, the agent does not know the live weather by itself. Now it can call a weather tool. Okay, let's say you have already integrated the weather tools inside your agents. Now your agents will automatically decide which tool to call. Now you are asking about the weather, so definitely it will let's say hit this get weather tools. Okay, it will use this get weather tool, and you are asking for Texas. Okay, so that's how the location you are giving, it will find the weather, okay, of that particular location. Then the tool returns the current weather, and the agent uses that result to answer the user. Okay, so that's how the entire system works. Now some common tools in Agentic AI. So you can see web search tools can be used a lot whenever you are creating these kinds of agentic application. With the help of, you can perform search operation over the internet, and you can get the current information. Then calculator tool. Okay, I think you saw the calculator tool. You can perform any kinds of complex mathematical operation. Okay, then database tool. You can even reads and writes data inside your database or any other, let's say, storage service. These tools can be also used inside your agentic chatbot. Then RAG retriever tools, okay, searches over the documents or vector database. We'll in future we'll also try to add these tools inside our agentic chatbot. We'll also add the RAG functionality. Okay, I will show you this part as well. So this is also important things, like in ChatGPT you can upload any kinds of documents, right? And in the document you can perform the search operation, you can perform the query operation. How it is happening? Because it has the RAG retriever tool. Then you can use Python tool. With the help of Python tool, you can execute the code, analyze the data. Okay, everything is possible. You can even use email tool. With the help of email, you can read email, you can draft your email, you can send the email. Okay, so everything is possible. Even in ChatGPT or Google Gemini, you can connect your email. Okay, even from there only you can send the email. This is also possible. And how it is happening? Because it is using email tool. Then calendar tool you can use. You can even access your calendar. You can use different API tool, like you can use weather API tool, finance API tool, CRM API tool, any kinds of payment system API tool, any kinds of API you can connect with your agentic chatbot. Okay, agentic AI system. Then custom businesses tool. Let's say if you have some custom businesses, okay, if you want to integrate that particular tool, let's say you can create the tickets, you can check the inventory, you can generate the reports, okay, you can update the customer records. Everything is possible here. So these are the common tool, guys, you can integrate inside your agentic system. Okay, apart from that, there are lots of tools are available. You can search over the internet. Okay, there are thousands tools are available. Whatever you need, okay, you just try to integrate inside your project itself. Okay, very simple. Then how tool calling works, guys? As you can see, the typical workflow is the user gives a request first of all, then the agent understand the goal. Let's say previously I showed you some kinds of action, right? I asked about the stock price of Google. So this was my user request. Okay, my agent understand the goal. What is the goal? It has to understand the, it has to get the latest stock of the Apple, okay, or Google. Then the agent decided whether a tool is required. Then our agent was understanding, okay, to give this particular answer, whether I need to use any kinds of tool or not. So in this scenario, definitely it has to use the tool, because inside the LLM, the default LLM, it doesn't have this kinds of information, definitely it has to use the tool. Okay, so the agents will decide, okay, it has to use the tool, it needs the tool requirement. Okay, then it selects the appropriate tool, because inside my application there are multiple tools I have added. Now which tool to call, okay, which tool to use, because here I asked different question, right? And for each and every question, it should use different tools. Okay, it's not like that for all the questions it will be using one specific tool. Okay, because question might be different, prompt might be different. First of all, it has to understand the goal. Based on the goal, it will automatically select the specific tool it requires. Okay, that's why it selects the appropriate tools. Then it generates the tool arguments. Okay, tool argument means here we are asking about, let's say, give me the latest news in AI. So what will happen, it will search this particular word in the internet. Okay, because it is using tably search tool, right? And you know tably search tool, what it does the internet search operation, the way you search the Google, right? It will be using tably search and it will perform the search operation. Okay, and this will give you the latest information of that. So that's why it generates the tool argument. Okay, let's say whenever you are giving any kinds of let's say equation, let's say calculate this number with this number. Now it will be using calculated tool. Okay, see, and what is the tool argument here? This expression. Okay, this expression is the tool argument right now, and it is calculating that, and it is you are able to see the response. Okay, then tool execution in action, that means tool will execute and this will give you the response, and this response, the result is returned to the agent. That means whatever responses you will be getting from the tools, okay, sometimes these responses won't be readable to the user. Okay, so that's why what you have to do, you have to send this response to the large language model again, that means your agent again, and agent will try to refine that particular output, and you will be able to see the final result. Then the last one, the agent produces the final responses. Okay, that means once my tool execution is complete and whatever output you are getting from the tools will try to pass to the agents, and agents will try to refine that particular output. Okay, and this will generate the final responses to the user. So that's why the agents produces the final responses. Okay, example, you are asking, let's say, what is 25% of 8500. Now agent decide it has to use calculated tool. Okay, now it will perform the tool call. Now this is the calculation it has to do, right? This is the expression it has to calculate. So after calculating, this will your let's say tool has generated this output. Let's say this is the final response, but if I show this response to the user won't be able to understand in a good way. Okay, so I have to generate some kinds of readable response. So again, I will send this particular result to my agent. Now agent will try to refine this out, let's say answer, and it will generate a final responses. You can see now agent is generating 25% of 8500 is 2125. Okay, now this is more readable than this one. Okay, so that's why this step is super important, and whenever you are using any kinds of tool, whenever your agent is calling any kinds of tool, so this 8 step it is following. Okay, and we'll also follow this 8 step to implement tools integration inside our AI agents. Okay, this is the entire idea, guys. So now, guys, I think pretty much clear how the tools works and what is tools exactly, and in the ChatGPT also how ChatGPT works, and whenever you are asking any kinds of real-time question, how it is able to give you the response, because it has the tools connection. Okay, lots of tools connection. Because of that, you are able to see the latest information or any kinds of action you can perform here. Now let's start the implementation, guys. I will show you the entire implementation, how we can add the tools inside our agentic chatbot. So guys, first of all, let's try to understand the workflow. After adding this tool node inside our workflow, how our workflow will look like and how it will work. So as you can see, this is the first workflow we have created so far. So this workflow has only one particular node, which is chat node. So basically, if user is giving any kinds of input, it is going to the chat node, and chat node is giving some kinds of output. And right side, you can see this is the updated workflow we'll be creating inside this video. Basically, we'll be adding our tools node here. So as you can see, this is the updated workflow. So here, if user gives any kinds of input, it will go to the chat node, and here actually we'll be using something called tool condition function. Okay, there is a function called tool condition function. So here I have already written what is this tool condition function. Function does. It's a tool condition. It's a pre-built conditional age function that helps your graph to decide should the flow go to the tool node next or back to the LLM. Okay, that means whatever input user is giving. Okay, let's say if user is asking, tell me about Python. So I think you know that inside large language model, this information is already available. So in this scenario, your agent doesn't need to call the tool, right? It can only use this chat node and give the response, and the response will go to the end directly, right? But if user is asking, tell me the latest news in AI in 2026, okay, this information is not available inside the large language model knowledge base. That time your tool condition, okay, tool condition function will decide, okay, now it has to use some kinds of tool. That means this kinds of question will redirect to the tool nodes. Okay, so this is how this tool condition works. That's why you can see the definition. So this tool condition is a pre-built conditional age function. Okay, I think I already told you about conditional workflow. Okay, how conditional workflow works. If you haven't checked that, please try to check my previous video. So conditional ages function that helps your graph to decide should the flow go to the tool nodes, okay, or back to the LLM. Okay, now I think you got it. What will happen here? Okay, now here we have added this tool. So this tool, we call it as a tool nodes. Okay, inside this graph, this tool is a we call it as a tool nodes. So tool nodes is also a pre-built node inside LangGraph. Okay, so as you can see, in LangGraph, tool node is a pre-built node type that acts as a bridge between your graph and external tools. Okay, that means inside tool nodes you can use any kinds of function, APIs, utilities, etc. So as you can see, normally in LangGraph you would write a node function yourself. Okay, it takes a state and return the state. So far we have written like that. But a tool node is a ready-made node that knows how to handle a list of LangChain tools. That means these tool nodes you don't need to write separately. Okay, this is already pre-built inside LangGraph. You just need to define that, okay, as a node, and it will automatically, okay, it will automatically handle the list of the tools you will be adding inside these tool nodes. Okay, then its job listen for tools calls from the LLM. Like let's say user wants to search something on the internet about the latest information, or let's say he or she wants to get the weather information. So automatically this tools node will decide which tool to use because it has the list of the tools. Okay, automatically based on the input, user input, it will decide which tool to use and automatically route the request to the correct tools. Okay, that means if user is asking about latest information in AI, it will be using search tool. Let's say if user is using if user wants to know about the current weather, okay, so that time it will redirect to the get weather tool. That's how it will route the request to the correct tool, then pass the tool's output back to the graph. Okay, so that's how the system works. Okay, that means whenever you will pass any kinds of input, first of all, this tools condition will decide whether it has to use the any tool or not, or whether it has to use the default large language model to generate the response. Okay, but if it needs any kinds of, let's say, tool functionality, that time it will automatically route to these tool nodes. Okay, and tool nodes will try to decide which tool to use for what kinds of input. Okay, now I think you are pretty much clear with this particular workflow, and this workflow will try to develop inside our system. Okay, so for this, first of all, I'm going to show you a notebook experiment, guys. We'll try to write everything in a Jupyter notebook. We'll try to understand the entire tools concept there. Then we'll try to integrate inside our agentic chatbot we have created so far. So here what I have done, guys, as you can see, left hand side, I created a notebook folder, and inside that I already kept my previous notebook I showed you, right? So this is the previous notebook I created at the very first time, right? There I showed you the chatbot workflow. We created this workflow, and this was the simple workflow. So here I created another notebook called tools demo. Now if I open it up, so you can see this is the tools demo related code. So here basically I'm going to explain this code, like how we have to add these tools inside our workflow and how we can practically test that. Okay, so once everything is working fine, then we'll try to integrate inside our development. And here I already added that documentation, the documentation I showed you, tools documentation. If I click here, so this is the documentation, guys. I already showed you this documentation, right? So this documentation reference I already given in this particular notebook. You can refer it here. Now here, first of all, I'm going to select my environment. So let's select my environment. So this is the environment. Now, first of all, we'll import all the necessary library. So as you can see, we are importing state graph, start in from LangGraph, then type dict, annotated. So these are the things are common. I think you are pretty much familiar with this. Now base model, human message. And one thing guys I have done, actually my OpenAI API key is over. Okay. My limit is over. That's why I am using Gemini model. And if you want to use Gemini model, so that time you can import this library called Chat Google Generative AI from LangChain Google Gen AI. Okay, and for this you have to install one library. So this is the library guys, LangChain Google Generative AI. Okay, and this specific version I have installed in my environment. Okay, so again you just need to open your environment and just write pip install -r requirement.txt. Okay, if you do that, it will automatically install this library inside your environment. So I have already done that. So let me open it up. So see, this is the alternative way to use any kinds of large language model. If you don't have OpenAI API key, or if your API key limit is over, that time you can use these are the free to use large language model. Okay. But if you want to use OpenAI API key guys, you can refer my previous notebook. I think in previous notebook, I used the OpenAI API key. Here I use this OpenAI model. Okay, chat OpenAI model. Only this part you just need to change. Okay. And one more thing you have to collect, which is like Gemini API key. That means Google API key. And how you will get this Google API key? So for this you have to go to the Google AI Studio. Okay, this particular website. And here you can click on get started. Now left hand side you will see this API key option, get API key. I'll just click on get API key. Now from here you just need to create an API key. Okay, I already created the API key, so I can copy and I can simply paste it here. Okay, so make sure you collect your own API key guys. I'm going to remove my API key after this recording, so don't use my API key. Try to create your own API key from here. Okay, once you have created the API key, then you will be able to execute this notebook. Then I'm importing this add message from graph itself, then load env to load my environment variable. Then I'm importing some other additional library. As you can see from LangGraph pre-built, I'm importing this tool node. Okay, I think I already told you about tool nodes, right? So here in this demo, I told you about the tool nodes. So these tool nodes will basically help you to yeah, I think this is the tool node. Yeah, tool node. So this particular tool node. Okay, so this tool node will help you to define your nodes. Okay, that means tool nodes, and you don't need to write this tool node separately. This is already pre-built inside LangGraph. Okay, that's why we're importing from pre-built. Then there is another function called tool condition. So this function I told you. So this tool condition we also need to add as a conditional edges. So basically this function will decide whether it has to use the tool or it has to use the simple LLM call. Okay, so this is also a pre-built function inside LangGraph. We'll be importing them. Then I need this Tabuli search. So Tabuli search is an internet search tool. With the help of that, you can perform the internet search operation. Let's say if user is asking any kinds of latest informations, like ChatGPT I showed you. Okay, previously the demo I showed you. If user is asking about latest information, anything which is, let's say, completely latest and available over the internet. So with the help of Tabuli search, we can get these informations. Okay. And if you're using Tabuli search tool, guys, you have to install these two library, LangChain Tabuli and Tabuli Python. Okay, so these two library you have to install, and this is the specific version I'm installing in this project. Now, what you have to do, you just need to simply write pip install -r requirement.txt. Okay, if you do that, it will install all of the necessary library inside your environment. Okay, so this tool library is required if you're using Tabuli search tool. Then we'll be importing these tools. Okay, right now we have to create the tools. Okay, and whenever you want to create your custom function, okay, let's say custom function as a tool, that time this tools has to be imported. With the help of this tool, we'll be creating a decorator, and this decorator will be represent my function as a tool. Okay, I'll show you this part how to do that. Then request and math module. Okay, so these are the import you have to write inside your code. Done, right? Now first of all, let me load the environment variable. So I have loaded my environment variable. Okay, now here I'm initializing my model, guys. So as you can see here, I'm initializing Gemini 2.5 Flash model, and this is the creativity parameter I think you already know about, and this is your LLM object. And if you want to use OpenAI large language model here, this is very much simple. Only you just need to write chat OpenAI, okay? And if you want to use a Gemini model, you have to use this particular code, okay? And if you want to use any other provider as well, simply just try to change here. You can go to the chat GPT and you can ask, okay, I want to use Grok model. Let's say Grok Meta model, or I want to use open router provider and I want to this model, okay? So this particular code will change, and you will get this code from the chat GPT or any kinds of documentation. You can change it anytime here, okay? So this will my large language model. This will be my large language model, okay? Now we'll be initializing the Tably search, okay? So Tably search is a internet search tool I already told you about, right? And to use this Tably search tool, you need an API key. Okay, so for this, what you have to do, you have to go to this Tably website. Tably, you just need to write Tably API key. Go to the first website and just try to continue with your Google. Okay, so here you will be getting your API key. If you don't have API key, please try to create from here. So you just need to create here, give the name. Let's say I'll give demo and simply create the API key. Okay, once you have created, just try to copy this API key and you have to place inside your environment variable. So here you just need to create another key called Tably API key, and here you just need to paste your API key. That's it. Okay, I already have my API key. I'm not going to change it here. Okay, so API key is also collected. Now see, this is our first tools actually we have defined. So Tably it's a like a tool inside like Agentic AI. If you are creating any kind of Agentic AI project, so Tably is a tool. By default, it's a tool. So you don't need to give this particular decorator sign. So you just need to create an object of Tably search. So inside Tably search, you will just need to give maximum result, like how many result you need whenever it will search, do the search operation. Let's say it has searched for latest AI news, okay, in 2026. It will search maximum in 5 website, okay, 5 website, and it will give you the response. Okay, I think previously I showed you this part. I think I created LangChain agent, right? There I showed you how to use the Tably search, right? Then topic, basically I want to search the general topic related search operation, and search depth advanced, okay? So these kinds of parameter you have to pass inside Tably search, and this will give you a search tool object, okay? And then you have to create this object. So this will become your first tool. Then the next tool, guys, I have created here called calculator tool. So you can see I have written a custom function. So just try to ignore this part. Let's say as of now, I haven't added this decorator. So let's say I'll remove this decorator. First of all, you have to write a custom function. So see, this is the custom function I have written. So here I'm using math module. And here if you are passing any kinds of expression, right? Any kinds of mathematical expression. So this function will be able to calculate that expression, and it will give you the result. And if any exception is occurring, it will raise the exception. Now let's see, if you want to create any kinds of custom function as a tool, only you just need to give this particular decorator, this decorator @tool, and this tool we have already imported here, as you can see, from LangChain course tools. Okay, now this will become a tools. Okay, now this will become a tool object. Now you can use this tool inside your agents. So this is super simple, guys. Okay, and this is very much interesting. You can create any kinds of like Python custom function, and you can convert it as a tool, and you can use it inside your AI agents. It's not like that always you have to use the predefined tools. Okay, it's not like that, because I can write any kinds of custom function, okay, for my work, and that has to be my tools. Okay, that has to work with work like it my tools. So I can do that. This kinds of customization is also available inside LangGraph. Now as you can see, this is my second tool, calculator tool. Now the third tool I created, get stock price. So let's say if user is asking about any kinds of stock price about Apple, Tesla, or Google, whatever. So this tool will be working that time, and it will give me real-time stock data. Okay, so as you can see, again I written a custom function. So this will basically take any kinds of company name, example Apple, Tesla, or whatever. And here I'm using a website. As you can see, this is the website, alphavantage.co. okay, this is the website. So in this website, basically this is the API endpoint of this website, and to hit this API endpoint, you need an API key. Okay, so let me show you this website first of all. So this is the website, guys. So this website has all of the stock related real-time data. Okay, stock market data. stock market data API for LLM and LLM and any other, let's say, uh, application you are implementing. Okay, so here basically you just need to collect an API key. So to collect the API key, so there is an option get free API key. I'll click here. Now you just need to give your organization name. Let's say I'll give DSwithBappy, and you just need to also pass your email. Let's say I'll pass my email, and once it is done, just try to click on get free API key. Okay, so this is your API key. Just try to copy that, and don't share this API key, guys, and try to use your API key, own API key. Okay, and here you just need to paste this API key. Okay, now this will become your um, API endpoint. See, now here you just need to pass a symbol only. Let's say I'll give Apple. Okay, I'll pass like that. See, now this is giving you the stock data related Apple. Okay, real time you are getting a JSON response. So that's how we are using this website, guys. That's how we are using this API. And to hit this API endpoint, I'm using request module inside Python. We are passing this URL and it is giving you the JSON response, and we are returning that. Okay, to the LLM. So this is our next tool I have used here. So in this demo, guys, I only use 3 tools. You can add like more tools here if you want. You can add like get current weather informations. You can add let's say emailing tool. You can add, let's say, Google Drive tool. Any kinds of tool you can add. Only you just need to go to the chat GPT and ask like, okay, I need to use this tool, how to write that particular function. This is a simple Python function you need to write. Okay, so just to show you guys, I used only 3 tools in this particular project, but you can feel free to add more tools here. Okay, anytime. Let's say let me show you another example. Let's say if I go to the chat GPT and if I, let's say, ask, I want to add a tool in my agent that will fetch weather or given location real time. Give me a Python function. So see, this is the get current weather tool. Okay. Now simply you just need to copy this code, and here it is telling what to install here. Okay. And it is telling this API key you also need because it is using open weather API, I think. So let me copy this function as it is. Just I'm showing you, okay, how to add different tools. Okay, you can take the help from ChatGPT anytime, and you can create this kinds of custom function. So let's say here I'm going to add another tool. This is my tool. Okay, get current weather tool. It will take a location, and based on the location, actually it will give you the real-time information. So here I need to import this operating system library. Import OS. Hmm. So, and it needs an API key. Okay, open weather API key. So how you will get this open weather API key? You can copy this key and search on Google. So this is the weather API. Get API key. So this is the website, guys. It is using get API key. Now you just need to first of all sign in, I think. First of all, I'll create an account. Okay, I think I don't have any account. I'll give the password. I'll confirm all of these things and let's create the account. The email is already taken. Okay, previously I think I already used this email. So let me sign in and see whether it's working or not. Okay, guys, let me log in. I think I am having some issue. First of all, let me log in with this website. So guys, as you can see, I have successfully signed up in this website. Basically, I forget my password. Okay, and now I changed my password and now I'm able to visit this website. Okay, first of all, you just need to create an account here. Then once you have done, here you will see one option called API key, and here is your API key. Okay, so you just need to create an API key. Let's create an API key. I'll give the name, let's say agent generate. This is your API key. Let's copy that. And here you have to write it inside your environment variable. And this should be the key name. Okay. Open weather API. So that's how you can collect the API and now it will work. So I will re-execute from the beginning. So here I have added another function that will basically fetch the real-time weather information. Then here what you have to do, guys, you have to make a tool list. So here you just need to pass all of the object one by one. First of all, I created search tool, right? So I'll give the search tool. Then I created calculator. Okay, calculator. Then I created get stock price. Then I created this current weather. This function I will pass here. Okay, so that's how let's say whatever tools you are creating, you just need to make a tools list. Okay, you have to give one by one. All the tool list you have to give one by one. Okay, just try to remember. Let's say you are creating 10 different tools, you have to give 10 different lists here. Once it is done, you have to do the bind operation with your LLM. That means you just need to tell your LLM, okay, now you have the tool. So that's why I'm not going to use the simple LLM right now. So the LLM object we have created is completely fine. This is completely fine. Okay, now we just need to bind this tool with the LLM. So here there is a function called bind tools, and inside that you have to pass all of the list of the tools. And now you'll be using this object LLM with tools. Okay, now let's bind that tool. Done. Now we are defining the state. I think the same state you remember we created previously. This state, no change. Let's define that. Now this is our chat node, guys. I think you remember we created this chat node. And here we need to create another additional node called tool nodes. Okay, I told you about this tool nodes, right? In this my Excalibur file, you can see this is the node. Additionally, we are adding this particular node, and this is a predefined node. Okay, you don't need to separately write that. So here we are using this tool node function. I think we have imported this tool node, and inside that we are passing the tool. Okay, tools, list of the tools we have, and this will become your tool nodes. Let's define both of the nodes. Now once it is done, guys, now we'll try to create the graph. Now we are using state graph and we are passing the state. Now we are adding the nodes. The first node we are adding, which is chat node. Okay, we are adding the chat node, as you can see. Then the second node we are adding the tool node. You can see the tool node. Okay, we are adding this tool node. So both node we have added. Now we have to do the edge connection. Now how my edge connection will look like? As you can see, first of all, start to chat node. So start to chat node. Then chat node itself will have a conditional edges with the tool condition. Okay, I think I told you about this one. Chat node will have a tool condition. Okay, edge connection. Basically this tool condition will decide whether it has to call the tool or whether it has to use the default large language model. So that's why this connection would will look like that. So you will be using add additional conditional edges and from chat node to tool condition. Okay, now this tool condition will decide whether it has to use any kinds of tools or not. Okay, then here you just need to write another edge connection tools to chat node. Okay, why you have to write this one, let me show you. If I, let's say, don't give this line, let's say I will comment this line. So what will happen, let's try to see. Let's say I have added my chat node and tool condition. Now if I show you compile and show you my graph, so that's how my graph looks like. Okay, and this is similar to this particular graph. Okay, and one thing I think you have observed here, I'm not using the simple LLM. Okay, right now I'm using LLM with tools. So that means this object, because here I did the bind operation with my tools. Okay, so make sure you add this line, otherwise it will not work. Okay, so many people do this mistake. So basically they use the simple LLM and they feel like, okay, it is not using the tool. So that's why this object has to be called here. Now let me show you my execution. So now here we are giving a message. So first of all, I'm giving hello, and you know, like for the hello, actually it doesn't need any kinds of tool, right? So this will my regular chat. So it is telling hello, how I can help you today. Now here I'm asking another question. Let's say, what is this particular expression? Okay, what would be the result of this expression, mathematical expression? And now it will use the tool. Okay, because it has the calculator tool, I think you know. So previously we created the calculator tool. So this is the calculator tool, right? It will use that particular tool. Let's execute. See, this is the result it has given me. Okay, now here I will ask another question. What is the new movie release in 2026? Now again it will use the tool. See, new movie release in 2026, and all of the URL it has also given, it has referred. See, this is the different website my tool has referred. That means I'm using Tably search tool, right? And it has, so my Tably tool did the internet search operation and it found the latest movies. Okay, as you can see, and it has given me all of the title of the latest movies, as you can see. Okay, see, but here the output we are seeing, see, this output is not properly readable. This output has also some metadata information. Okay, so if I give this kinds of output to the user, so user will confuse, okay, what to read. So that's why I have to pass this output to the agent again. That's why I told you in my file itself. Okay, so you can see our tools listen for the tool calls. Okay, and once, let's say, it perform any kinds of tool calls, then it automatically route to that particular correct tool, then pass the tool's output back to the graph. Okay, why it has to pass this output back to the graph? Because of that, because this output is not readable. So again, what I will do, this output I will try to pass to the output we are getting. See, right now this is our architecture. So whatever output we are getting from the tools, it is getting ended. Okay, now we have to again give this output to the chat node. Okay, if I pass this output to the chat node will try to refine this output and it will generate a readable output for me. Okay, so that's why I have to do little modification inside my architecture. So let me show you. So here I'll just try to add this line. Okay, basically the tools output you are getting, okay, you are again sending to the chat node. Okay, this is the modification you only just need to do. Now let me again execute. Okay, so I have to execute from the beginning. Now that's how your structure will look like. See, right now we are not returning the tools output. Instead of that, the tools output we are getting, we are again sending to the chat node. Okay, and chat node will refine the output and it will go to the end node. Now let me show you my output. Now see, again, this is using tool. See, now see the result, guys. Okay, see the response. Previously it was only giving this number, but right now this giving the result of this equation is this. This is more readable, right? Because right now the output we are getting from the tools, we are again passing to the chat node, and chat node is doing the refinement. Now here I'm asking what is the new movies release in 2026. Okay, now if I send this prompt, so this is the response I'm getting. Here are some new movies release scheduled for this date. Okay, and you can see all of the movie it has given me. Again, this is a list. Okay, so what I can do, I can um, get the output. Now I just need to get this text. Now see, that's how you can extract the final result. Now see, this is more readable. Okay, this is more readable. I hope you get it, guys. Okay, now let me show you another question. First, find out the stock price of Apple using get stock price tool. Then use the calculator tool to find how much it will take to purchase 50 shares. Okay, now this kinds of question I'm asking. Let's see whether it is able to use my tool or not. Now see, again I'm getting the result, and if you want to get the text, you can extract from here. Okay, the stock price of Apple is that much, and to purchase 50 shares it would cost around that much of money. So okay, now I think you saw it is able to use the tools right now. And this is not a simple chatbot. Okay, this has the tool connection. It can perform any kinds of action. Even you can also ask about the real-time weather information. Let me also ask. What is the current weather in, let's say, New York? The current weather in New York is moderate rain with a temperature that this is the temperature, and feeling like uh, see, this is the temperature, humidity, and the pressure. Okay, each and everything it is giving you. Okay, so yeah, guys, our system is working perfectly. Now we'll be integrating inside our agentic chatbot. This is the complete notebook experiment I showed you, and you have already understood the concept. Okay, how to add the tools, and how to add the tools, and how we can write our custom tools as well. Each and everything I showed you. So guys, now we'll try to add inside our project. So here what I can do, I can simply create a separate file so that you can refer all of the previous code as well. So I'm going to create a file here. I'm going to name it as, let's say, this name, Agentic Chatbot Tool Backend .py. Okay. And inside that, I'm going to copy all of my backend code I had. Okay. The same code you just need to copy paste here. Same code. And here I'll do the modification. And again, I just finished my OpenAI API key limit. That's why I'm using this Gemini model. Okay. But if you have your OpenAI API key, you can uncomment this line and comment this line. Okay. So alternative approach I showed you here. So now here I'm going to first of all import all of the necessary library from my notebook. Just import all of this necessary library. Okay. After that, we are loading the environment variable. It's completely fine. Then if you have OpenAI API, you can uncomment this, but I don't have. I'll be using Gemini model. So once model initialization is done, so let me comment also so that it would be easy for you to remember. So this is the LLM definition. Now we'll try to define the tool. Okay. So here we'll try to define all of the tools we have created here. Okay. All of the tools we'll try to define here. So let's copy all of the tools. So here I copy pasted all of the tools. So first tools, I had my search tool, Tably search tool. Second tool, I had my calculated tool. Third tool, I had my stock price. And the fourth tool, I created this weather. I'll also copy this one. Copy and paste it here. Okay, some error is coming. Okay, now it is solved. The problem was that I just copied till here. Okay, the last part was not copied. Now I think this is fine. Okay, now this is fine. But here I have to import another things, which is this any. Okay, so any and ways. Import ways and import from typing. I will import this any. So in the tools also I have to do the same thing. Fine. Now I think everything is good. This is my calculator. This is my get stock. This is my current weather tool. And this is my chat state. This is my chat state. So here let me comment. This is my chat state. Now I'll define my nodes. Same nodes only. Okay, one more thing I just forget to do. I just need to do the tool bind operation. I think you remember. Here, we just need to bind this tool. Let's do that. So before initializing the state, I will just bind this tool. Let me comment here. Bind tools to LLM. Now state definition is also done. Now I'll define my chat nodes. So this is the chat node, and the change I have done, instead of calling the simple LLM, I'm calling LLM with tools. Okay, this object. Now I'll define my second node, which is tool node. Okay, tool node. So I think remember here also I did the same thing. Tool nodes. Okay. Now this is my connector. That means my checkpointer for the persistence memory. Checkpointer. This part I already taught you. Okay. This is common for all. Now I'll try to define the graph. Okay, we'll try to define the graph. So as you can see, this is our graph. We are adding the nodes where this is the edge connection. We are using the tools condition, and at the last we are just doing this edge connection as well. That means whatever tool output we'll be getting, we'll try to send it to the chat node. That means in the same tools demo.ipynb file, I showed you the same thing. Okay, I just copy pasted the code only. Okay, nothing changed. The same code I copy pasted. That's it. Once it is done, I think this function, you remember, this is the helper function for the Streamlit frontend we used. Okay, that means with this function we are getting the threads. Okay, for the Streamlit we created, I think in my previous video, I think you remember. So yes guys, this is the modification we have to do in the backend .py. Now everything is fine, I think. Let me check. Everything is fine. Now we are ready to test inside our frontend as well. So now I'll just write another frontend file. So here I'll copy this file as it is. And the last file was the db, right? Yeah, last file was the db. So I'll just copy and paste it, and I'll just rename it. App tool .py. Okay, so it has the db with tools code as well. Okay, now here the change you just need to do, which is yeah, if you don't change, it's completely fine. You can use it as it is. Okay, there won't be any kinds of problem. But one I think UI update you won't be able to see, I think, at whenever I show you my application for the first time, right, as a demo. That time you saw whenever I was executing my agent, it was showing it is using some kinds of tool. Okay, see right now if I execute my app. So what will happen? Let me show you first of all. Okay, one more just modification you have to do. This import. Okay. Previously I'm importing from Agentic Chatbot DB backend. Now I have to import from Agentic Chatbot tool backend. Okay. So this update only, and make sure you have your LangSmith environment variable. That means the LangSmith API key and everything, because it will trace everything in the LangSmith. Let me open my LangSmith platform. And let me execute completely fresh. So what I can do, I can delete this one. I can delete this project and let me execute completely fresh. Now I will execute my app, my app tool.py. Okay, this file. Stream lit run app tool.py. Now this is our chatbot. Now let's give the prompt. I'll give hello. See, it's working. Now I'll give tell me the latest news in AI. See, right now you are getting the output like that, but you didn't see it is using the tool. Okay, which tool it is using, but previously in the demo itself you saw it is using some kinds of tool. Even in the chat GPT also, if you're asking, you will be able to see some tool calling. Okay, so some tool calling is happening, right? So let's say if I ask the same question in chat GPT, you will see some kinds of tool calling is happening. See here, it will tell like, okay, I'll search for the internet. See, searching for the internet, it is using some kinds of search tool. So I want to also see this kinds of interface. Whenever my agent is using the tool, I'll be able to see that, okay, this is using some kinds of tool. Okay, so if you want to see that, you just need to do little bit UI update. So in the Streamlit app, you just need to do some little bit modification. So here itself, you just need to do the modification. Let me show you. So here you just need to do the modification whenever you are sending the user input, right? And whenever you are just hitting the agent, that means here you just need to do the modification. So what I've done, guys, I just given this code to the chat GPT and I asked, I just need to see this tool progress on my user interface. Whenever it will use any kinds of tool, just try to do the UI update. So then again, chat GPT given me this code. Let me show you. Chat GPT given me this particular code. So from here, everything needs to be changed. This part. So this is the update chat GPT given me, guys. So right now, basically it will automatically understand whenever it will use any kinds of tool. That time you will able to see in the user interface. Okay. So this code you don't need to remember, guys. You have chat GPT, you have Gemini. Anytime you can do the modification inside at the UI interface, because this functionality is completely user interface. Let's say update. Okay, so as a agentic AI engineer, this is not your task. There are some front-end developer, they will take care of this part. Okay, I need to import one tool things, which is tool messes here on the tool messes. Okay, that's it. Now this is the updated code. Now if I execute this code, let me show you what will happen. So I'll re-execute my app. Now if I ask the same question, tell me the latest news in AI. Now you will see that it will be using some kinds of tool. Now see, it is using Tably search tool and it is doing the real-time search operation and the response it is generating, it is again giving to the chat nodes, and chat node is refining the output. Okay, now you are able to see the okay refinement result. And you can also see the tool execution. That means in the behind the tool, what the execution is happening, this is also available. Okay, like chat gpt you can also see the behind execution process, like what the website it has referred and everything, you will be able to also see here. Okay, this is also possible. Now let me ask another question. I'll tell uh, calculate this number. Now we will see that it will use my calculated tool. See, calculated tool done. Okay, now here I will ask, now here I will give another prompt. What is the current weather in New York? Okay guys, one problem I found, it is not able to use my current weather tools. Okay, why? If I show you the code, see, whenever I did the bind operation, right? So here I didn't add my current weather tool here. So this is the problem. So what I will do, I'll just try to copy that code. That's why I'm telling why it's not working. Yeah, so I'll copy this code as it is and paste it here. Okay, now I think it should work. Let's see. I'll re-execute my app. Now here you can ask the same question. What is the current weather in New York or any other city? Now see, it is using get current weather tool, and this is the current weather in New York right now. Okay, and you can also ask any other question as well. Tell me, give me all the movie list in 2026. See, it is using Tabilis rule, and it will real-time search over the internet, and this will give you the result. See, this is the entire result. I'm getting all the latest movie information I'm getting here. Amazing, right? Now my agentic chatbot is working like ChatGPT. So ChatGPT has this kinds of tool as well. That's why it is giving you real-time informations. Okay, and our chatbot is also working in that way. Now if I open up my LangSmith dashboard, so if I go to my project, now here all of the trace has executed. Even you can see trade wise. Okay, trade wise you can see. Now I will see this particular trade. So I will open it up, and you can see the execution. Now here you can see, guys, I have added the tool, and automatically this tools has integrated inside my LangSmith dashboard as well. Now see, this is my chat node. Okay, and whenever you given this message, it will go to the chat node. Chat node will hit the invoke the LLM, and LLM has the tool condition integrated. Okay, now tool condition has decided, okay, it has to use the get current weather tool, because what was the question? The question was, what is the current weather in New York? So it will go to the tools condition. Tool condition will decide, okay, it has to use the tool, and which tool it will call? Get current weather tool. Okay, this tool it will call. Now tool condition will try to redirect this thing to the tool nodes. Okay, and now tool nodes will select this get current weather tool, and what would be the location? New York. And if you pass this New York to the get weather function, this will return you the current weather information in New York. You can see this is the output. Okay, and this output we are sending again to the chat node. Okay, you can see, say again sending to the chat node. Now this is the input as well as the user input. We are sending it, and AI is generating this refine output. Okay, so that's how the entire system is working right now. Okay, now I think you can see, guys, what is the use of LangSmith as well, because in the LangSmith itself you can debug everything after which node is executing, whether it is able to select the right tool or not. Okay, So that's how you can understand each and everything. I hope it is clear, guys. Okay. So yes, guys, this is all about of our agentic chatbot. Now, this agentic chatbot is not a simple chatbot. Okay, this has the tool connection. It can perform different actions. Now I can tell this is more advanced agentic chatbot we have created. Now some other functionality also needs to be added in this agentic chatbot. We'll also try to add the RAG functionality. That is, you can upload any kinds of document. You can perform the chat operation. So yes, this is all about from this implementation. I hope you liked it. So if you like this implementation, guys, please try to subscribe to my channel and share this video with your friends and family. So guys, this is our agentic chatbot we have developed so far, and we have integrated lots of features with this agentic chatbot. Now this is not a simple chatbot right now. This has conversation, threads. It has tool integrations. It has streaming features. Even it has the persistence memory with the permanent database. Okay, so this is not a simple chatbot right now. Now the functionality I have added here, this RAG functionality, that means RAG functionality. Now in this chatbot, in this agentic chatbot, you can upload any kinds of documents, okay, and you can start doing the conversation on top of that, like ChatGPT. Okay, so ChatGPT also has the same features. If I show you the ChatGPT, so in ChatGPT also you can upload any kinds of documents and you can perform chat on top of that. So first of all, let's see our application. Okay, so here let's say I will upload a documents. Let's say this is the documents I will upload. So this is a research paper. Actually, I published this research paper. So as you can see, this is the paper, guys. The paper name is development of multiple combined regression method for rainfall measurement. Okay, so here you can see I was the author. Okay, so I contributed in this paper. So this paper covers about the rainfall measurement. Okay, by using some regression methods. Okay, you can go through the paper. This is also available on the ResearchGate. Okay, now what I'll do, I'll just upload this paper on my agentic chatbot. I'll select this paper, I will upload it. See, it is getting uploaded and it is processing. Okay, so once it is done, now see here you can see the successful message. Now I can perform the chat operation. Now I'll just ask what is rainfall measurement based on the uploaded PDF. Now see, it is using my RAG tool. Okay, so internally I created a RAG tool. It is utilizing my RAG tool and it is giving you some kinds of response. As you can see, the document highlight that predicting the amount of rainfall recorded in millimeter is crucial. It notes that conventional methods for forecast for foreseeing rainfall using equipment based on climate coordinations like temperature, humidity, and weights are not productive. Okay, instead the paper process using the machine learning procedure and specifically a predictive regression analysis technique. Okay, so yes, if you go through the paper, guys, you will be able to see the same things this paper covers. Actually, we proposed some regression method for this rainfall measurement technique. Okay, now you can also ask any other things like, say, what is the methodology of this paper in methodology. Okay, now I'll send this prompt. Now see, it is again using the RAG tool, and uh, it is giving you the entire methodology we have written in the paper. You can see this is the entire methodology. So if you go through our paper methodology, you will be able to see the same things we are discussing there. Okay, so that means like ChatGPT, we are able to upload any kinds of documents. Okay, and we can perform the conversation. So in ChatGPT also you can try, you can upload your documentation. Okay, and you can do the conversation on top of that. And we have also integrated the tracing features with our agentic chatbot. That means it will continuously monitor our agentic chatbot. Okay, and we are continuously tracing the execution on the LangSmith platform, guys. As you can see, these are all of my trace. Okay, and you can monitor the entire trace, entire, let's say, application in this LangSmith dashboard only. Okay, so this part I also showed in my playlist. Just go through and check that how we can add this LangSmith functionality inside our application. Okay, so yes, this is the features guys I have added inside our agentic chatbot. And trust me, this is very much important whenever you are creating agentic system. Nowadays, all the agentic applications are having this kinds of RAG functionality. That means you not only you can do the conversation with the tools and the default large language model. Instead of that, you can upload your private documents and you can continue the conversation on top of that. Okay, everything is possible here. So yes guys, this is the application, and apart from that, this application can also handle different conversation. Let's say if I'm asking, tell me the latest, okay, latest news of FIFA, okay, 2026, did Brazil on the game. Now see, this is the question, this is the latest information I'm asking, and my agentic chatbot will be using some kinds of search tool and it will give me the response. Now see, it is using Tably search tool. I already told you about what is Tably, right? And it is doing the internet search tool. It is doing the internet search and it is giving you the real-time response, as you can see. Yeah, so this is the answer. In the FIFA World Cup 2026 Group C match, which ended in a 1-1 draw. Okay, then Vinicius Junior scored Brazil in this simulated game. Okay, so this was the like match, guys. If you have already watched that Brazil match, you saw like this was a draw match actually, and this Vinicius Junior actually scored one goal for the Brazil. So yes guys, that's how our agentic chatbot works, and you can upload any kinds of documents right now and you can start the conversation on top of that. Apart from that, whatever functionality we have created so far, whatever tools we have integrated so far, it will be working like a same, right? So now let's start implementing this functionality inside our agentic chatbot. But before that, first of all, I want to give you the idea about RAG, what is Retrieval-Augmented Generation techniques, and why it is useful, okay, and how this system works. Okay, first of all, we'll try to understand, then we'll start the development, guys. So guys, as you can see, RAG in agentic chatbot, it's a very important features. Not only in agentic chatbot, whenever you are working with the generative AI technology, especially with the large language model, this RAG is very important like component of that. If you have already studied about Gen AI, I think you already work with RAG concept, right? So RAG helps us actually in three measures actually field. One is the outdated knowledge. So I think you know whatever large language model you are using, it has a knowledge cutoff, right? So if I'm talking about the, let's say GPT 4 or GPT 3.5, right? It has a knowledge cutoff till 2021. This model got trained, and after that actually whatever new data came in the internet, this model doesn't have the access to that data, right? Because it has a knowledge cutoff. That means if you are asking anything regarding after that date, this model won't be able to give you the response. So it's not like that. Again, you have to fine tune that model, okay, on the new data, because fine tuning at the end, it's a costly task. For this, you need a good instance, you need good infrastructure, you need lots of money, you need lots of data, right? So that's why researcher introduced the RAG concept, and with the help of RAG, actually, you can give external data to the large language model as a knowledge base, and your LM will be able to generate the response you are asking about the latest information you have already given, right? So this is the concept of the RAG. So that's why if your model has outdated knowledge, that time RAG is very important for that, and only things you have to create a detailed knowledge base, okay, with your custom data. Now the second thing is the private data. Okay, so what is private data? Private data means, let's say just I showed you one example. I uploaded my paper, right? I uploaded my research paper. So this research paper is my private data, and I want to perform some conversation on top of my private data. I want to understand about my private data. Not only research paper, you can upload any kinds of private documents of yourself. You can upload about your life story, you can upload about your, let's say, any kinds of inventory list. Okay, anything you can upload and you can perform the conversation on top of that. Okay, so this private data actually is not available in the LLM, okay, the default LLM we are using. So that's why we have to create this RAG technique so that I can upload any kinds of private documents and I can start doing the conversation on top of that. Okay, I can ask anything, I can get any kinds of feedback from my like chatbot. Then the third is the hallucination. Hallucination happens, let's say, whenever you are asking your agent to do something. Let's say you are asking, give me some, let's say, research topic link, okay, for that particular topic. Let's say this topic your agentic chatbot doesn't know, right? Let's say this is completely a new topic. This is not available in the large language model knowledge base. So that time what will happen, it might generate some wrong URL, right? It might generate some wrong URL, and if you go to the URL, you will be able to see this URL is not working, this research article is not working, right? So instead of, what you can do, maybe you can give some of the resources. Okay, you can give some of the document to your agentic chatbot as a external knowledge, and you can tell like, okay, now refer this actually knowledge, and you can generate some like research topics, or let's say URL, okay, on top of that. So that time actually your LLM will not do the hallucination. But if you're not doing that, there is a possibility your chatbot will do the hallucination. Okay, it might generate something wrong information for you. So that's why this RAG technique is super important whenever you are creating this kinds of system. That's why nowadays all of the application you have seen like ChatGPT, Gemini, okay, these are the application are using this RAG concept in their application. That means you can upload any kinds of documents, okay, PDF, whatever, and you can perform the conversation on top of that. Now let's try to understand how this RAG works. So this RAG came from actually in context learning techniques. So in context learning, what happens? So this is the like high level diagram of this in context learning. So here we not only pass a query, okay, to the large language model. With the help of with this query, we also give some kinds of external context. Okay, then we prepare a prompt, and this prompt will try to send to the large language model, and large language model will generate some kinds of response. Now let's try to see this part in action. So what I'm going to do, I'm going to give you one example. Let's say here you are asking about your let's say paper. So I uploaded one paper, I think you remember, called rainfall measurement paper. So if I ask directly this question, okay, to my large language model, let's say here I'm using very old large language model, and this large language model trained till let's say 2019, okay. And if you see my paper, guys, this paper I published around 2021, okay. So this paper information, definitely it's not available inside my large language model. So if I'm asking about this let's say paper, let's say tell me about this rainfall measurement paper, okay, rainfall paper, okay. Let's say I'm asking my large language model, this is my entire prompt I'm passing to the large language model. That time large language model will definitely not provide the response because it doesn't have the information, okay. So in context learning, what happens, instead of giving the direct query, you can also pass the context. Context means here you can give the entire paper, okay, you can pass the entire paper, okay. You can extract all of the content, or you can directly give the paper, okay, as a context, and you can combine a prompt. Let's say tell me about rainfall measurement paper, and here is the paper content, okay, content, and you are already passing the paper here, right? You're already passing the paper here. That means you are giving the query as well, okay, you are also giving the paper, okay. Then you are asking, tell me about the rainfall measurement. Now your LLM has the context as well as the query. Now it can generate the response, okay. You are ask it can generate the response, the question you are asking, by using this particular context, okay. In real life also, let's say if I'm asking you anything which is completely new, and let's say if you don't know that information, if you don't know that, let's say, question, that time you will directly say, okay, I don't know. But if I give you some kinds of context, let's say I will ask about tell me about let's say Brazil team. Okay, so what you will do, if I give you some context, let's say if I give you list of the Brazil player, let's say name list, then you will be able to give me, okay, these are the players are available in Brazil team, right? It's like that. That means you are not only giving the query, but also you are providing the answer. That means the context, okay, the entire paper. Now LLM is referring the paper, and it is generating the question you are asking. Let's say you are asking about rainfall measurement. It will be able to understand about the rainfall measurement from the paper, and it will give you some kinds of refined response. So that's how in context learning works. Okay, but the problem with the in context learning is, so let's say here the paper I am uploading, it might have lots of content, right? It might have lots of content means if you see the paper, all of the words you can consider as a token, right? And if you count all of the token, there is a chance this token, okay, number of token might increase than your input length of the model, input limit of LLM. Okay, so every model has a input limit, right? Token limit. If you open any kinds of model, right, in Google, you will see that it has an input limit, token limit. Let's say the model we are using, this model can take 1000, okay, 1000 token input at a time. But if you're passing the entire paper, let's say the paper token I have counted, it is around 5000 token, okay, 5000 token. That time definitely this token is bigger than your input token limit. That time there would be an error, okay, and there would be some kinds of input error. That means you can't pass that many of token as an input to the model. Okay, so this was the problem with the in context learning. So that's why from the in context learning, one concept has introduced. The concept name is RAG. Okay, so in RAG, actually what we do, instead of giving the entire documents directly, we perform something called chunking, we perform something called splitting. Okay, we divide our entire content in a different chunk, different split, and we pass this different chunk, okay, one by one to the model. So this is the like updated architecture. As you can see, let's say here I am having an entire documents. First of all, we'll try to extract all of the content from the document itself. Okay, we'll load the documents and we'll extract all of the content from the documents, as you can see. Okay, and once it is done, we'll try to perform some kinds of chunking operation. We also call it as a splitter, text splitter. Split means, let's say this is my entire docs, right? This is my entire content, and I'll just try to create a different chunk. I'll try to divide this content, okay, in a different part. This is called text splitter. Okay, now let's say if your original documents, it is around 5000 token. Okay, now after doing this splitter or chunking, every let's say chunk will have, let's say, 1000 token. Okay, 1000 token. That's how you can create five actually chunk here, or let's say 4 chunk here or 6 chunk here. It's completely up to you. Okay, but this input should be less than your model input. So once you have created the chunk, then you will be using some kinds of embedding model. I think you know about embedding model. What embedding model does, basically embedding model we use to convert our text to the number, because the large language model we are using, right, it can't take directly the English text as an input, okay, internally, because this is some kinds of mathematical equation. So we have to convert as a number, right? We'll be using this embedding model and we'll generate some kinds of vector embedding. This is called vector embedding, right? This is called vector embedding. Now this vector embedding, we have to store somewhere. This is called actually vector database, and we also call it as a vector store. Okay, especially in RAG, you will be using vector database, not a traditional normal database. Okay, here you have to use vector database because there is a concept called similarity search or semantic search you have to perform, and this is only possible in vector database only, right? Then you will be storing all of this vector in the vector database. Okay, now this will become your knowledge base. This will become your knowledge base, guys. Okay, now this knowledge base we have to connect with our large language model right now. Okay, now this part actually we perform the retriever operation. That means if user is asking about a question about the, let's say, the paper I have uploaded, rainfall measurement, so first of all this question will go to the knowledge base. Okay, because knowledge base has all of the, okay, all of the information about the rainfall measurement, because I have uploaded the entire paper, it is available right here, right? So then this retriever, it will go here and it will perform a semantic search operation, and will only extract that part which is required for the query. Let's say here I'm asking about what is rainfall measurement, but if you open the paper, instead of rainfall measurement, it has lots of like see topic. it has the related works, it has the methodology, okay, then it has some comparison, it has some data set introduction, okay, it has some diagram, pre-processing section. So I don't need all of the information, I only need that part where it covers what is rainfall measurement exactly, okay. So with the help of the similarity search, it will only found that information, okay, which is you are asking in the query, and it will give you that particular relevant response. So here you can see this question will go to the knowledge base, and knowledge base will return some relevant response based on the query you are asking. Most relevant chunk, okay, we call it as a most relevant chunk or context. Then you are combining the query also. Here you can see the query you are also combining. Then you are preparing the final prompt. That means you are combining this query with the prompt. Let's say this my query is what is rainfall measurement, and you got the rainfall measurement answer. Now we are combining the prompt. What is the tell me about rainfall measurement, and here is the context. Then you are generating entire prompt, and this prompt you are passing to the LLM. Now LLM has the query as well as the context, okay, the question you are asking. Then LLM will try to read that, it will understand, and it will refine some kinds of final response, and it will show you this particular response, okay. So that's how the entire RG system works, okay. So this is the better version of the in context learning, because in context learning we pass the entire documents, okay. And what is the problem with the entire documents? Because it has an input limit. But here uh, if you are giving, let's say, thousands token input as well, it doesn't matter, because it perform the chunking operation, it perform the splitting operation, and all of the entire documents would be split into different chunk, and it will store in the vector database. Then you can perform any kinds of retriever operation, okay, similarity search operation, and you can perform these kinds of question and answer on top of your private documents. So that's how this RG system works, guys, okay. I hope this part is clear to all of you. Now we'll try to implement this system, guys, inside our agentic chatbot. But before that, I want to show you the notebook experiment, okay. Like let's say I will show you the step-by-step procedure how we can implement this RG, okay, with our agentic chatbot, because we are using LangGraph, how we can do it with the help of LangGraph. I'll show you the entire experiment, and once our experiment is working, then I'll try to integrate inside our actual code. So guys, as you can see, this is our entire code, and this code I have already uploaded in my GitHub, and link is given in the description. So here in the notebook folder, guys, I added another notebook called rag demo. Okay, just open this notebook, and here I already written all of this code required to implement this RAG functionality, right? Instead of writing from scratch, because it will take lots of time. Instead of that, maybe I can go through my implementation, right? So here just try to select your environment. After that, first of all, you have to import all the necessary libraries. Okay, so here I have already imported all the necessary libraries, guys. As you can see, OpenAI embeddings, okay. Even I've also imported this Google Generative AI, because if you don't have OpenAI API key, if you don't have OpenAI, let's say, provider, that time you can use alternative way for running this project. You can use Gemini model, and Gemini model by default you will be getting some free access, okay. You can use that particular model. So that's why I'm importing this Gemini, and if you want to use this Gemini, you have to import this chat Google Generative AI functionality, and I have already installed this in my requirement. As you can see, this library I have already installed there. Apart from that, you have to also import this Google Generative AI embeddings, because I don't have OpenAI embedding model, right? I don't have OpenAI API key. That time I can use Gemini embedding model, okay. So that's why both I have imported. Let's say whichever you have, you can use them, okay. Then load env PyPDF loader. See, if you are implementing RG, that time this thing is required. If you are uploading the PDF document, that time from LangChain community, you can import this PyPDF loader. This is already available in document loader, and for this you have to install some library like LangChain community. Then you have to install Fires CPU. Fires is a vector database, okay. Apart from Fires, actually there are some other vector databases are available, like WebVT is there, ChromaDB is there, Pinecone is there, okay. Maybe in future project we'll try to use, but in this project I'm going to use Fires, okay. Fires vector database, and Fires is a in storage database. That means it will create the database inside your computer, okay, inside your computer hard drive. And there are some cloud-based vector database are available, like WebVT is there, then Pinecone is there. You can store all of your vectors in cloud, okay. This part I will also show you later on. Then PyPDF you have to also install, because we'll be uploading PDF documents here. So in this project, guys, only just to show you, I'll be considering the PDF documents, but if you want, you can also upload the docs format, you can upload Excel format. Okay, this part you can go through the simply LangChain documentation. Okay, there you will try to see how to load the documents, how to load the Excel documents. Okay, each and everything they have given, but here I'm going to only consider PDF documents. Then another library you have to install called LangChain text splitter, and this LangChain text splitter will be using for this actually chunking operation. Okay, from the entire document will perform different chunk, right? And with the help of this LangChain text splitter will be doing this particular work. And here I have already specified the version. These are the version you have to install. And how to install? Open your terminal and just execute pip install -r requirement.txt. Okay, if you do that, it will install in your system. Okay, so I have already installed all of the necessary library, guys. I don't need to install again. But if you're doing it for the first time, you have to install these are the library. Okay, even all the comment I have also given in my readme.md file. So once it is done, guys, let's import all of the necessary library. You can see I'm importing this recursive character text splitter from LangChain text splitter, and with the help of that, we'll be performing the chunking. Then we are also importing a vector database. It is also available inside LangChain community vector store. I'm importing FIAS. Okay, and FIAS is implemented by Meta AI team. Okay, by Facebook, this vector database has implemented. Then we are importing tools, graph, then annotated type dict. These are the things are common. Add messages, human message, base message. Okay, and from LangGraph, we are also importing some pre-built, let's say, node like tool node and tool condition. So these are the things are common. Okay, so this is our entire import. Let's import them one by one. So see, guys, I have imported successfully. Now we have to load the environment variable. So as you can see, we already have the environment variable here, and here I have already added all of my API key. I used Davili API key, I used Open Weather API key, Google API key. Okay, and this API key I collected from Google AI Studio if you want to use Gemini model. So in my previous video, guys, I showed you this part. Okay, how to collect all the API key. You can go through that recording. Then from LangSmith tracing, guys, we have added these four things, and here you have to pass the LangSmith API key as well from the LangSmith platform. Okay, so these are the credential you need. Now let's load all of them. Now if you're already having this OpenAI API key, you can uncomment this line and you can use OpenAI model. And if you don't have OpenAI API key, if you have only Gemini key, that time you can use this definition. Okay, so here we are using Gemini model. So let's load the Gemini model. Now we'll try to load my paper. Okay, one of my documents. So here I already kept my documents, my paper. That means this paper I already copied in the folder. Okay, you can use any other documents as well. So this is the name of the PDF. So I have to load this particular PDF. Now for loading it, I'm using PyPDF loader because this is a PDF file. Now let's load that. Okay, so once you do the loader.load operation, you will be able to see the entire documents. Now let me show you the entire documents. So this is the documents. Now by default, LangChain loads your documents into document format. Okay, as a page by page. So how many pages this is having? I think this PDF is having 15 pages. Okay, 15 pages content I have extracted. Okay, and you can see some metadata are available, but the main part is that the content. So let me show you. Here is the content, page content. Okay, and in the page content you will have all of the text. Okay, I have in my PDF, and these are some meta information. Now we'll try to perform this operation. That means we have extracted the entire document. Now we have to perform the chunking, guys. Okay, we have to perform the chunking. Now this part actually performs the chunking operation. We are importing recursive character text splitter, and here we are defining the chunk size. Okay, that means each of the chunk will have how many token. Okay, here we have defined each of the chunk will have 1000 token. Okay, and there is a another parameter you have to provide called chunk overlap. This chunk overlap basically means that there it has to add some overlapping. Okay, overlapping means let's say it is extracting 1000 token. Okay, let's say till here you have 1000 token. Okay, now next again it will create another chunk, right? Let's say from here it will start, but if there is a chunk overlap, let's say 200, what it will do, it will go back 200 word. Let's say 200 word starts here, then it will create again 1000 tokens from here. Okay, that means from your previous chunk, okay, there is an overlap I am creating so that my model can understand, okay, after this token, after this let's say chunk, this chunk is starting. Okay, so that's why this overlapping is important, and this is the concept of RAG. Okay, I already covered in my YouTube channel. There is a dedicated generative AI playlist I'm having. You can go through that playlist. There I covered this RAG concept in detail. Okay, you can understand these are the concept there. Then after that, we are splitting the documents. We are passing the entire documents, and you can see we are creating the chunk. Now total I got 44 chunks here. Okay, that means I got 44 chunks here. Okay, by doing the splitting of my entire content. Okay, and each of the chunk will have 1000 token because our chunk size was 1000 token. And this is completely hyperparameter number. You can also change this number as per your requirement. Now guys, we'll be defining the embedding model right now, and here if you have OpenAI API guys, you can execute this code. This code actually loads the OpenAI embedding model and it stores in the FAIS vector database. But if you don't have OpenAI, you can execute this code. And this code uses Gemini embedding model. Here you can see I'm using this Gemini embedding model, and we're storing our vectors. Okay, we are storing our vectors inside my FAIS vector database. Okay, FAIS vector database, and for this is the code FAIS does from document, and here you have to give all of the chunk and your embedding model as well. Okay, now if you execute this code, now see here you will be able to see um, one database, but this is only visible if you write this line vector store save local. Okay, and here you have to give the name. Now if I execute again, now see it has created the FAIS database here. Okay, in your computer. Okay, that's why I told you this is an in computer database. It will store inside your computer storage. Okay, now we'll see the vector store. So this is the object of the FAIS vector store. Now we'll just try to create a retriever. Okay, retriever means if you want to perform this semantic search operation, you have to create a retriever of the entire database you have created, because user will give a question, and this question will first of all go to the vector store. It will extract the most relevant chunk, and it will combine your query, then it will prepare a prompt. Okay, for this operation you have to create this retriever object. How to get the retriever object? You just need to write vector store as retriever. Okay, then here you have to provide the search type, and here we'll be using similarity search operation, and the search keyword is 4. That means it will extract 4 relevant response at a time. Okay, let's say if you're asking about what is rainfall measurement, it will go to the vector store and 4 relevant chunk it will try to extract. Okay, so this is the parameter. If you make it as 5, it will extract 5 chunk. It will, if you give let's say 2, it will only extract 2 chunks. Okay, that's how these things works. Now we'll try to create the retriever. So once retriever is created guys, now these things we want to integrate inside of Agentic Chatbot. And Agentic Chatbot, if you're using RAG concept, you have to actually create a tool of your entire RAG you have created, right? But in simple RAG, we don't create the tool. We just directly perform the question and answer on my retriever with my large language model. Okay, but here we have created Agentic Chatbot, and Agentic Chatbot works with the tool. So guys, as you can see, I have written this retriever functionality as a tool, and this is the function I have created, and I made it as a custom tool. So before showing you this one, first of all, I want to show you how retriever works. Let's execute retriever independently. So I'll copy this one, retriever.invoke, and here let's pass a query. I'll give what is rainfall measurement. Okay, now see, this will return you actually 4 relevant information. See, 4 relevant information. Why? Because this search keyword you have set it as 4. This k parameter is 4 right now. That's why 4 relevant response it is giving you. See, these are my 4 relevant chunk I am getting about the rainfall measurement. Now this will go to the my query. That means I'll add the query here, and we'll prepare a prompt, and this will go to the LLM. Now LLM has the context as well as the question, and LLM will be able to generate the final response for me. Okay, so that's how this system is working. Okay, that's how this retriever is working. Now I have to make it as a tool, because here we are creating an agentic chatbot, and agentic chatbot works with a tool. Okay, now here you can see I have written the same thing just in a function. it will take the query. I'm doing the invoke operation, whatever documents I'm getting. First of all, I'm checking if document not found. So no relevant information was found. And if it is found, then I'm extracting the documents. So here you can see some metadata information are available. So from this metadata, I'm extracting the document sources. Okay, sources means which PDF it is referring. You can see here there is a section called source. Title is there, source is there, you can see source. Okay, so that's how I'm extracting. These are the meta information, page and content. So this information I'm extracting, and we are joining in this list, and we are returning it. That's it. Okay, so this is the function I have written, and we made it as a tool because this is our custom function. And if you want to make it as a custom function as a tool, then you have to use this LangChain tools, okay, decorator there. We have already learned this previously, right? So this is my tool right now, and I named it as a RAG tool. Now further step will be same. That means we'll be adding the tools inside a list, and we'll try to bind that with our large language model. So you can see I'm binding my large language model with my tools. Execute. First of all, I'll execute this code, then execute this. Okay. Now we have to define the state. Now this is our state. And see here, I haven't added other tools because I want to only show you the RAG functionality. That's why I'm only using one tool. But in my actual code, I have also some other tool like calculator, web search tool, then weather tool, then stock market tool. Okay, I think you remember. Then this is our nodes. So in the node itself, I'm using my LLM with tools. Okay, this particular updated one. And here is another node, which is tool node. Now here I am defining my graph structure, and we are adding the edges. And I think this part you already know how to add the tool nodes and tool conditions there. Now finally, this is our graph, and this graph we also saw in my previous implementation. Now guys, we'll try to invoke our chatbot. Now see, this is our regular message. Here I'm just doing chatbot.invoke. I'm giving a message hello, and for this it doesn't need any kinds of RAG tool. It will generate the answer from the large language model only. Hello, I'm here to answer your question about the PDF document. Okay, now here I'm passing my prompt, as you can see. So here I'll just try to tell using the PDF notes, explain about the rainfall measurement technique in a conscious way. Okay, now you'll see that it will use the RAG tool, and it will retrieve the information from the knowledge base, and it is giving you the final response. As you can see, the provided documents primarily discuss rainfall prediction techniques using machine learning regression analysis rather than detailing specific rainfall measurement techniques. Okay, and blah blah blah. Now if I only want to get the text, I'll just extract the text from here. Now see, this is now final answer, guys, I'm getting. Okay, so that's how, guys, now we can perform any kinds of chat operation on my PDF I have loaded here. Okay, that means this architecture we have implemented in my notebook. Okay, I hope you clear, guys. Now we'll try to add this functionality, okay, inside our app. So as you can see, this is our app we created so far. This was our final app. I think last app we created, this one, app tool. Okay, we integrated the tool. Okay, now what I'm going to do, guys, I'm going to add this RAG features with our actual application, and we'll try to conclude this particular video. So guys, we have seen the entire notebook experiment of the RAG, like how to implement the RAG functionality inside our agentic chatbot. And main thing, we have learned this tool, right? Now we have to create this retriever as a tool, and this tool will be using inside our agentic chatbot. So now, guys, we'll be integrating these features inside our actual agentic chatbot we have created so far. Now this was the last file I created, apptools.py. Okay, this was the front end, and the backend was this one, agentic chatbot tools backend. Okay, this was my backend code. Now here what I'm going to do, I'm going to create another file. Maybe I can make a copy of this file, copy, and I'm going to just paste it. Now I'll just rename it. Okay, instead of tool backend, I'll give RAG backend. Okay, I am keeping my old code as well so that you can get a reference. Okay, you can you will have this code so that in future whenever you are practicing, all of the code will remain same. So agentic chatbot RAG backend .py. Okay, so this is my updated code, updated backend I'm going to write here. Okay, and in this code I'll just do the modification, and for front end also I'll just create another one, this app tool, right? Instead of app tool, I'll copy and I'll paste it first of all. Then let's rename it. Instead of tool, I'm going to give rag. .py. Okay. Now, first of all, let's update our backend. So I'll open my backend, and here update would be, first of all, we'll import all the necessary library, whatever we have imported in my notebook. So this is my updated library, guys. As you can see, PyPDF loader, recursive character splitter, Google Generative, AI embedding, okay, files and all. We are importing everything, right? Then after that, we'll be just loading our embedding model. So after large language model definition, we'll just try to load our embedding model. Okay, the embedding model I was using in my notebook. So here I think I remember I was using this embedding model. Okay, let me close some of the file. This file, also this file. Now after that, we'll just write a function. This function will basically take a PDF file and it will extract the documents. It will perform the chunking, and after chunking, it will store all of the chunk in my vector database. Okay, that means this step I perform, right? This step I perform, okay, separately. I'll just do inside a function. So let me show you this function I have already written. After this embedding model, just a minute. Here I have defined this model 2 times, right? Okay, so I have to remove. So what I can do, I can remove and rewrite again. Okay, now I think it's fine. Now I've imported all the necessary library. This is my model. This is my embedding function. So this is my embedding model. Now I'll just write this function. So this is the function. I named it in this rag document. This will take a file path, and we are defining the database path. That means it will create a folder called files database. Inside that, all of the vector would be saved. Now we are loading the file, extracting the document, performing the chunking operation. Now you can see chunking operation. After that, we're storing everything in the files vector database, and then we are saving this database inside our local. Okay, so this is the function we'll be using, and this function we have to use from the front end. So whenever I'll upload any file from the front end, that time I have to execute this function, and this function will create my knowledge base. Okay, this knowledge base would be created. Okay, now I'll just write another function for the retriever. Okay, so this function, what it does, basically it loads your vector database. Okay, that means the database we are creating, knowledge base we are creating, first of all it will load with the help of files.load local. Will be loading this and we'll pass the embedding model. And there is another parameter you have to provide called allow dangerous deserialization is equal to true. Then we'll create the retriever again. So vector store as retriever, we are giving the similarity search and this k parameter like that. Okay, this part we are doing. Then we are creating the retriever object. Now with the help of this retriever object, I'll be able to perform the invoke operation. That means I'll be able to do the search operation, similarity search operation. Okay. Now we'll just write our rag tool as a function. So this is our rag tool, guys. As you can see, we created the same function. We copy pasted the same function from here. Okay, this one. Now this will take the query. We are doing the, first of all, we're getting the retriever. We are calling this function get retriever. This will give me my retriever object. I'll do the invoke operation. Whatever document I will get, I'll extract all of the content from here. Okay, then I will return it. That's it. It's coming. Now after that, we'll be defining all of our tools as it is. Okay, this will remain same. You don't need to change anything. Our stars tool, our calculator tool, then our get stock price tool, then our get current weather information tool. Everything will remain same. Only the change I have to do here. Okay, here I have to add another tool, which is my RAG tool, RAG underscore tool, the function I have created. Okay, this one, this function I have to pass as a tool. Then we are doing the bind operations. Then we are defining the state. And one more change we'll be doing inside our chat node. Now this is a simple chat node we created previously. It doesn't have any kinds of system prompt. Now we'll add a system prompt here. Let me show you my updated nodes I have created. So this is my updated nodes, guys. Okay. So here I added a detailed system prompt, as you can see. This is my system message. As you are a helpful agentic chatbot with access to several tools, use tools tool uses instruction, use RAG tool for a question about uploaded PDF or documents. Always retrieve relevant documents content before answering the PDF related questions. Use search tool for current events, recent information, or informations that requires the internet search. Use calculated tools for mathematical calculation. Do not calculate complex expression manually when calculator is available. Then get stock use whenever user asking about any kinds of stock price, and get weather whenever user is asking about latest weather informations. And answer general questions directly when no tool is required. Do not invent information from the uploaded documents. If the user asks about the PDF but no documents is available, ask them to upload the PDF. Okay, after receiving a tool result, provide a clear and helpful final answer. So that's how, guys, we defined a clear system message to our chatbot right now. Okay, so every agentic chatbot you will see it has a message. Okay, it has a prompt system, we call it as a system prompt. And with the system prompt, basically it performs all the operation. That means whenever you are asking anything inside a chatbot, okay, it works like step by step. How it works? Because it has a proper system prompt, and this thing you have to provide. Okay, so far we haven't given, but now we have given a detailed system prompt because now we have made it more advanced. Now I want my chatbot to be work like a professional way. Okay, that's why we have added this entire system prompt. Now in the message you will give the system prompt as well as the state message user is giving. Then we are invoking it, and whatever response we are getting, we're just returning it. Okay, so this is a simple modification you have to do inside your chat node, and all of the node will remain same. Your tool node, then we are defining my checkpointer SQLite database. Then this is our graph. Okay, all the graph definition, everything will remain same. No need to change anything. As well as my helper function for Streamlit frontend, this will also remain same. Okay, so this is the change, guys, you have to do in the backend file. Okay, so this is the change you have to do in the backend file. Let me check whether anything is required or not. I think everything is fine. Okay, fine. Now I have to change my frontend. Now what I will do, I'll just try to open my frontend app rag.py. Now see what I have done, guys. I just copied my existing front-end code to ChatGPT, and I asked I need a document uploader function features on my chatbot. So try to create a Streamlit user interface for that. Okay, so then I got this code. Let me show you. This is the updated code I got. This is the updated code I got. So basically this has the document upload features. Okay, so if you don't know about front end design and all, don't need to worry. So this is the work of a front end developer. So I also took the help from ChatGPT, and I created this front end part. Only the change you have to do here. Okay, first of all you have to change this import operation. That means right now we are importing from Agentic Chatbot RAG backend. So from Agentic Chatbot RAG backend. Okay, we are importing chatbot. Then get all threads. Get all threads. Okay, this one. And we are also importing ingest RAG documents. Okay, that means this function I need whenever I will upload any kinds of documents on my Streamlit. So this function will be executed and my vector store would be ready. Okay, that time. Then everything will remain same. Only the change here it has done. Let me show you. See, this is the new code it has added. If you compare with your previous code, so this part has changed. Okay, so here in the uploaded section, that means in the user input section, it has added another one called uploaded file. So basically here it is taking a PDF file upload, and we are taking this PDF file, we're saving as a temporary file. Then we are calling this ingest RAG documents. We are passing inside this function. Okay, and this function is creating my knowledge base. This knowledge base is be created. That means this vector store would be created. Once my vector store is created, Now you will be able to perform the chat operation. Again, we are taking the user input and doing the chat operation. Okay, that means all the code are common. Only that part is changed. Okay, that means upload document part is changed. Now let me show you my updated front end, how it look like. So Streamlit run app rag.py. So as you can see, this is my updated front end. Now we can perform the chat operation. Now let's perform the simple chat initially. So let's say I'll give hello, I am Bappy, and this is happening in a like new threads. Okay, completely new threads, and internally it is also tracing our application. Okay, it is also tracing our application with the help of LangSmith. Now I'll give tell me about, let's say, Python. So this is a simple chat. So it is telling you about Python. Okay. Now here I will ask what is the answer of this equation. Let's say I'll give a mathematical equation. I'll see it will use my calculator tool. See, calculator tool it is using, and this is the final result I'm getting. Okay. Now I'll ask what is the current weather in, let's say, Dhaka. Now it will use my get current weather tool, and this is the current weather in Dhaka right now. Okay, now I will ask about the latest information. Tell me the latest news. Okay, latest news of FIFA World Cup 2026. Now see, it is using Tably search tool, and here is the answer I got. Okay, about the FIFA World Cup. Okay, now I will ask. I will upload a documents. Let's say I'll upload a documents. The same documents. Let's say I'll upload my paper. My paper got uploaded. Now I'll tell me about rainfall measurement uh, based on the PDF loaded. Now see, it is using rag tool, and it is giving you the entire response about the rainfall measurement. Okay, this is amazing. Now I'll tell me about the abstract paper. Now see, again it is using rag tool, and this is giving you the entire abstract section. Okay, now I'll ask who is Boktir Ahmed Bappy mentioned in the paper. Now again it is using React tool, and now it is telling Boktir Ahmed Bappy is one of the 6 author of the paper development of multiple combined regression method for rainfall measurement, and here is the address and email address. Okay, amazing, right? So that's how guys our agentic chatbot right now it's working, and it has It has lots of advanced feature right now, and the current one we have added this RAG functionality. Now you can upload any kinds of document and you can perform the conversation on top of that. Okay, like ChatGPT, like ChatGPT also you can upload any kinds of documents. Okay, and you can start doing the conversation here. Okay, this is also possible. And one more thing I want to show you. So if I go to my LangSmith right now, so if I go to my threads, so I'll go to these threads, and here all the conversation I have done. So the last conversation I did this one. Now if I go to the tool condition, okay, I'm Bappy. I think last conversation was that. Okay, this one. Yeah. Now you can see here, whenever I did the conversation, first of all, it went to the chat node, then large language model, then it was redirected to the tool condition. Tool condition was selected the tool. Now it selected the RAG tool. Okay. And inside RAG tool, we are using this vector search retriever operation. Okay. And with the help of that, it is doing the vector search, and it found actually 4 relevant response, I can see. Okay. From my knowledge base. And this 4 relevant response went to my chat nodes again. That means my LLM with the prompt, and then it was generating the final response. Okay, so that's how this entire system is working. And in the LangSmith platform itself, you can monitor the entire system. Okay, this is the best part of this actually application is. So yes guys, this is the chatbot we have created so far. This is our agentic chatbot we have created so far, and everything is working fine, and all the codes I will be sharing in my description section. From there you can check it out, and let me know how this learning is. Okay, whether you are able to learn the agentic AI concept from my playlist or not. So if you found my content useful guys, please try to subscribe to my channel and share this with your friends and family. Okay, your support is required. So if you are supporting me guys, I'll get lots of motivation to bring this kinds of content. Okay, in this video we'll be learning one very interesting concept called human in the loop, HITL, inside our agentic chatbot with the help of LangGraph. If you are following my entire playlist guys from the beginning, I think you remember in my introduction video, I already talked about this HITL, that means human in the loop concept. That means this is the component of an AI agent. Whenever you are implementing any kinds of AI agents, whenever you need any sensitive task, you need this HITL concept, that means human in the loop concept. Okay. So in this video guys, we'll try to learn this entire HITL concept. We'll also see the practical and we'll also try to integrate this functionality inside our agentic chatbot. So before I start this implementation guys, first of all, I want to show you the demo, how this HITL looks like, and after adding this inside our agentic chatbot, how it is going to work. Okay, we'll try to see the demo. After seeing the demo, we'll try to understand this concept in a theoretical manner. Then we'll see the practical implementation as well. So guys, this is our agentic chatbot. That's how this chatbot looks like. So right now you can upload any kinds of document and you can start a conversation, okay, on top of your documents. This is possible. So let's try to test our chatbot. And I already integrated this HITL with this agentic chatbot. I'm first of all going to show you the demo. Then after that, we'll try to see the practical development. So here you can perform the simple chat operation. Let's say if I give hello, so your chatbot will return something. See, hello, I can help you today. Now we'll ask what is the current weather in Dhaka. You will see that it will be using different tools. Okay, that means it will use weather tools, and it will give me current weather informations. Okay, given any kinds of location. Even you can upload any kinds of documents. Let's say I will upload one of my documents. Let's say I will upload these documents. Okay, okay. Now this is one of my resume I have uploaded. Now I'll ask some question on top of this PDF. So tell me about Boktiar Ahmed Bappi based on the PDF. Okay, upload it. Now we'll see that it will be using RAG tool, and it is giving you the entire actually introduction of Boktir Ahmed Bappi. Is a data scientist over 5 years of working experience in the field of generative AI, LLM ops, autonomous AI system, okay, and blah blah blah. You can see the entire summary of me, okay. So that's how, guys, you can perform any kinds of conversation on any kinds of documents, okay. Now here, let me show you this HITL functionality I have added in this agentic chatbot. So basically here I have added this HITL for one sensitive task. Okay, sensitive task means, I think you know that with the help of this agentic chatbot, I can see any kinds of stock price, right? So let's say if I'm asking, uh, let's say what is the stock price of Apple. Okay, so I think you know that it has a tool. That tool actually real-time fetches the stock prices, okay, given any kinds of company. So if I, let's say, send this prompt, you'll see that it will use that tool using get stock price tool, okay, and this is the current stock price we are getting of the Apple. Now I want to perform a sensitive task with this agentic chatbot. Basically I want to purchase a stock of Apple, okay. I want to, let's say, purchase 10 stock of Apple. Now this task required actually human observation, that means human approval. It's not like that you are giving your agents the 100% authority to perform all of the task. It's not like that, because there are some sensitive things you have to monitor, okay, manually, and this needs actually human approval. So here, let's see, if I am asking to my agents purchase, okay, purchase, let's say, 10 stock of Apple. Okay, let's say I'm asking this question, and this is a sensitive task, and for this you will see that it will ask for human approval, okay. Now if I send this prompt, now see, it is asking for the human approval required, approve buying 10 shares of Apple, yes or no. Do you want to give me the permission? If you want, I can buy. So for this you have to provide yes, otherwise you can reject this particular approval, okay. So let's see, if I am giving yes, I will approve this purchase. Now you'll see that it will use my purchase stock tool, and it will purchase the shares of the Apple, okay. Now if I'm again asking this thing, let's say um, purchase 10 stock of Google. Now see, again it is asking for human approval. Now right now, let's say if I'm rejecting the purchase, you'll see that it will not purchase that, okay. Your request to purchase 10 shares of Google was declined, okay. So this is called actually HITL, that means human in the loop. Basically, if you have already used any kinds of agentic system, guys, okay, you will see that this kinds of functionality they are having, they will ask for human approval. If you are already using any kinds of code editor also, like this anti-gravity or cursor AI, okay, there also you will see that whenever you want to generate something, generate some code, or if you want to create any project, it will ask for the human permission, okay, if it required. That time if you are giving the permission, okay, at that time actually it will perform all of the task, otherwise it will decline that, okay. So this functionality, guys, we have integrated inside our agentic chatbot, and now this chatbot is super advanced, okay. Now it can do all of the task, and you can actually integrate this HITL not only in this stock price purchase, but also you can integrate these things in any kinds of, let's say, task you are performing. I'll show you, okay, how to do that. And you can feel free to add so many tools here, okay. So many autonomous tool you can add here. Let's say you want to send automatically email, you can add the emailing tool. If you want to check your Google Drive, okay, how many files are present, and if you want to upload any file, so you can also add these kinds of tools, okay. I already talked about the tools, and this video is already available over my channel. You can see that, okay, how to add different tools. So yes, guys, this is the demo of this HITL, human in the loop. Now we'll try to see this human in the loop. What is this human in the loop, okay, why it is required in a theoretical manner. Then I'm going to show you the practical implementation of that. So guys, if you are completely new to my channel, and if you haven't subscribed yet, please try to subscribe to my channel if you found my content useful. Please support me if I get your support. So definitely I will get lots of motivation and I will bring these kinds of content more. So please try to subscribe to my channel and hit the like, and please try to share this with your friends and family as well. So guys, first of all, let's try to understand what is this HITL is. As you can see from the definition itself, HITL, that means human in the loop, is a design approach in agentic systems where a human actively participates at critical points of the AI workflow, either to supervise, approve, correct, or guide the model's output. Okay. So this is the concept. Actually, it's required whenever you are performing any kinds of sensitive task, whenever you are performing any kinds of, let's say, very critical task. That time this HITL is required. And if you are creating this kinds of agentic system, I think you know that why you need to exactly add this HITL feature, because inside a agentic project, actually there would be multiple kinds of tasks. Let's say here inside our chatbot, we have added different tasks. Let's say our chatbot can perform internet search operation. It can give you the weather information. Okay. So for these kinds of tasks, actually, I don't need this HITL features. Okay. But let's say I showed you one demo. I need to purchase a stock price. This is a critical and sensitive task, okay? And definitely needs human approval. Otherwise, if I give the full authority to my AI agents, it may actually do something wrong. Okay, let's say I will tell, please purchase 10 shares of Apple. Okay, so what it can do, it can, let's say, purchase 20 shares of Apple. Okay, it can, let's say, spend more money okay, of me. So that's why this human in the loop is required in this kinds of critical tasks. That's how inside an agentic AI project there would be multiple like scenario. You might need to add this HITL. Okay, it's not necessary to add this HITL to all of your features, all of your tasks. Okay, wherever you feel like, okay, this is required for me, you can add it there. Okay, so that's why you can see this HITL. It's a design approach in AI agentic AI system. Okay, where a human actively participates at a critical point of the AI workflow. Okay, that means this is your completely your design philosophy here. Okay, you will be designing this kinds of HITL functionality inside your project. Now you can see, think of HITL as putting a human checkpoints inside an AI pipeline, so that important decisions are not made autonomously by the model. Okay, that is what I told you. So whenever you need this kinds of critical task handling, you are not going to give the full authority to your agent. So that time it will not automatically take the decision, okay, by your agent. That time you will be available, okay, in this particular loop, and if you approve that particular task, this will perform, otherwise this will not perform. Okay, this is what actually this definition says. Now you can see why HITL exists. As I already told you, to help agentic system. That means whenever you are creating any kinds of agentic system, so to help the agentic system, you need this kinds of HITL. For an example, let's say you want to implement an agent that will prepare a post. Okay, that will prepare a LinkedIn post, and it will post over the LinkedIn platform. Okay, so here, to create the LinkedIn post, it doesn't need any kinds of human approval. But whenever it will post that, let's say on the LinkedIn platform, that time this human approval is required, because human will review the entire post. If the post is fine, then they will approve this post, and this post would be published over the LinkedIn platform. Okay, so here basically this HITL helping the agentic system, okay, to perform the complete task. Okay, I think you can understand what I'm trying to say. Then the second, to add the accountability. Accountability means, let's say I already told you agentic system can make mistake. So let's say if you are telling I need to purchase 20 stock of Apple. Okay, so there is a possibility your agent will try to purchase, let's say, 40 stock of Apple. Okay, so there is a problem, right? So before purchasing that stock, first of all, you will try to review that whether the amount you want to purchase, it is fine or not. The price Apple is having for this stock, it is fine or not. If everything goes fine, then you will try to give the approval. Otherwise you will try to reject. Okay, so that's why this HITL is exist. It will help you to help the agentic system, and to add the accountability as well. Okay, now you can see HITL ensures accuracy. Definitely if you are implementing this HITL inside your agents, there would be higher accuracy inside your agentic system. Otherwise, there are some problem. I think I've already explained that. Okay, what would be the problem? So if you are adding this one, so definitely accuracy will increase inside your agentic system. That's why in ChatGPT, Google Gemini, whatever agentic system you are using, all of the applications are having this kinds of HITL functionality. Okay, in ChatGPT also, maybe you have observed, it will tell you, okay, do I need to perform this task or not? Okay, if you give yes, then it will perform, otherwise it will not perform. Okay, then safety, definitely safety is required. As I already given you one example, that stock price purchase demo. So there, let's say if I'm not giving these kinds of HITL features, that times there is a possibility our agent will purchase more stock which I don't need. Okay, so definitely this is one kinds of safety. Then the next thing is ethical alignment. Let's say if you are doing a task that have some kinds of ethical alignment. Let's say we are preparing a post for the LinkedIn, and that post should not have any kinds of, let's say, sexual content or let's say abusive content. So that time actually you can have these kinds of ethics. You can basically review that, and if you approve that kinds of content, then your agent will basically post that, otherwise it will not post that. That means if your content is having these kinds of sexual and abusive content, it will reject, and if it doesn't have that time you will try to approve that. Okay, so this kinds of ethical alignment also ensures this HITL. Then better user experience, as I already told you, if you are adding these kinds of things, so definitely there would be better user experience, as you already observed inside our app, right? So it was giving some kinds of approved, let's say, input, and if you're approving that, the task was happening. If you are not approving, the task was not happening. So this is kinds of better user experience, okay, you are providing with the help of this HITL. Then some common HITL patterns, as you can see, action approval patterns: approve, reject before execution. As I already showed you one demo, right? So basically whenever you want to perform any task, and if it needs any kinds of action, so here you can perform with the help of this HITL. You can approve or reject before the execution. Then output, review and edit pattern. So maybe you have seen any kinds of block generation, let's say, agent. So what it does, basically it generates some kinds of output, then it waits for the human review. Okay, human review and edit. So if they review and edit and approve these kinds of output, then it will finalize that, otherwise it will not finalize that. Then ambiguity, clarification pattern. So sometimes your agent is asking, let's say, your agent is getting confused, right? Let's say you are asking your agent schedule a meeting on Friday. So let's say in this week also you have the Friday, and next week also you have the Friday. So that time your agent needs a clarification. Now which Friday it needs to schedule the meeting. So again it will ask you, actually I'm a little bit confused which Friday you are talking about, this Friday or the next Friday. So this is called ambiguity clarification pattern. Then escalation pattern. Let's say sometimes what happens in some kinds of chatbot, so it talks with the customer, and when it feels like, okay, it cannot handle these kinds of scenario, it will redirect to the actual owner of that company, and they will basically handle this kinds of scenario. Okay, this is called escalation pattern, and that can be also implemented with the help of this HITL. Okay, so yes, this is the entire idea of this HITL. I think you have understood. Now we'll try to see how this HITL works, okay, in a practical way. First of all, I will show you this diagram wise how this HITL will work. So for this, here I have taken an example. So here I have taken a basic workflow, guys. As you can see, this workflow, you can consider this is a post generation workflow. Let's say you can generate any kinds of LinkedIn post. So you can see it has the start node. First of all, user will pass a topic, and if submits the topic, it will go to the your LangGraph workflow. Okay, and it will execute the start node. Then it will perform the research operation of that particular topic, and once it found the content, it will prepare the content, and here it will post that particular content over the LinkedIn. But here we'll try to add this HITL feature, okay, because before posting that, definitely it needs the human approval. It will ask me whether I have to post or not. Okay, so if I review that, if I approve that, then it will post, otherwise it will not post. Then this workflow is getting ended. So let's try to understand this HITL with this particular example. So see what is happening. Let's say you are passing a topic name here. Let's say you are passing a topic name of machine learning. Let's say ML. Let me take this color. Let's see you are giving ML topic. Okay. So this ML topic you are submitting here, and it will go to your LangGraph workflow. So this is the LangGraph workflow we have created. Let's say. So first of all, here it will prepare a state. I think you know that we have to prepare a state, right? And here, what would be the state? State would be the topic, and as well as the draft. That means draft post it is generating. Okay, so it will first of all invoke this workflow, and it will go to the research node, and research node will perform the research operation. It will try to find ML related latest let's say information, and it will prepare a post. Okay, once post is prepared, then here we'll try to add this HITL feature. Okay, HITL feature, human in the loop features. Okay, now how human in the loop feature works, let me give you as a high level high level idea. Definitely we'll try to see in practical manner how to write in the code, but I will give you this one high level code diagram how it will work. Okay, so see, whenever you are implementing this HITL inside any kinds of node, right, that time you will be using one function called interrupt. Okay, this is already available inside LangGraph. Inside LangGraph, actually this HITL implementation is super easy. So there is a function called interrupt. Okay, interrupt function. Okay, so once you will use this interrupt function, this execution will pause here. Okay, this execution will pause here unless and until you are not giving any kinds of input. So let's say here I will take a variable called decision is equal to, okay, interrupt. Now here user will pass something. Let's say if user pass this decision is equal to yes, that time post will happen. Okay, else it will reject. Okay, so this is the high level code diagram. You can understand that's how actually LangGraph will work. Okay, so here we'll try to use one function called interrupt, and this function will basically pause the execution unless and until human is not giving any kinds of input. Okay, now you can define your input, like what kinds of input you need from the user. This kinds of functionality also you can add here. Okay, then after getting the input, you can execute your workflow. And one more thing which is very important whenever you are implementing this HITL, you have to add the checkpointer. Okay, you have to add the persistence memory. We have already seen the persistence memory. Okay, persistent memory basically saves all of your state, right, inside a memory, whether you can use any in memory saver, that means in your RAM or any kinds of permanent database. You have to use that, because whenever it will perform the pause operation, right, let's say here it is performing the pause operation. So to execute it again, let's say whenever user is giving the input, okay, after getting the input, this will execute, right? So whenever it will execute, it's not like that it will execute from the beginning. It will execute while it has paused that particular execution. And how it will understand? By seeing the state, because state is saving all of the information, and while it is getting loaded, it is getting loaded in the database. Okay, in the persistent memory, and from the persistent memory it will load that, and it will see that, okay, I stopped in the post nodes, and now I have to continue from the post node instead of continuing from the beginning. Okay, that's why the checkpointer you have to define, this persistence memory you have to define whenever you are implementing this HITL concept inside LangGraph. Okay, LangGraph, it is super important. Okay, I hope you clear, guys. So that's how this HITL will work in practical, and you can implement this HITL in any kinds of node. Okay, any kinds of node or any kinds of tool you are using, you can define that. We'll try to see that. And one more thing, whenever you are giving this input, right, let's say this interrupt is waiting for the human input, and whatever input you are passing, let's say here you are passing this yes input. Okay, so this yes input will consider as a command. Okay, it will consider as a command. So this command actually will go to the again your let's say node, that means your chat node, and if your chat node is getting this yes command, that time it will feel like, okay, now user wants to post that. Okay, then your posting will be happening. Okay, so that means this command is required. A command keyword is required whenever you are using this interrupt function, and whatever, let's say, user input you are getting, you have to store in the command. Okay, now this thing I will also show you in the code. I think by seeing the code, I think this concept would be more clear in your mind, right? But before the code implementation, I have given you high level overview so that whenever I will explain the code, you won't be having any kinds of confusion. Now guys, we'll try to implement this HITL with the help of LangGraph. For this, actually, first of all, we'll try to see a simple example. I think you remember the agentic chatbot we are creating so far. From the very beginning, I have taken this simple workflow. Okay, so this workflow has one node, which is chat node. So if you basically give a input, it will generate the output of that given input, and you will be able to see the output of that. Okay, so here what I'm going to do, guys, I'm going to add a simple actually example of this HITL. So basically here, whatever input is coming right in this particular node. So here we'll just try to add a HITL feature. Okay, HITL feature. So here we'll try to first of all ask the user, do you want to really ask the question? Okay, do you want to really ask the questions to the model? If user sends yes, okay, I want to perform, then the answer would be generated. Otherwise, answer won't be generated. Okay, it looks like very funny, but just to make you understand, actually, I have taken this example. First of all, let's try to see the HITL implementation with this very simple example. Then I'm going to show you with the advanced example as well. We'll use our agentic AI code, the code we have implemented so far, and we'll try to integrate these things. Okay, there. But before that, I want to show you the implementation part, how it can be done. That's why this example I'll be taking. Okay, so I think you have understood what I want to do. So whatever question is coming, first of all, here we'll just try to add a HITL feature. It will ask for the human review. Do you want to really ask the question? If user gives yes, then this question would be going to the chat node, and user will be able to see the output. Otherwise, user won't be able to see the output. Okay, this is the implementation we'll try to do. Now for this, here I already prepared a notebook. So inside notebooks folder, I already kept a notebook, as you can see, HITL demo. Let's open it up. Okay, so I think this code is pretty much common. I have taken the same this example. I think you know that I created a simple chat workflow. Okay, I copy pasted the same code and I added this HITL functionality there. Okay, so first of all, here we are importing all the necessary library. As you can see here, we have taken both model. If you don't have OpenAI, you can use Gemini model. For this, we are using this this library, and some other library we are also importing. And we are also importing the checkpointer, because I already told you, if you are implementing this HITL, you need this persistence memory. Okay, then one new import I have done, which is this from LangGraph types. I have imported interrupt function and command. Okay, because I already told you here, if you want to add any kinds of HITL functionality, you need this interrupt function. Okay, so this should be interrupt. Sorry, there should be a T. Okay, interrupt function. So this interrupt function is required. So with the help of this interrupt, he will try to pause the execution, and he will take the input from the user, and this input will basically become your command. Okay, so you can see this command is also required. Then load env, type dict annotated, and the base message. So let's import all of the necessary library. And make sure inside your environment variable, all of the key are present. Okay, whatever key we're using so far. Now let's load the environment variable. And after that, here I don't have OpenAI API key, that's why I'll be using Gemini model. And for this, I already collected my Google API key. Let's initialize my model. And here we are preparing the state, guys. As you can see, this is our state, the same state we're using. And here you can see in this chat node, we have added this interrupt functionality. That means HITL functionality. Okay, that means here. Okay, here we have added this HITL functionality. So if you want to add the HITL functionality, you have to use this interrupt function. I already told you. You can see inside chat node. See, this was our previous chat node, right? Now this is the update I have done. So here I'm using this interrupt function, and in this interrupt function, you have to give some like metadata. That means the first metadata you have to give the type. So type should be approval. Reason, model is about to answer a question. Okay, then question, whatever question user is asking, this question you have to pass in the question section, and the instruction. Okay, approve this question, yes or no. That means this instruction user will be able to see. Okay, once he will execute the node, this message actually would be visible to the user. Do you want to approve this question, yes or no? Okay, if user pass yes, then this question would be going to the chat node, and user will be able to see the output. And if he sends, let's say no, on that time it will be rejected. Now here we are checking, you can see decision. Okay, decision, and here we'll try to expect a parameter. expect a key called approved. Okay, so if this approved is equal to no, let's say if user has given no, that time I'll simply return the message. Okay, that should be the AI message, no approved. Okay, not approved. If user gives yes, that means I'll simply invoke my large language model, I'll pass the message, and user will be able to see the output. So this is the simple things you have to add, and the main thing here, the interrupt as well as the command. Okay, command functionality. I'll show you the command what to add, but here we are basically using the interrupt to pause the execution here. Okay, and from the front end side, that means from the front end side, that means from the user side, we'll get this approved. Okay, approved key. I'll show you this part. Now let's execute this node. Now here we are building the entire graph, guys. You can see we're taking the graph, we are adding the node. We have only have one node. We are doing the edge connection, and we're preparing the check pointer. So here, just to show you, I am using this in-memory saver check pointer, and we are building the entire graph. Okay, and we're passing the check pointer, and that's how your workflow looks like. Okay, so this is the same workflow. Now to execute the workflow, guys, you need this config, you need this thread. I think you remember, if you are using persistence memory, you need this thread. So here I created a dummy thread, and we are initializing an input, explain the gradient descent in a very simple terms. Okay, this is, let's say, our user input. So this input will invoke with this workflow we have created, and the workflow object is app. So you can see we're invoking this input, and we're passing the configuration. Now let's execute. Now see, guys, here you will get one result. This is the result. Okay, you can see this is the result you are getting. So here you can see this is the human message, explain the gradient descent in a very simple term. And whenever it is going to the chat node, there we added that HITL. Okay, that means here the interruption is happening, it is pausing the execution. Okay, you can see you cannot see any kinds of output. Okay, the model output you cannot see unless and until you are not providing any kinds of input. Now if you want to provide the input, so first of all let me show you the interrupt message. So this is the interrupt message, you can see, and this is the instruction, approve this question, yes or no, and some other metadata we have provided. This is also coming here. Okay, now what I'll do, guys, I'll take the user input. So here I am preparing the user input, I am showing the same message to the user, and here I'm taking yes or no from the user. Okay, so let's say this is my user input. So now user is giving, let's say, yes. Okay, let's say user wants to see the message, that means the output. Now if I give yes, now inside user input what will be present? Yes. Okay, it will present yes. Now how this present, how this input we have to return to the HITL as a command. Okay, now, right now you can see we are again invoking this workflow, but right now inside invoke functionality we are giving this command keyword. Okay, we are giving this command keyword. Inside that we're telling resume is equal to approved. So you have to pass a dictionary. You can see we're giving approved and user input. Okay, so that means approved should be user input. So that's why here I written this condition. Where is that? Yeah, if decision approved, because it is this approved key is getting created newly, right? If approved is equal to yeah, no, that means it will reject, otherwise it will approve that. So that is what actually we are doing here. Okay, that is what we are doing here. Then we are again passing the configuration, and we are again invoking our workflow. Okay, now one error I'm getting. Okay, so guys, we are getting this error because inside our env we haven't set our environment variable yet. Okay, so let's try to set all of my environment variable, all of the key. So this is my updated key I have added here. Now let me save and let me re-execute this notebook. Okay, so again what I will do, I'll just try to execute from the beginning. So let me restart. Now let's execute all of this code. Now interrupt message we are getting. Now we're taking the user. Let's say user is passing yes. Now we'll try to invoke this workflow again. Now see, this execution is complete. Now we'll see the final message. You can see this is the final message we are getting about the gradient descent. But let's say if user is giving no, that time what will happen? Let's say again I will execute this code. User is giving no. Okay, I have to re-execute from beginning because here I have running as a cell by cell, right? That's why. Now I'll give no. Now if I execute my uh, final result, now you'll see the output. Now you can see not approved because user has given no. Okay, so that's how guys you can add these HITL features inside any of your node. Okay, it's not necessary to add inside your node always. You can also add this inside the tools. Okay, this part I will also show you after this demo. Okay, so yes guys, this is how we can add this HITL, and we have seen the simple demo. Now let's try to see the advanced example with our agentic chatbot we have created so far, and this is the actually workflow we have created. And you remember because inside our workflow we are using some kinds of tools, right? And this is our workflow, final workflow. And this code we have already written. As you can see, this is the code we have written in my previous video. If you haven't checked that, please try to go through the recording. So here actually I added the RAG functionality, and we added lots of tool here previously, right? You can see we have added lots of tool. Now guys, first of all, I want to show you this agentic chatbot execution without using HITL. Okay, let's say if I'm not using HITL, what will happen that time? Let's try to see an example. So here I'm going to create a file. I'm going to name it as chatbot without HITL, human in the loop. Okay, so after seeing that, we'll try to add the HITL and we'll see the benefit of that. Okay, so chatbot without HITL. So what I'll do, so the code I have written, the previous code, that means the RAG backend, I think you have seen my previous video. I'll copy this entire code as it is, and here I'm going to paste it. Okay, so here I'm not going to change anything, only the things I have to add a new tool here. Okay, so here I'm going to add a new tool. So I think you remember in this particular chatbot, the sensitive part is the stock price. Okay, let's consider the stock price. So here we are getting the stock price, right, given any kinds of company. So here we'll try to add a new tool. So that tool will basically purchase the stock for me. So here I have written a simple dummy, let's say, tool. So it will only do the print statement, that means return statement. But in actual chatbot, definitely here you have to use some kinds of API. That API will connect the Apple, let's say, stock company, and it will purchase the stock for you. But just to show you here, I have taken a dummy function. So this function, what it does, it takes the symbol as well as the quantity, like how much quantity you want to purchase and which company you want to purchase, and based on that it will give you some kinds of success statement. Let's say you have successfully purchased this stock. Okay, so this thing I have converted as a tool and I named it as a purchase stock. Okay, purchase stock tool. Now what I have to do, I have added a new tool, and this tool I have to add inside my tool list. So I'll go below, and here I have to add this tool. The tool name is purchase stock. Okay, then we are binding this tool. Everything will remain common, no need to change anything. Just a minute, let me check. So everything is fine. We have added this in the list. Now I will go below to list. This is my check pointer. We are using SQLite database, and we are creating the entire graph, and this is our helper function. It's completely fine, but here at the last I will add a simple CLI code. Okay, this is my simple CLI code. Basically I want to execute this file, okay, in my terminal. Okay, that's why I have added this code. First of all, I am printing some message. That means this is agentic chatbot CLI, and here I have taken a demo thread. Okay, because if you know that if I want to because you know that if I want to execute my chatbot workflow, I need this thread. So that's why I created a demo thread, and here I'm running a while loop. Okay, in this while loop I'm taking the user input from the user, and if user is giving, let's say, exit or quit, I'm telling goodbye and breaking the loop. Otherwise I'm taking the user input, okay, and preparing inside my state. Then we are invoking our chatbot. Okay, we are passing the thread ID. Then whatever response we are getting, we're just printing in the terminal. So this is a simple CLI code I have written, okay, just to execute my entire workflow. Now let me show you how this thing will work. So I will open up my terminal and I will execute this file chatbot without HITL. I'll just write Python chatbot without HITL. Okay, now see if I execute. Now see, it is asking for the input. Let's say here I will give hello. It's giving hello, how I can help you today. I will ask what is the stock price of Apple. Now it will use that get stock price tool and it will extract the stock price of the Apple. Now see, the stock price of Apple is okay, that much. Now I'll tell purchase, okay, purchase 10 stock of Apple. Okay, now see, if I send this prompt, it will directly purchase the stock. It will use that tool, right? Like a purchase stock tool, and it will purchase the stock. And here you can see the message, I have successfully placed the order to purchase 10 stock of Apple. Now see here, it is not asking any kinds of user input, right? Although this is a sensitive task we are performing, but it is not asking any kinds of input. So there is a possibility it may do some mistake, right? Instead of purchasing 10 stock, maybe it can purchase 20 stock, right? Let's say instead of purchasing stock in Apple, it will purchase the stock in Google. Okay, so this kinds of mistake my agent can perform. I think you know this is completely large language model and it can perform any kinds of wrong task. It can do hallucination. I think you know that, right? It's not always perfect. So here definitely I need a human approval here. Okay, if I want to perform these kinds of sensitive and critical tasks. So this is the execution you have seen without HITL, and this is the problem here. Okay, right now I'm going to show you if I add this HITL with this chatbot, what will happen right now. Let's try to see. So I will exit this terminal. Now here I'm going to create another file and I'm going to name it as chatbot with HITL. Okay, and here what I'm going to do, I'm going to copy paste the same code, okay, from my previous file, and I'm going to paste it here. And the modification I will do here in this particular tool, okay, in this particular tool, this stock price tool. Okay, yeah, so here I'll do the modification. Why here I will do the modification? Because in this tool only I need the human approval. Okay, whenever user is asking to purchase a stock, right, that time here only I need to perform the interrupt operation. And whenever user is giving okay, you just need to purchase it, user is giving yes, yes command, that time this tool will execute, otherwise this tool will not execute. Okay, it will not purchase the stock for me. So for this I'll do a simple modification. See, instead of this function, I have modified with this function. Now just try to see. Okay, and most of the code, I think this is common to you because I already explained previously. Okay, in that simple demo, right? Here I'm using interrupt function, and here I just done a check statement here. Okay, now I have to import this interrupt function as and command function. So let's import it as well. I'll import it here from LangGraph types. I'm importing interrupt and command. Now I will go to my tool again. So this is the tool. Okay, yeah. So see here, I'm not adding this HITL inside my chat node. Okay, here I don't need to add inside my chat node because here I'm using a tool, lots of tool. Okay, and inside only get purchase stock price, in that tool only I need this HITL functionality. Okay, always remember whenever you are using tools and you are creating these kinds of advanced advanced agentic AI application, right, In chat node, you don't need to add it. You will be adding inside the tool. That means with the tool, you are performing some kinds of task. You are performing some kinds of action. And there, this HITL should be integrated. Okay, not in chat node. But in my previous example, the simple example I have given you, just to show you, I added the HITL in my chat node. Okay, I hope you clear. Now inside tools only, I will add this functionality. So this is the code for that. I'll close some of the window. Chat with HITL. Okay, now this is the tool, guys, I have written. This is the update I have done. So here, whenever it will use this tool, that means my agent will use this tool. That time it will see the interrupt function here, and it will pause the execution here. Okay, and user will able to see one message: approved buying. That means how much quantity user will provide. Let's say user is providing 10 stock. Okay, I want to purchase 10 stock of Apple. So this 10 will come here. So 10 shares of symbol means the company. Okay, that's I'm giving Apple. So Apple will come here. So do you want to purchase it? Yes or no? Okay, user will see this message. Okay, in interrupt only you can directly show the message. Then once user will pass this yes and no, it will store inside the decision. Okay, and right now I'm not storing inside as a dictionary, but previously the previous example I showed you, right, in the notebook, here I was storing as a dictionary. Okay, that's why I was checking the condition like that, because here I was passing as a dictionary. Okay, I was passing as a dictionary, but right now here I'm taking as a simple string. Okay, yes or no. So here I'm checking if this decision is a string and I'm doing the lower operation. If it is yes, then I'm returning the statement. Status should be success. Message purchased, order placed for quantity shares of symbol. Okay, symbol should be symbol and quantity should be quantity. That means here I'm giving a success message. Your order has been placed. Okay, or let's say you have successfully purchased the stock. Otherwise, if user is giving no, okay, in the else block you can see purchase of shares of the symbol was declined by the human. Okay, and status is cancelled right now. Okay, so these kinds of statement we have written inside our tool. Okay, and this thing you have to follow if you want to implement this HITL in any kinds of tool or any kinds of task you are implementing going forward. Okay, now I want to give you a task. Instead of purchase stock, maybe you can add another tool that will perform some kinds of sensitive and critical task. Okay, and in that task you just need to add this HITL functionality. Okay, this should be your task after this implementation. Just try to make this agentic chatbot more advanced. You can add some more advanced task which needs human approval, and you can add this functionality here. Okay, now this is the update I have done. Now the next update you have to do, next update, if I go below, already this tool is added inside the tool. I don't need to add. Now your chat node will also remain same. No need to add anything. Only this CLI code you have to change. Okay, right now user is giving the interruption message. That means the command. So this thing you have to add, take from the user. So here, this is the CLI code I have written. Because this CLI doesn't have any HITL input, right? Now this has the HITL input. So again, the same loop I have written: print statement, demo thread, while loop. I'm taking the user input. If user is giving exit and quiet, I'm like just breaking the loop. Then I'm preparing my state, okay, with the help of user input. Then I'm invoking my workflow, okay, and I'm passing my thread. Now we'll check this interrupt. Let's say whenever you are invoking the workflow and user is given, let's say, hello, that time just let me know whether this interrupt will happen or not. Definitely there won't be any kinds of interrupt. When interrupt will happen, whenever you will ask purchase 10 stock, or let's say purchase any stock of any company, right? That time that tool would be executed. That means our purchase tool would be executed, and whenever that tool will be executed, that time this interruption, okay, you will get the interruption. That means you will get something in the interruption variable. Okay, otherwise you will not get anything in the interruption variable. That's why we're checking if interruption variable has something. That means if interruption happens, definitely some message you will get, okay, in the interrupt variable. If you got the message, that time you will feel like, okay, there right now there is an interruption has happened inside my code. then you will ask the human. Okay, so what is the interruption? Okay, you will show this prompt. You can see I'm showing this prompt as a HITL message. Okay, whether he has to approved or approved or not. So this thing I will take inside my decision. I'm taking the input from the user, your decision. Okay, I'm just making it as lower. Then whatever decision user is giving, I'm again re-invoking my chatbot. Okay, and right now I'm giving the command, and we are giving this resume parameter is equal to our decision. Okay, which we are giving as a command. Then we are passing the configuration again, and whatever result we are getting, we are showing the message, and we are also printing in the terminal. So this is the simple code I have written. Now let me show you the execution. So again, I will open up my terminal, and right now I'll execute this chatbot with HITL. Now see, here I will give hello. Hello, how I can help you today. Now I will tell what is the stock of Apple, stock price of Apple. Now see, this is the stock price of the Apple, as you can see. Now I'll tell purchase, okay, 20 stock of Apple. Okay, purchase 20 stock of Apple. Now it will use that purchase tool, right? And there would be interruption. That will basically happen the interruption. That means HITL will apply in that particular tool, and it will ask for the human input. See, now HITL has been triggered, and it is asking for the human input. Approve buying 20 shares of Apple. Do you want to approve? Yes or no? So here I will tell yes, I want to purchase it. Now if I execute this code, you'll see that I have successfully purchased an order to purchase 20 shares of Apple. That means this tool has been executed, and this tool has purchased the shares for you, okay, of the Apple. Now again, if I let's say re-execute this code, let's say purchase, let's say purchase 20 stock of Google. Now again, it is asking for the human approval. Approve buying 20 shares of Google, yes or no. Now if I let's say give no, now it will decline. Okay, declined. So you can see, I'm sorry, your request was purchase 20 shares of Google was declined because you given no. Okay, right now just tell me which one is better. Okay, for this kinds of sensitive task, this kinds of critical task, without HITL or with HITL. Definitely with HITL, it is more accurate and more secured. Okay, secured version of our agentic chatbot. Okay, now guys, I think you have got it, how to integrate this HITL inside our agentic chatbot. Okay, now guys, let's try to add this functionality inside our user interface. So what I have done, guys, I just copy pasted the same code. Okay, I just copy pasted the same code, and I given to the chat GPT, and I asked, I just need to add this HITL functionality on my user interface, and ChatGPT has given me one updated code. Let me show you. Only you just need to update inside your front end. So maybe I'll create a separate file of the front end. Let's say I'll tell it as app underscore HITL. Okay, .py. And this is the updated code I got from the ChatGPT, guys. Again, if you don't know about the front end design, no need to worry. There are some front end developer in your would be in your company, so they will handle this kinds of scenario. Okay, but again, if you don't know, you can take the help from ChatGPT, and this is the updated version of our front end. Okay, this has the HITL, that means approval user interface. Okay, that means the first time I showed you a demo, right? It was asking for a human approval, yes or no button. So it has added that particular functionality here. Okay. Otherwise, my backend code will remain same. There won't be any kinds of change. So what I will do, again, I'll create another file here. Let's say, I'll copy the name, and I'll create a new file. I'm going to name it as Agentic Chatbot HITL backend. HITL backend. Okay. Backend.py. Sorry. Backend.py. Okay, and whatever code I have written inside chatbot with HITL, I'll just try to copy paste as it is. Okay, so from here, I just need to copy chatbot with HITL. I'll just try to copy the same code and I'll paste inside my agentic chatbot HITL backend.py. Okay, and no need to change anything. Only you just need to remove this line. Okay, this CLI is not required. I'll just remove that code and everything will remain as it is. Now, here in this app HITL, you just need to change this import. Okay, so now the import is agentic chatbot HITL backend. So agentic chatbot HITL backend. Okay, so from here we are importing all the functionality and this is the updated code. Now let me execute and show you this execution. So here I'll stop the execution, clear, and I will run streamlit run app HITL. Okay, now this is your interface. Okay, the same interface I think you saw. Now here you can perform any kinds of chat operation. Tell me the latest news uh, in AI. You will see that it will use some kinds of search tool. So see, it is using Tably search tool and it will give you the latest news in AI. You can see this is the latest news I got, and this is the news of Anthropics. Okay, latest news. Now here I will ask, I will try to check my HITL code, HITL functionality. So here I will tell what is the latest, or let's say what is the stock price of Apple. It is using my get stock price and it is giving you the latest stock price of Apple. Now I'll tell purchase, let's say 20 stock of Apple. Now we'll see that it will ask for the human verification. Now see, human approval is required and this is the user interface we have added with the help of ChatGPT. Now if I approve this purchase, now you see it will use purchase tool and it will purchase that shares for me. You can see your order to purchase 20 shares of Apple has been placed successfully. Okay, now if I let's say give another one, purchase 20 stock of let's say Google. Now again it will ask for the human verification. Okay, now if I reject this purchase, now see it will tell your request to purchase 20 shares of Google was declined. Okay, so that's how this system is working right now, and we have successfully added this HITL functionality inside our agentic chatbot. And you can also see the live tracing on the LangSmith platform. You can go to the threads and you can open up your threads and you can see all of the execution. Okay, now you can see guys, it hit your HITL functionality. This is also available here. Okay, you can see that. So guys, our agentic chatbot is ready and we have added all of the functionality. Okay, we have discussed previously in my introduction video, in my theoretical video. Okay, I think remember, if you are following this playlist from the beginning, I think you know that we have already explained about all of the core component of agentic application. We have added all of these core component inside our agentic application, and now this is like more advanced. Now the only part is left, the deployment part. In my next video guys, I'm going to show you how we can deploy this agentic chatbot, okay, over the cloud platform. And I'm not going to show you the simple deployment, I'm going to show you the CI/CD deployment. Okay, that means continuous integration and continuous delivery. So there I will try to set up the entire CI/CD pipeline and we'll try to deploy this project over the AWS cloud. Okay, I'm going to show you another deployment on the Render cloud. Render is another cloud and there you can also do the deployment. First of all, I'm going to show the AWS deployment, then I'm going to show the Render deployment as well. Okay, that means right now this bot is running on my local host. This agentic chatbot is running on my local host and it cannot access by any kinds of people, right? You can only execute this bot, but let's say if you want to make it live, right? If you want to make it live to the entire world, that time you have to deploy this application. So this deployment part I'm going to show you in my next video guys. So yes guys, this is all about, and I hope you liked my content guys. If you like my content, please try to subscribe to my channel and hit the like, and please try to comment in the comment section if you have any question. In this video, I'm going to show you the final deployment of that Agentic Chatbot.
So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time. Then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application. Then you will be uploading your updated code. Then this code will reflect to the endpoint. Then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application, yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CI/CD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CI/CD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CI/CD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually three famous tool actually we are having in the market right now. So people are using more this GitHub Action because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay. So here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can, let's say, use Jenkins, Circle CI. These are the services as well. Fine. So yes, guys, this is the complete high-level architecture of our deployment.
So guys, here you can see this is our application code, and we have written actually so many files, but if you see the final files here, which is this app HITL and this agentic chatbot HITL backend, okay, because this was our last update we have done, right? So instead of like deploying all of these file, guys, what I'm going to do, I'm only going to copy the final file, okay, the final code, and I'm going to create a new folder, and inside that I'm going to keep these are the code, okay. Just to explain you all the concept, guys, I have kept all of my previous code, and this is not required actually to run my final project. So my final project is right now this app HITL. Let me show you. So let's say if I execute this one, Streamlit, run app HITL, okay, .py. Now we'll see that my agentic chatbot application will be opening. So guys, as you can see, this is our application we have implemented so far. So here what I'm going to do, instead of moving all of this file, I'm only going to take my final file, which is this frontend app HITL, and my backend, which is agentic chatbot HITL backend. Okay. Apart from that, I need this requirement.txt file. Yeah, so I think if I have these are the file, then I'll be able to run my final application. And I also need this .env file because inside that you have all of the credential. So what I can do, I can maybe create a new folder here, and let's create this folder, or I'll just create a GitHub repository, okay? Because here we have to do the CI/CD deployment, and for this, first of all, you have to create a GitHub repo, and you have to push all of your code, okay, in that particular repository. So what I'm going to do, guys, I'm going to open up my GitHub. So here, what I'm going to do, I'm going to create a new repository. Let's name it as Agentic Chatbot. Okay, Agentic Chatbot using LangGraph. LangGraph. Okay. Now, what I'm going to do, I'm going to simply add a README file. Then I'm going to take this git ignore. Here I'm using Python programming. Let's select the Python. You can also take any kinds of license. Let's take this Apache license. You can also take any other license, is completely fine. Now let's create the repository. Okay, once a repo is created, click on this code and copy this link address and open up your local folder. Inside that, open up your terminal. Okay, you can also open up your git bash. It's completely fine. Now here simply write git clone and paste your URL you have copied from the GitHub and clone this repository here. Okay, now you can see I have successfully cloned this repository. So now what I'm going to do, I'm going to simply redirect this folder. So cd agentic chatbot using LangGraph. Okay, now I'm inside this particular folder. If I show you, see, I'm inside this particular folder right now. Now here I have to move my code file, okay, my final code file. So what is my final code file? I'll take this app HITL, then this agentic chatbot HITL backend, as well as this .env file, and I need this requirement.txt. Okay, yeah, I think these are the file I need only. Now I'll copy this and I'll try to paste inside this new folder I have created. Okay, now if I open up with my Visual Code Studio, let me open up. So this is my, okay, this is my old code. Now I'll try to open it with my Visual Code Studio. Yeah, so you can see, guys, this is my final code. Okay, I have copied from my previous code. Yeah, this is my final version of the code. Now, what I can do, I can maybe rename these are the file. Instead of keeping this file name like that, I can rename it. So first of all, let's try to change this backend file name. So here, let's rename it. So here I'm only going to name this file as backend.py. Okay, backend.py. And this app HITL, I'm going to name it as only app.py. Okay, app.py. Now make sure whenever you have renamed this file, you also need to change the import. Okay, so it has automatically changed because I'm using one extension. That extension automatically will uh, like trigger whenever I'm changing any kinds of file name. It will automatically change that import in my other file as well. Now you can see I'm importing all everything, and it's coming one warning because I have to select my original environment, which is LangGraph test. Okay, this environment. Now I think everything is fine. Okay, now here what I have to do, guys, I have to uh, um, let me check again. So everything is fine. Let me show you whether it's working or not. So what I can do, I can stop my previous execution and let's open up my new terminal. Now I'll execute this app. So conda env list. So this is the name of the environment. I'll copy and I'll just write conda activate my environment. Now after that, let's execute my app.py. So streamlit run app.py. Now see, this is the application. Now let's test this application. See, right now you can't see any of my old threads because completely right now I have copied my chatbot in a new actually folder. Okay, and right now all of the execution will be happening from the beginning. So let me test this chatbot whether it's working or not. So here I'll pass hello. See, it's working. Okay, hello, I can help you today. That means everything is fine. That means this is our final code we can utilize right now for the deployment. Now guys, let me write all the deployment step actually we'll be following for the CI/CD deployment. Let me write here. This is the entire step. Okay, you can see this is this entire step I have already prepared for this deployment. So let me open the preview. Yeah, now you can see here. So see, this is a Streamlit app, and we have to deploy the Streamlit app over the AWS cloud as a CI/CD. And for CI/CD tool wise, we'll be using GitHub Actions. Okay, and GitHub Action is already actually, let's say, built-in CI/CD like tool. You don't need to set up this GitHub Action server separately. This is already running on the GitHub. Okay, you just need to actually configure that GitHub Actions by adding some commands. Okay, by adding some commands inside a file. We call it as a cicd.yaml file. This file I'm also going to show you how you can write that. But as you can see, this is the deployment step we'll be following. First of all, we'll try to build the Docker image of our source code. Okay, we'll try to Dockerize entire of our source code. Then we'll try to push this Docker image to the Docker hub. Okay, then I'm going to launch a EC2 machine on AWS server. Then I'm going to pull my Docker image, okay, from the Docker hub to EC2. Then I'm going to launch my image. That means I'm going to execute my application as a Docker container inside EC2 machine. Okay, then I'll do some port mapping. Then you'll be able to access your application, okay, from the remote URL. Now for this, Docker knowledge is definitely required, and I am expecting you are already familiar with Docker. But if you don't know about Docker and all, so don't worry, I have a complete let's say tutorial on my channel. As you can see, I have a complete video, ultimate MLOps full course in a one video. So this is around 11 almost 12 hours of recording, and this course covers everything about the MLOps. I have already covered Linux. Okay, then some other tools as well, you can see in the description section. See, lots of like MLOps tools I have covered, And here we'll be seeing one section. I think from this hour itself, you can start watching uh, Docker concept. Okay, you can see the Docker concept I have also covered in this particular course itself. Now, if you are completely new to the Docker and if you want to learn the Docker, okay, how Docker works and why Docker is required, I'm going to suggest you go through this recording. I'm going to add this video in my description. From there, you can check it out. Okay, you don't need to watch from the beginning. Maybe you can only complete the Docker part at least, so that you can see the deployment part. Okay, you can understand like how Docker is helping for this CI/CD deployment and all. Okay, so yeah, this is the requirement. Then here I have added this step. First of all, we have to log in to the AWS console. Then we'll be creating the IAM user. Okay, then after creating the IAM user, we'll try to set the policy. Then we'll try to create the EC2 machine. Okay, we'll be taking Ubuntu instance. After that, we'll try to open the EC2 instance and we'll try to set up Docker there. Okay, because by default in the EC2 there won't be any kinds of Docker. You have to set up it. Once the setup is complete, then you will be able to set the port. Okay, that means by default Streamlit runs on port number 8501. Okay, so we'll try to do the port mapping. Then we'll try to set up our entire project as a self-hosted runner. That means we'll try to connect our AWS with our GitHub. That means once, let's say, we'll try to push something in the GitHub, automatically my CI/CD pipeline will trigger and all of the new changes will be available over my AWS. Okay, that means automatically my deployment will be happening. So this kinds of pipeline we have to create by creating this self-hosted runner. Okay, I'm going to also show you how to create that. Then once everything is complete, then I'll try to like set up all of my secret. Okay, so you can see if you want to run this project, you need, these are the secret. Apart from that, some additional secret is also required, like registry, Docker username, Docker password, okay, image name, AWS access key ID, AWS secret key, secret access key, okay, AWS region. So these are the thing additionally you need, because if you want to authenticate with AWS account programmatically, you need, these are the credential. Okay, we'll try to create this credential as well. I'm going to show you okay how to do that. And I am going to push my Docker image to the Docker Hub. For this, Docker credential is also required, and you should have also account in the Docker Hub. And after that, whatever credential I'm having, I think you already know that these are the credential I need to execute my entire agents. Okay, like if you're using OpenAI model, you can set the OpenAI API key, Tabby API key, open weather, Google. Okay, if you're using Gemini, you can set the Google API key, LangSmith endpoint, LangSmith API, then LangSmith project. Okay, so yeah, this is the step guys we'll be following for deployment. Okay, for this CI/CD deployment. Now, first of all, guys, here I'm going to create a Docker file. So let's create a Docker file here. So to Dockerize your entire application, you need this Docker file. Okay, and inside this Docker file, you have to write some Docker related command. Now, what are the command you have to write? So this is the command, guys. And this thing you will be able to understand from that particular video I suggested you, because in that video I have covered like what is this beige image, okay, what is this environment, what is this working directory, okay, each and everything I have explained there. If you are completely new to the Docker, first of all, try to complete that recording. I think that would be easy for you. Okay, but if you're already familiar with Docker, I think you know that these are the command we need to create the Docker image. That means to containerize entire our application, right? So yeah, we are setting this command inside the Docker file, and here you can see we have to install the requirement.txt. Okay, we are also installing in this particular command, and I have already commented out. See, this part you need to prevent Python cache file and enable immediate container logs. Okay, then this code you need to build the essential supports package that required compilations. Then lib gomp1 is commonly required by Fire CPU. That means here I am using Fire CPU for the vector database, right? That's why this library you also need to install, okay, whenever you are upgrading this machine. Then you need this requirement.txt. It has to copy in the root folder. Then you can see we will be installing this requirement.txt, and this is the command we are writing. Then we are copying all of our source code inside the root directory. Then we're exposing the port, and by default Streamlit runs on port number 8501. We're exposing the port, and this is the final command to launch the Streamlit server. Okay, so yeah, this is the Docker file, and with this Docker file you need another file which is .docker ignore. Okay, so inside this docker ignore, you have to write some of the unnecessary files and folder which you don't need to integrate inside your Docker image. Let's say if you have your virtual environment, okay, in this particular folder itself that you don't need, okay, whenever you are creating the Docker file, right? So that time you can ignore this one. So that means whatever file and folder you will be keeping inside .docker ignore, it will ignore during building the Docker image, okay, like this git ignore. And you know git ignore what it does, it ignores the files and folder whatever you will be adding inside this git ignore, okay, so that it won't be pushing inside our GitHub repositories. Okay, so these are the things actually I don't need inside my Docker image, so that's why I'm ignoring inside Docker ignore. So once it is done, then I'll try to add this cicd.yaml file for the GitHub Actions CI/CD deployment. So for this, you have to create a folder. The folder name should be .github. Okay, so this is the folder name we usually use, and this folder name you don't need to change. If you are changing, it will not work. So by default, if you're using this GitHub Actions for the CI/CD deployment, you have to create this .github folder. Inside that, you will be creating another folder called workflows. Okay, workflows. Make sure you are using the same name, otherwise it will not work. Okay, workflows. And inside this workflows, you will be creating a file called cicd.yml. YAML, okay, YAML. Okay, this is a YAML file. Inside that, you have to mention all of the command you need for the CI/CD deployment. Okay, now just verify whether everything is fine or not. Inside .github workflows and cicd.yaml file is available. Okay, now guys, what I'm going to do, I'm going to maybe close this file. This is not required. Yeah, I'm going to open up my new code. Yeah. Now what I'm going to do, guys, I'm going to add all of these CI/CD related command, and these are the CI/CD related command you will be getting in the internet itself. Okay, you can simply search I want to perform CI/CD deployment, okay, on AWS, and I have a Streamlit application for that. I need this cicd.yaml file. So you will be able to see this YAML file is available, okay, over the internet. You don't need to memorize it. You will be getting this thing in the internet only. And if you have the ChatGPT Gemini, simply you can open the ChatGPT and Gemini. You can ask, okay, I need a cicd.yaml file commands. I have to do this deployment, okay, Streamlit app on the AWS as a CI/CD. So I have already prepared the cicd.yaml command. So let me show you. So this is the command, and most of the command you can see this is a Linux command. If you are completely new to the Linux command, so again, in my MLOps course, okay, on my YouTube channel, I already covered the Linux, okay, Linux related command. You can see Linux is also covered, okay. You can go through the Linux video as well to understand how this command works, okay. So yes, this is the structured command you need to execute whenever you want to perform CI/CD with the help of GitHub Actions. So first of all, you have to define a name of your application. So here I have given Streamlit AWS CI/CD. You can change the name anytime. Then on push, okay, that means if you are pushing on the main branch, that means right now I have the GitHub, right? This is the GitHub, and here I am using main branch. That means whatever push I'm going to do on my main branch, this pipeline will trigger, okay. Only it will ignore if you are changing the README file, because README is not a feature. Okay, README is kinds of file. There I just try to write some metadata for my project, right? So if I'm changing anything in my README, that time our CI/CD pipeline should not be triggered. That's why path ignore, we are writing README file. Otherwise, if you're changing in any file, this pipeline will start. Okay, this CI/CD pipeline will start and your deployment will be happening. Then we are giving some other parameter as well, like workflow dispatch, concurrency, okay, permissions. We are giving each and everything. And this is already, predefined actually workflows you have to write if you're using this GitHub Actions for the CI/CD deployment. Okay, this is not our code. So CI/CD with GitHub Actions documentation, if you check, so they have written these are the commands should be added inside your cicd.yaml. Now here the main thing is the jobs. So here first of all continuous integration will be happening. Inside continuous integration we are just only echoing the command. Okay, we are taking a Ubuntu instance and we are only echoing the command. Then the second step, we are building and pushing the image to the Docker Hub. So here first of all we are verifying with the Docker Hub account. So make sure you have the Docker Hub account. So if you don't have, you can create. So simply search for Docker Hub. Okay, Docker Hub, go to the first website and make sure you have an account here. Okay, I already have the account, that's why it got login. Okay, but if you don't have account, guys, please try to create an account. So let's say I will sign out. So here you can sign up. Okay, sign up, you can fill your information. After filling, you will be able to create the account. So I already have the account. I'll just try to sign in. So this is my email and password. I'm going to sign in with my Docker Hub. Okay, and this is how your Docker Hub will look like. Okay, previously I already pushed some of the image, that's why it's available, but for you it would be completely empty. Okay, so Docker Hub is a service that you can store all of your Docker image. Okay, you are creating. You can also use AWS ECR service, but this is fine. I can use Docker Hub also. It's completely fine. Okay, in AWS also, to store your Docker image, there is a service called AWS ECR, Elastic Container Registry. Okay, you can also use this one. But I'm going to use Docker Hub for this particular project. Maybe in future, I'm also going to show you that Elastic Container Registry, how to use that. Because I want to minimize my cloud costs. That's why I'm using, these are the free to use actually hub, okay, to push my image. And yeah, so here you can see we are authenticating with the Docker Hub, and after that we are building the image. Okay, we are building our Docker image. Then after building, we are pushing this image to the Docker Hub. Then once my second step done, then it will start the third step. There you will try to deploy your image to AWS EC2 instance. Okay, as a self-hosted runner. For this is the command. So it will again authenticate with your Docker Hub, and it will take that image and it will run on your EC2 instance. Okay, and to run your app, you need some credential. I think you remember, you need Google API key, Tablet API key, Open Weather API. Okay, so whatever, let's say, API you have used, right? You have to write all of the API here. You can see where is that? Yeah, but you are not going to directly give the value. So this value you will be reading from the secret. Okay, we call it as a GitHub secret. I'm also going to show you how to add this secret, but make sure whatever API key you are using, you have to write here. Okay, and here we are checking all of the API keys are available or not. If not available, we are just launching a message cause secret is missing. Okay, then this is the code, and finally we are running our Docker image, and it is starting the server. Okay, and some other necessary command we are also running. Okay, everything will be running in that Docker video I have already given you. Okay, in my MLOps course. Now this is the CICD.yaml file, guys, you need for this deployment. Now everything is ready. Now let's try to create the server. Okay, server means I will follow this step. Okay, first of all, here what I'm going to do, I'm going to log in with my AWS console. So let's try to log in. I already logged in with my AWS console. Make sure you have the AWS account. If you don't have the account, guys, please try to create one account. I already logged in with my AWS console, and that's how your console looks like. Now here, the first thing you have to search for the IAM user. Okay, IAM user, that means Identity Access Management. Then I will go to the IAM user section, and here you have to create an user. Okay, let's create an user. So I'm going to name it as, let's say, Agentic. Okay, Agentic user. You can give any name, it's up to you. Now I'll click on next. Then you have to add the policies. Okay, and which policies you have to add? So here I think I have already written. Yeah, so after login to the AWS console, we are creating the IAM user, and this is the policy you have to add. Okay, Amazon EC2 full access. So here, let me check again. Amazon EC2 full access. Okay, because you only need the EC2 instance. Okay, so I'll copy this, and here I'm going to search it here. Okay, so Amazon EC2 full access. I'll provide this access, and I'll click on next. Okay, see why we are giving this permission, because in my AWS account there are lots of services we are having, right? And it's not like that I'm going to give all of the services access to my project, to my code. Instead of that, I'm only going to give the access the service actually I'm using. Otherwise, there is a possibility it might use some other service and I will end up with lots of cost, right? But I don't need that. So that's why I am only giving the access the services I'm using. So here I'll be using EC2 instance. EC2 is a virtual machine inside AWS. Okay. Once it is done, let's create the user. Okay, so some error is coming. The specific username is invalid, must contain. Okay, so I think the name we have given, this is not okay. There I have given a space, right? But it should not be having any kinds of space. So I'll give this hyphen sign. Now let's click on next. Now I'll provide this Amazon EC2 full access. Click on next. Now everything is fine. Create the user. Okay, so my user creation is done. Now I'll go inside the user, and there is an option called security credential. Just try to click here, And here you will see this one, access keys. Okay, now I'll click on this create access keys. Now select this command line interface CLI and just do the confirmation. Okay, once everything is done, now click on the next. Then I will click on this create access keys. Okay, now this is our access keys and secret access keys, guys. You need to authenticate with your AWS because I'm going to access my AWS account from my Python code, right? From my actually GitHub actions. That's why this credential is required. Okay, now you can download as a CSV file as well. Let's try to download this thing. I need later on. Now this service is creation done. Okay, now this is creation done. We have successfully created the IAM user and we have given the policy and we collected our access key and secret access key. Now the next step, you have to create the EC2 machine, Ubuntu machine. Okay, now let's do that. I will go to my home and here I will search for EC2 instance. Okay, let's open this EC2 instance. And EC2 instance is a virtual computer service, okay, inside AWS. Now I'll just try to click on launch instance, launch without a walkthrough. Okay, now you have to give a name. So I'll give Agentic, okay, Agentic Chatbot machine. Okay, you can give any name, it's up to you. And make sure you select this Ubuntu instance. Okay, there are some other instances are available like macOS, Windows, Red Hat, but I will take this Ubuntu instance because this is the most used instance whenever you are doing the production grade deployment. Now once it is done, you can select the instance type. That means how much memory, how much CPU you need. You can select the configuration here. So for this project, at least 4 GB RAM is required. Okay, and I'm going to take 2 vCPU. I think this T2 medium is fine for me. Okay, but if you are creating a heavy project that needs lots of computation, that time you can also take some bigger instance as well. Some bigger instance are also available like 32 GB memory, 16 GB memory. Okay, you can see everything is available. Now I'll take this T2 medium. Okay, this is fine for me. Now here you have to create a key value pair, key pair. Now you can give the name. I'll give Agentic. Let's create the key. And once it is created, you can select it from here. Okay, Agentic. This one. So this key you need whenever, let's say, you want to access your this EC2 machine from any third-party tools like Putty and Mobile Extreme. That time it is required, but for our case, we'll try to launch in the same Google Chrome only. Okay, there you can launch the terminal. Okay, your EC2 instance terminal. This is also possible. Now here you have to check mark these two options: allow HTTPS and allow HTTP traffic from the internet. And here you can take the storage. At least try to take 32 GB storage. And everything is fine. No need to change anything. Simply launch the instance. Okay, so I'll go below and click on view all instance. Now see, my instance has created and it is running. Okay, make sure it is running, otherwise you can keep on refreshing this page. Now simply I'll click on my instance ID and here you will get one option called this connect button. Okay, but before connect button, I think you remember what I told you. I told you to do the port mapping. As you can see, okay, port mapping I think we can also do later on, but you can do the port mapping right now if you want. So let's do the port mapping. Otherwise we'll do it later on. Okay, so simply I'm going to connect my instance. Okay, so there is a connect button. Just try to click on the connect button and make sure you select everything as default. If you want to connect this let's say EC2 instance from any third-party tool, that time you can use HSS client and you can use Mobile Extreme, Putty. These are the tools to connect. Okay, but I'm going to connect from my same AWS CLI only. I'm going to simply click on connect. Now see, in a different tab, it will open up your this EC2 instance terminal. Okay, this will be your Linux terminal, and there you have to execute all the command to set up your entire server. Okay, now see, this is the Linux server we are getting, guys. That's clear. And for this, you need some idea about Linux command, Ubuntu operating system, and this thing I have already covered in my ultimate MLOps full course. Okay, there I have already covered about the Linux. You can study about that. Okay, for the deployment, guys, you need a little bit of understanding MLOps. If you know about MLOps, it would be easy for you to do the deployment. Now, guys, what I'm going to do, I'm going to set up all of the package I need here. So for this, I mentioned all of the command, as you can see. First of all, you have to upgrade your machine. So for this, just copy this command and execute it here. Right click and paste and execute. Then I'll copy the next one. See, you just need to copy this command one after one and just execute inside the terminal. Done. Now I'll paste this second command. So see, this is a completely newly created machine, and here you have to upgrade the package manager. Okay, so we are upgrading, and for this we are using sudo apt-get upgrade this command. Now I'll give yes permission and upgrade this machine. And that's how your production server looks like. Okay, that's why you may be heard of, in production you need to know about Linux. Okay, because every production server they're using Linux, especially the Ubuntu instance. Okay, they're using. Now this is also done. I will clear the terminal. Now let me see the next command. Next command, you have this you have to install this Docker. Okay, now to install the Docker, this is the command. First of all, let's download the Docker. There is a HS file you have to download. Then after that, we'll try to install. I'll copy this command one by one. Paste the next command. And this is the last command you have to execute. Now see, Docker successfully got installed inside our Linux instance. You can check it. For this, you can run this command docker -- version. So you'll see that Docker is running right now. Okay, but previously Docker was missing. Okay, I can maybe close my localhost execution. Let's close it. Terminal is also running. I'll stop it. So fine, we have successfully installed Docker. Now the next step, I have to configure my EC2 as a self-hosted runner. For this, just open up your GitHub and go to the settings. Okay, make sure you are using your GitHub. Okay, not my GitHub. Go to the settings, and left hand side you will see one option called actions. Now go to the runner. Okay, here just try to select this new self-hosted runner, and you will see this Linux operating system. Just try to select that, and these are the command you have to execute inside your EC2 instance. I'll copy the first command and execute in the terminal. Then I'll copy the second command. I'll execute in my terminal. I'll copy the third command and let's execute it here. That means you are connecting your AWS with your GitHub. Okay, that means whatever change you will let's say push in your GitHub, automatically this will be like, let's say, available inside your AWS. Then I'll copy the last command and execute. Okay, so two more command you have to execute. So inside configure, this command. Now see, GitHub action is getting initialized and it is already connected with my GitHub. Now here it is asking for the internal name of the runner group. I don't need to give any runner group name. I'll simply press enter. Then it is telling enter the name of the runner. So here make sure you give the same name, self-hosted. Okay, that means in this YAML file, I think you remember, here you have given this name. Okay, continuous deployment, you have given runs on self-hosted. You have to give the same name here, self-hosted. Okay, so make sure you are giving the same name, otherwise it will not work. Now I'll press enter. Now it is asking there would be any following labels. I don't need any label. I'll skip it. Press enter. Then it is telling enter the name of the working folder. I'm going to again press enter. Okay, now it's done. Now simply you have to copy this last command and you have to execute, and you will be able to see that your AWS will be connected to your GitHub. See, connected to the GitHub and listening for the jobs. Now you can test it here. So simply you can again click on the runners. Now see your self-hosted runner, it is already idle. That means your AWS is connected with your GitHub and it is listening for the jobs. Now, right now, if you push anything in your let's say repository, right? If you push any code, automatically it will get deployed over the AWS cloud. Okay, how? Because you have written this YAML file, and inside this YAML file, all the commands are available for the deployment operations. Okay, but one more thing I have to do, which is this secret credential I have to add. Without this secret, it will not work. Okay, so definitely this secret needs to be added. So let's add the secret. Now, if you see the last step is that you have to add the secret key in the GitHub actions. Okay, so let's do that. I'll go to the GitHub again, go to the settings. Left hand side, you will see one option called secret and variable, and go to this action section. Okay. Now here you have to create a new repository secret. So first of all, you have to create this registry. Registry should be docker.io because we are using Docker Hub. So make sure this is the key name and this is the value name. Okay, inside secret, you have to give the value and add the secret. Okay, done. You can see we have added this secret. Now I'll create another one, new repository secret, and I'll do it for the next one. I'll add my Docker username. So what is my Docker username? If you go to my Docker hub, so this is my hub. If you just click on my account here, you will be able to see the username. Okay, so make sure you check your username in your Docker hub and copy the same name and give it here. Now the next thing, I have to add the Docker password. That means Docker hub password. So make sure you are giving your Docker hub password. Okay, so let me give my password, guys. So this is like secret password. I don't want to show you, so that's why I'm going to pause the video. After adding the password, I'm going to show you the next step. So yeah, guys, I have successfully set my Docker password. Okay, so that's how you have to add all of the secret inside this secret variable. Now let's try to add the next one, the image name. So image name, I'm going to, let's say, give the same name like Agentic Chatbot. So with this name, actually your Docker image would be created. Okay, you can also change this name as per your requirement. I have given Agentic Chatbot. Now let's add the secret. Now next I have this AWS access key ID. Now why you will get this AWS access key ID? I think remember we downloaded one CSV file. Okay, this CSV file, let's open it up. I'll open in my Notepad++. So this is the secret and secret access key. So first of all, let's copy this access key ID. So before this comma, this is your access key ID. Okay, I'll copy and paste it here. And make sure you don't share this credential with anyone, otherwise they will be able to access your account. Okay, I'm going to remove after this recording. Don't use my one. Okay, try to use your one. Now AWS access key is done. Now next I'm going to add AWS secret access key. Secret access key. Okay, now where you'll get the secret access key? So this part is your secret access key. Okay, that means after this comma, whatever you have, this is your secret access key. Let's copy and paste it here. Done. Now next you have the AWS region. So right now I'm inside, you will see that I'm inside US East 1 region, North Virginia, US East 1. Okay, if you're in other region, you can give this name. Okay, but right now I'm inside US East 1. I will give the same name here. What is that? Yeah, let's copy. So all the command I have given in my readme file, you can check from there, guys. Done. Now next I have to add the OpenAI API key. If you're using OpenAI API key, guys, you have to add the OpenAI API key. Okay, and make sure you add your value here. So I'm using Google Gemini model because I don't have OpenAI API key. So that's why I'm not going to pass my OpenAI API key, but I just showed you, okay, how to add your OpenAI API key. So make sure you pass your OpenAI API key here. Okay. Now here I'm using Google API key. That means I'm using Gemini model. I'll be using my Google API key instead of OpenAI. You can also remove this part if you are not using OpenAI. But I have showed you, if you're using OpenAI, you can add this. Now I'm going to add the Tably API key. Tably. And what is your Tably API key? It is available inside your environment variable. So this is your Tably API key. Let's copy and give it here. Then next you have this open weather API key. Let's copy my open weather API key from this in env. Okay, now next I have to add, after open weather, Google API key. So here I have my Google API key. Now next you have this LangSmith tracing, because we're also using LangSmith for monitoring our entire application, right? To trace all of the execution. And this secret would be true. You can also verify from your environment. So tracing should be true, okay? And don't give any quotation, okay? Quotation you don't need to give. Now next I have this LangSmith endpoint. This is the endpoint. Now next I have this LangSmith API key. And here is your LangSmith API key. Done. Now next you have this LangSmith project name. Okay, that's how whatever API key you are using, you have to add inside the secret. Okay, that's how you have to prepare the secret variable. So what is the name? Agentic AI project. Agentic Chatbot project. This is the name I think I was using. Even you can also open up your LangSmith platform. You can verify. Yeah, so Agentic Chatbot project. Okay, if you want to create a new one, you can also create, and it's completely fine. But here I'm tracing all of my execution. All right, so all of the secret I have added, guys. Let me check if I'm having anything else. No, I think everything is added. Okay, now see, all of the secret we have added. So right now this secret is not visible to the public. Okay, so this is available inside my account, inside my secret. Okay, and my application will pick up from this particular secret only. That's why everywhere I've given secret dot your API name, or let's say key name. Okay, so that's how you don't need to expose your API key, or I mean to the audience. Just try to make sure you are adding inside the secret. Okay, this is super important. Now everything is done. Now we are ready for the deployment. So right now our server is connected, my GitHub is connected, my self-hosted runner is running, everything is done. Now simply I'm going to push the changes. Okay, now let's try to push the changes. I'll commit the changes. So here I'm going to open up my terminal. I'm going to write git add. So see, these are the file I'm going to push. Yeah, so everything is fine, but let's delete these are the file. This is actually created because I have executed this project, right? And it has created the persistence memory, but I want to delete it. Okay, I want to like push completely new project, okay, to the cloud. So I'll delete these are the file. So everything is fine. Now let me push the changes. So I'll open up my terminal. I'll just write git add space dot, then git commit hyphen m. I'll give, let's say, updated Now I'll just write git push origin main. Now push is done. Now if I go to my GitHub, okay, now see everything is updated in my GitHub and your workflows is running. Okay, you can go to the action and you can see your first commit is running. This is your first attempt to the CI/CD deployment. Okay, and this is a one-time setup, guys. This setup you have to do one time, and going forward you don't need to do this setup. Okay, going forward you will only just try to change your upgrade and automatically it will be getting deployed. Now see, three-step it is running: continuous integration, building and pushing image, push Docker image and deploying to the AWS EC2. So continuous integration is already completed. Now building and pushing image is running. Okay, so right now my image is getting builded. Okay, you can see it is setuping everything, all the package and everything. So this process may take some time. Let's wait. Now see, requirement got installed successfully. After that, it will push the image to the Docker Hub. Now you can see in the Docker Hub, I don't have any kinds of image name with the help of Agentic Chatbot. Okay, now you'll see that after some times, this image would be available. Everything is happening automatically, guys. Okay, because I have set up the entire server, I have written that YAML file, and all of this command is available. So everything would be automatically. This is the beauty of CI/CD deployment. Only one time effort, okay, one time configuration, one time setup, and rest of the life you can enjoy. And that's how production deployment happens. Whatever application you can see, right, everything is connected with CI/CD pipeline, and that's how they're setuping the server. You can also use any other cloud like GCP, Azure. It's completely fine. The step will remain same. Maybe some functionality would be different, okay, in that cloud. Now see, build and push is complete. See the green tick mark, that means complete. Now deploying this image to the AWS EC2. Now it is pulling the image and it will run on my EC2 instance. Okay. See, all the three steps are complete. All the three steps are getting green tick mark. That means everything is fine. There is no error inside our workflow. Okay. We have successfully deployed. Now I will go to my instance and there you will see one option called public DNS. Okay. Just try to copy this URL and paste over the new tab. And if I execute, see, right now this application is not going to open because we haven't done the port mapping. Okay, port mapping is required because by default our application is running on port number 8501. Okay, so we have to do the port mapping. So to perform the port mapping, you can go back to your instance and there is an option called security. Just go to the security. There is an option called security groups. I'll click on security groups and here you will see one option called edit inbound rules. Okay, now here you can see your port number is not defined here. That means 8501 is not defined here. So just try to add the rules and port number you have to write 8501. Okay, this is the port of Streamlit. You can also verify in the cicd.yaml at the last whenever you are running your image, right? So there you said that yeah, see, you are doing the port mapping to 8501. This is the port. Okay, by default Streamlit application runs port 8501. Now you have to select this 00. Okay, that means you can access from anywhere and simply save these rules. Done. Now I'll go to this instance again, instance ID, and I'll copy this public DNS again. Okay, and make sure after this URL you are giving this clone port number 8501. Okay, 8501. Now if I execute, I'll see your application will be running. And this is completely live right now. Okay, now if I share this URL with anyone, they will be able to access my agent. See, this is running on the AWS server right now and this is completely live. Okay, now you can purchase any kinds of domain name. Okay, then you can change this name with your domain name, own domain name. This is also possible. Okay, But if you know till here, I think it's completely fine. The domain part, I think this will take care by the front-end developer. So right now our chatbot is running live. Okay, we can test whether it's working or not. So let's say I will give hello. See how I can help you today. Then I have given another message. I am Bappy. Now it is telling nice to meet you, Bappy. Now I'll tell me the current weather. Okay, in Dhaka. Now see, it is using my get weather tool, and it is giving you the current weather in Dhaka. Now I will ask uh, latest news in FIFA. Now see, it is using Tably search tool, and this is giving you the latest news on FIFA. Okay, so this is the latest news you're getting. Now you can ask any other thing. Let's say you can ask about the stock price. Tell me the stock price of Apple. Okay, this is the current stock price of Apple. Now you can also purchase any stock, so you can just write purchase. Let's say 20 stock of Apple. Okay, now again we have added this HITL features. That means human in the loop. It will ask for the human verification. Now see, asking for the human verification. Now if I approve, now my share would be purchased. Okay, now you can even upload any kinds of document. You can start the conversation. You can also create a new threads. This is also possible. Let's say I've created a new threads. Okay, now here I will ask upload any kinds of documents. Let's say I will upload my resume, and I will ask tell me about Boktir Ahmed Bappy based on the PDF uploaded. Now see, it is using RAG tool, and it is giving you about myself. Okay, based on the resume I'm having. Okay, so that means everything is working fine, and this is completely live right now. You can share this URL with your friends and family. They'll be able to use that. Okay, so amazing, guys. We have seen how to perform the deployment. Now the uh, good part I want to show you about the CI/CD deployment is that now let's see in future if you want to add any new change here. Okay, let's see if you want to add any new features. You don't need to manually, let's say, set up everything again in the cloud server. Okay, you don't need to manually copy paste your code and set up everything. Only you just need to change and upload inside your GitHub. Automatically this deployment will be happening. Let me show you. Let's say in this app.py, let's say right now, let me show you one like small features. Okay, I'll be adding here. Let's say I'll refresh my app. So right now you can see it is agentic chatbot with LangGraph. Okay, let's say I want to add an emoji here. Okay, let's say I want to add an emoji. So what I'm going to do, I'll go to that part there. I'm creating this title. I think here I'm creating the title right here. So let's say I'm going to add an emoji. So simply let's add an emoji. So let's say I'm going to add this this robotic emoji. Okay, so I'm going to add this robotic emoji. Refresh, and yeah, save it. And now we have to commit it again. Okay, you have to commit your change again. So let's commit our change again. So I'll just write git add space dot git commit hyphen m. Let's say I'll give new feature added. Okay, and git push origin main. Now push is done. Now again I will go to the GitHub, and I will see that your pipeline will automatically get triggered. Now see, again action is running. I'll go to the action. Now see, new feature added, this pipeline is running again. Okay, and this version is having a new update. Okay, again it will build the Docker image, push the Docker image to the Docker hub. So you can see in the Docker hub itself, you will see your application. That is your image. See, Agentic Chatbot. So right now it is having only one image. Okay, and it is uploading the next image here. So let's wait. See, again all of the execution is happening and you don't need to do anything. Okay, and still your server is live. See, if you refresh here, if you start the conversation, it will run. Okay, it will not actually shut down. Okay, but if you're not getting CI/CD pipeline, that time there is a possibility it will get shut down. Okay, and user will feel this application is not working, and then you may lose your user, right? So that's why CI/CD is required. In the backend, all of the deployment is happening, but you are not going to see anything, right? Now if I come here, say deployment is completed. Now if I come here, now if I refresh my application, now see that new update has added here. Now see, this emoji has been added here. Okay, so this is called actually CI/CD deployment, and that's how you can continuously add new features without shut down your application. Okay, without, let's say, stopping your application. And this is what actually we use inside the industry, inside the production deployment. Okay, I hope everything is clear, guys. So if you found this content useful, please try to subscribe to my channel and share this video with your friends and family, and please try to like on my video, guys. Okay, and if you have any question, please try to comment in the comment section. I would like to see your comment and I would like to see your opinion. Okay, whether this playlist is helpful or not, because I have covered each and everything. I have implemented the project. I showed you the end-to-end deployment, everything I showed you. Okay, and lots of things are coming as well. So guys, yeah, we have seen the deployment. Now we will see that how we can terminate all of the server, because if you keep on running it, it will charge you. So let's say once we have deployed everything, our learning is over. Now I'm going to show you how we can stop the server. Okay, let's see, if you want to stop the server, how to do that. So for this, okay, one more thing I want to show you. Let's say if I close this terminal, okay, if I close this terminal also, still my application will be working. Okay, so still my application is working. Okay, so now if you want to let's say delete this instance, first of all you have to select it. Then there is an option called instance state, and there you will see called terminate and delete instance. Okay, so if you do terminate and delete, it will delete everything. Okay, but if you stop it, it will stop. Again, you can restart it, but I'm going to delete everything because my learning is over. I'm going to terminate and delete. Now after some time it will be deleted. Okay, now you have to delete your IAM user as well. So let's go to the IAM user. Left hand side, IAM user is available. Select the IAM user and delete it from here. Deactivate the keys and just write confirm. So it will be deleted. Okay, if you want, you can also delete your Docker image you have uploaded in your hub. Okay, this is also possible. You can also delete here, but I'll keep this image, okay, in my Docker repository, so that later on I can use it anytime. Okay, so yes guys, that's how we can do the CI/CD deployment, and we have completed our deployment. Okay, so right now you can see our application will not run because I have deleted all the instance, and this is offline right now. So see, this is offline right now. Okay, so yeah, you can try. I will share all the resources, all the code in my description. From there you can try, and please try to support my channel, guys. If you support me, definitely I will bring this kinds of content more in future. So yes, this is all about for this deployment. I have showed you on the AWS cloud. Now in the next video, I'm going to show you how we can deploy this project over the Render cloud. Okay, Render is another cloud. There you can also deploy this project as a CI/CD. So what is Render? Render is a cloud platform. So there you can deploy any kinds of web application. Okay. This is the a very fastest and very easy to use cloud platform. So here you don't need to do so many configuration. Okay, with some few clicks actually you can do the deployment. I'm going to show you how to do that. And definitely for this you have to create an account on Render. And Render is not completely free, but they have a free instance. In that free instance you can at least deploy some application. Okay, but if you want to do the production grade deployment, okay, with some higher infrastructure and higher instance, that time you have to take the subscription. Okay, but I think this is fine as a learning purpose, and just to just to actually live our app, okay, just to test our app, we'll be using the free instance. So free instance is having like very low configuration like machine, and I think this is completely fine for us, so we can manage that. Okay, so if you found my content useful, guys, please try to subscribe to my channel, and please try to share, and please try to hit the like. I need your support. If you provide the support, guys, so I can bring this kinds of content more in future. So well, let's start with the deployment, guys. First of all, here you have to create an account. If you don't have account, guys, please try to create an account with your Google address. You can create your account. So I already have the account. I'll just try to sign in. So here I'll just try to sign in with my Google. So after sign in, guys, you will be able to see this kinds of interface. So this is the rendered dashboard, and previously I deployed some app, that's why it's coming okay like that, but for you it would be completely empty. So here what I have to do, guys, first of all I have to actually commit my code to the GitHub. Okay, and in my previous deployment video I already pushed this code in my GitHub. So this is already available in my GitHub repo. As you can see, this is the repository we created, Agentic Chatbot using LangGraph. So we can utilize that. And one best part is that if you're using render, so render, it is already having the CI/CD integrated. You don't need to set up the CI/CD separately, okay, like we did in on AWS, right? Here CI/CD it is included, okay. Only you just need to connect your repository, and automatically the CI/CD pipeline would be created. You don't need to manually create that. That part I'm going to show you. So first of all, here just try to copy this URL, okay. Copy your GitHub URL, and in on render you will see one option called new. Okay, just click on new, and here is a service called web service. Okay, just click on web service, and here you can see git provider is available. Okay, just try to paste your URL. Okay, or you can go to this public git repository, and you can provide the URL. Okay, and if you want, you can also pass your existing, let's say, Docker image. So I think you remember in my last video I like pushed my Docker image in my Docker hub. So you can also provide that image URL, that and with the help of that you can also perform the deployment. You can also use your GitHub to do the deployment. Okay, but make sure you have this Docker file here. So I already have the Docker file, and in my last video I already created this Docker file. So Docker file should be available. Okay, so we have the Docker file, it's completely fine. Now simply what I'm going to do, I'm going to just paste this URL here, and I'll just connect this repository. Okay, once you have connected, you can provide the name you want to provide for this deployment, but I will keep the same name. And the language, you have to select the Docker. Okay, if you don't have the Docker, you can also select the simple Python, but I have the Docker, I'll try to select the Docker. Okay, language, then everything will remain same as it is, no need to change anything. And here in the instance type, see, they have some plan. You can take the plan as per your requirement. If you have, let's say, a very high configuration project that needs lots of computation, that time you can take, these are the plan, but we'll be using this free plan for the hobby project. Okay, just to show you, I'm using this free plan, and it is having 512 MB RAM and 0.1 CPU core. Okay, it would be a little bit slow, lagging, but just to I mean make our project live, it's completely fine, because nowadays none of the cloud provides the free a free, let's say, instance, right, to do the deployment, but at least they are providing. I think this is fine for us, right? So I'll select this free instance. Then here you have to set all of your environment variable you have inside your project. So I think you remember, inside our project, these are the environment variable is required. So try to set one by one. So I'm not using OpenAI, so I will not set the OpenAI. I'll select set from Tably. So Tably API key, here you have to give the value. Okay, then the next one you have this open weather API key. That's how I'll try to add all of the environment variable I have here. You can also upload your .env file, that will also load, but let's try to add like that. Google API key, because I'm using Gemini model. Now, next I have this LangSmith tracing. LangSmith endpoint. Then LangSmith API key. Then we have LangSmith project. So yeah, all of the API key has set successfully. Now in the advanced part, you don't need to do anything. Just keep it same as it is. Now let's try to deploy our web service. Okay, now it will start building your Docker. Okay, all of the setup, everything will going on here. So we have to wait for some times. Okay, so this will set up and prepare everything, and once this starter should be live, you will be able to access your application. Now let's wait, guys. So what I'm going to do, I'm going to pause the video. Once this Docker building is complete, then I will come back. So as you can see, guys, our application is live right now, and all of the setup has complete successfully. Now we can access this application. So this is the URL. Just try to copy this URL and open in a new tab. So you'll be able to see that your application will open. Yeah, so it has loaded my application. So this is our agentic chatbot. Now let's test this chatbot. Let me zoom out so that you can see the entire screen. Yeah. So now let's test this chatbot. So here I will give hi. So see, it's giving you hello, I can assist you. Now I'll tell what is the current weather in Bengaluru. So this is the current weather in Bengaluru. Now I will ask, tell me the latest score of FIFA. Okay, today. Yeah, so this is the score it has given. Now you can check about this stock price. What is the stock price of Google? Okay, so the API I was using, so the rate limit has been over. Okay, so I have to create another API key. It's completely fine. Now let me test with my documents upload. So I'll just try to provide my resume and I'll ask who is Bakhtiar Ahmed Bappy based on the PDF uploaded. Now it is giving you the entire answer about me, right? So yeah, it's working perfectly. So only the issue we found, our API key we're using, right, for this stock price, this has been, I think, limit is over. So I have to create another API key and I have to set there because we are using the free one, right? And free one definitely has some limitation. It's completely fine. Yeah, so it's working fine. Then you can also create a new threads. Okay, you can create a new threads and you can again do the conversation. Let's say, hi, I am Alex. Okay, see, everything is working fine. Okay, now this application is completely live. You can share this with your friends and family. They will be able to access your application, and this will not charge you. Okay, because this is running completely on the free instance, and that's how you can deploy any kinds of project. Okay, just for the testing purpose. Okay, but if you want to do the production grade deployment, that time just try to make sure you are taking the subscription plan. Now guys, one best part I will show you, which is this CI/CD. Okay, that means if you are changing something inside your code and if you are again committing to the GitHub, so what will happen? So let's say right now, here I have an emoji. Okay, so I want to remove this emoji. As of now, just try to consider this is our features. Okay, we are adding inside this chatbot. Where is that part? Yeah, so here. So let's say I will delete this emoji. Okay, and I will again push my changes to the GitHub. So let's say app file updated. Now I'll push the changes. Done. Now if I go to my GitHub, see this commit is over. Okay, app file added. Now here if I come to this I mean render, and if I go to this event, so you have to go to this event, and there is an option called manual deploy. Just try to click here. Okay, and there is an option called deploy last commit. Okay, so you can also like make it as automated. There is a setting you can turn on that. But if you just click here deploy latest commit, now if I let's say deploy latest commit, so you'll see that automatically my new features would be added. See, still my application is running. See, still my application is running and my deployment is going on. Okay, so that's how they have integrated this inbuilt CI/CD and all of this. Okay, whatever we have learned in my previous deployment. So here you don't need that much of configuration. Only few clicks you can do the deployment. Okay, so this is the best part on this render cloud. Let's see. So see, our application is live now. If I go to my application refresh, so see this emoji got removed. Okay, so that's how we can add our new features, and you just need to commit the code on GitHub and you can just trigger that pipeline. Okay, and you can also make it as automated. There is a settings you can turn on. So yes guys, that's how we can do the deployment. Now I'll show you how we can delete the instance. Okay, let's say this project I have deployed. Now how I can delete this instance. Okay, so for this you just need to go to the settings and go below. There is an option called delete web service, and you have to copy this command and give it here and delete the web service. Okay, so if you delete it, so this service would be deleted and your application would be offline. Okay, so yeah, that's how we can do that. So if you found my content useful guys, please try to support me. And this is my LinkedIn profile. If you want to connect me guys, you can connect on my LinkedIn. You can follow me on LinkedIn, and please let me know how you are enjoying this complete list. If you found this useful, so please try to tag me on LinkedIn. Okay, I'll happy to see that, and just try to implement something from your end, and please try to tag me. So if you are tagging me on LinkedIn, I would be happy to see your work, and definitely I will put my feedback and comments. Okay, so yes guys, this is all about from this video. I hope you liked it. Thank you so much, and I will see you in the next video. Thank you.